again. Today I'm going to share with you one of the projects I have worked and got some satisfactory results. Basically, this project can be implemented for many user cases. For example, if you want to get multiple PDF from the website and summarize the data and get some insights from it. So basically, this data I'm going to access is the Bank of Italy anti-money laundering sanction data I got from the Bank of Italy website, and I'm going to use this code, the code I write with GPT, to actually, first of all, to save the PDF information to a CSV file. Of course, you can choose to save to CSV or JSON. It's up to you. And I'm going to process this data, get some numerical insights from the data. Because usually if you want to clean up the data, it will take many mundane process. So I wanted to do the text searching, but eventually I think maybe the local LLM is faster and more straightforward. Then you can see here in the first version, I did first of all the analysis without date because I forgot one of the important components of the data is to understand which date one entity is sanctioned. So later I did another round of the coding and with date. Okay, so just to let you know, because the first attempt to try these codes, I always miss something. So I will add that missing piece to the next part. The final part is called option of text searching. I'm saving this as a placeholder, so in the future I can compare the text searching with the LLM model to compare which one is better. However, at this moment, I think because my coding background is not so solid, so if I'm going to implement a very robust text searching algorithm to find patterns, it will take a lot of time. So today I'm going to go over the project with you. Okay, let's check the code. First of all, I'm going to get the data from this website. Basically, if you go to this web page, you are going to see there are some introduction and also a list of the PDF, all the links you can download. Okay, so basically in this part of the code, I'm going to use some, I think this is a traditional way to scrap the information from the website. And these I have done 2 or 3 iterations with GPT and also modify some of the components to make sure it works. And of course, I have also some of the manual adjustments. For example, like here, the pages of the website. I assume it has 19 pages. Okay, but this one usually I would recommend to check the HTML file, check the website to understand which is the range, because making it too small or too large does not make sense and also can intrigue some of the errors of the code. In the end, this code will actually make sure all the information is properly stored in the CSV file. I'm going to show you quickly the CSV file is like this. Okay, usually it has the URL, it has also the text information from the PDF, and this will be the base for us to process. So then let's come here. Okay, so here actually I'm implementing the local LLM. I did download some of the LLM models to my LLM studio in local environment, so I can use this code to access that model. And more precisely, this will do the feeding of the information to the model and get a response. So I think the most important part is about, first of all, set the local server address and then extract the sanction information based on this part, this function. So basically, this function is going to intrigue this chat mode with the model. Okay, so I have my prompt information here to get concise, structured information, and okay, I also said the maximum token is 200 because I don't want it to be too long. Sometimes if you don't set a limit, the model will go on forever and cost a lot of compute. And you are going to wait a lot of time. So, and then here, this is a part of the function that actually gets precisely these information. Okay, so after running it, we can see here. Here is a data frame, which we have. We have partially the information. So what's the problem of it? If you expand the text content, yes, you can get the text content. You can understand it's a very long document. The sanction information, well, it can get some of the information, but it is not well structured. So you cannot easily process in the next step. So in order to separate the sanction info, I need to do more work. So in the next part, I repeat. Okay, I repeat all the algorithm. Actually, I make sure of course I work with GPT to refine this part of the code to actually make sure it will separate the information to the data frame with separate column. Yeah, you can see here. Yes, we have separated them to sanction entity, amount, and also the reason. Of course, you can see here there are not many, not 100% accurate, because you can see here some empty space and some zero amount. So there are some potential problems about the quality of the extraction or the data cleaning. Okay, but at least at this step, we can get the different column, and we can further refine based on it. If you want to check any detail of the code, please pause. Then I actually did the refine and also add the data in the next step. So here, I actually copy the output of the code to GPT to actually let it understand what are the tasks I need to do, especially about the data cleaning. For example, the amount number, most of them are not regular. For example, the punctuation, like the separate of the thousand number 30 in Europe and in USA and in China are totally different. So I iterate several steps to get this part of the function to let the code to clean the data. And I refined my prompt. You can see now my prompt is very well structured, much better than the previous one. Previous one is just one sentence to ask it to get concise information and so on. But now I have different bullet points to let the LLM to get me these information. And about the maximum token, because as a rule of thumb, I tested and tried and saw the maximum token should not surpass 100. So this will speed up my processing time. Okay, so in the process text data part, of course, I iterate several times with GPT to actually make it more robust, because during the testing, this kind of code actually take a lot of time to get the right information you want. So after doing all these improvements, we can see the result. You can see it's much better, because at least you see, okay, at the first, let me show you. First, this is showing that the information is passed which information is passed to the local LLM, and there are some ID, blah blah blah, different information about this instance, and then this is the extracted information, and I think it's a pretty good. Okay, this you can in this way you can check the process. Of course, in your LLM Studio, you can always check the real-time processing of this data. So I'm just going to save your time, because how to set up the LLM Studio is quite easy. You just open it, choose a model, open the server, then you can use your code here to link to the local LLM Studio. So these information are passed to the system and get feedback. But you can see here, like this one, the model is hallucinating. Okay, so after passing the text data to get the feedback, okay, and also more structured data feedback, in the end, we have a very structured data frame, and you can see just from the displayed part, you can see the accuracy improves a lot. And I make a note. It took about 24 seconds for processing 10 records, because at first I actually limit the page searching to one page of the Bank of Italy website. So more or less it got 10 records. And I used this stable code instructor 3B model, and it took 24 seconds. My suggestion is to always choose a lightweight model to quickly test your code and try other models, because I believe most of the listeners do not have a very big machine. So our resource is limited. So let's see how I get the dynamic scatter plot. For this code, I mean GPT can generate like a super fast and very accurate. I think from here I can see a different entity. You can also see the size of the circle to show the amount is quite okay. I think it's very useful for the data visualization. But you can see here some entities have very lousy code, is not accurate. And you can also see some of the sentence. Let me try to check some to you. For example, like this one, because of some of the sanction is to person. So if I want to see the aggregation or to an entity, this data has some noises. Like I do not want to see how much one single person is fined, is penalized. So this just to show you there are some limitations at this point. Then I choose different visualization. You can see that the package I used is Plotly. It's very useful, and you can see all the data, and of course you can zoom in and zoom out. So I also did the yearly trend data. Yeah, it's okay. So basically, I think by here I already finished the first version. The reason I do not focus on the different visualization part is because the package is standard. You can try anytime you want. Yeah, but from here you can see some of the entity name is very strange. Like this one, I believe it is not complete, or it may even be error. So how do I get to the next step? The next step, I wanted to try a different model. So, and also I tried to save the data to JSON file. I did save to JSON file, but I do not find any particular advantage. So eventually I switch back to save to CSV. Okay, the CSV is like before. And in this version, this part is the same. Yeah, until here, yeah. So the same as before. The improvement is in this part. First of all, I get more structured prompt. And you see here, let's see this one. I believe I have done some improvements. Like here, my prompt is about this big. And here more robust, I think. Because now I want to assign a category. Because I want to see, because I know the reason can be 20 words, very complex, or very scattered. Now I want to summarize them in a more compact way, especially in the data visualization. So I tried this, and also the category of reason, one keyword, to put it in the model. And also I changed this model to Mistral 7B. It is a test for this model. And the rest of the code almost the same, but I add some more columns. I had to process. Like I said, every time when I first try the model, I try only 10 records or one page of the website. Okay, so I get a lot of response and also the results from the local model. Eventually, you can see that the quality in general is similar, but later in the visualization, you are going to see there's no error code about error information about entity name. That is improvement. And you can see now the sanction reason. Let's try to check also the sanction reason. Sanction reason in the previous one, you see, is not very organized. But here, you can see it is more structured, the response, like the violation to what and the failure to what. Okay, and category of the reason. Yeah, it's not perfect, but it can already summarize to a more compact way for me to understand which is a category. So reason is a long paragraph, but category is much shorter. I would expect to summarize only to one word, but believe me, I tried, but the result is not so good. Because sometimes even one word, it can use a separate dot or slash. So eventually it's not just one word. So if we want to refine the categorization, it needs more time and more design of the code. So yeah, now I have the new categorical stack. Let's see what it shows. Yeah, I think it's much better. Okay, so I have these different categories. It's not perfect. We can still work on it. But at this part, I think we can have a more compact one because, for example, like here, in here, this is April 2022. The most find reason is for transparency and cleanliness. I think you can get the insight from this data visualization. And I also tried to group by the first word of the category because I think this is too many words. I want to see more compact version. Yes, just by reorganize the data frame, show it in the graph. You can get it. For example, like let's say anti-money laundering and transparency. I think sometimes if you only see just one keyword, this categorization could mean something for your operational needs and for your understanding. Okay, dynamic scatter plot is like before, but I changed the layout of the graph. But you can see here, let me quick run through. You see these names are all company names. At least from what we see, there is no very obvious error code or individual name. So this is a huge improvement. But as I said, if we needed to actually detail in very detail to compare both process, different ways, different models, different results, we need a very detailed descriptive data. But at this point, I think this project already gets some very useful insight. So if I would like to choose to improve, I will improve on this version and use the Mistral 7B model. And you can see here, the monthly trend is like before. Yeah. and also the yearly trend. Yeah. One thing I want to share with you is that during the trial of this code of the graph, sometimes the system does not organize the data in a sequential way. You need to pay attention to it. If that happens, just check the code and make sure that you see sort some functions to sort, to group based on your need or user case. Okay, I wish this video is useful. Today I do not run it with the local LLM Studio, but if you want to see the real-time processing, I'm going to make another video to explain. I wish this is useful for you, at least to let you know with ChatGPT and also VS Code and also LM Studio in local environment, you can already build some very useful project based on the publicly available data for you to get data insight and better visualize the data. Of course, based on this, you can implement many algorithms to do the prediction, to the regression, and so on. Wish you had a fun time, and see you next time. Bye-bye. Everyone, welcome to my channel again. Today I'm going to present you the project that I have successfully run in my local environment to build the AI agents and let them talk with each other. First of all, the tools I'm going to use, first of all, is MLLM Studio. So with LLM Studio, you can download the model that you want to test and also to load it and to start the server. So to let the VS Code module to actually access to the local server and interact with the large language model that you prefer. And then, of course, we need the Visual Studio software installed so that you can run the Python code very easily. And the last and most important thing is that the AutoGen. AutoGen is a package and also the I think a package is a right name because I'm going to import in the Python environment. This AutoGen is I think developed by Microsoft and is very useful for me to actually build this conversation program between different agents. So you need to pay attention to two parts. The first part is LM Studio page. It will tell you how AutoGen can interact with LM Studio. It is very in detail. You can test all the code, of course. The second part is about group chat. Group chat is actually more advanced. So if you check this page of the LM Studio, it gives the example of two agents chats. So it's just two agents talking back and forth. But if you are talking about the group chat, actually the group chat will invite multiple agents to interact with each other. Okay, so I invite you to check these documents. It will be very useful for you to test the code. So let's come to the code part. From the basic, I just mimic what the document says. So first of all, I set up two models. Okay, so if you set, for example, this Llama refers to this Llama model, and also the URL key is the local LM Studio. You can find it, and also the API key is LM Studio. Okay, so basically setting up the different model will be useful when the agents will link to these models. And you can see here the second part is to from the AutoGen import conversible agents. This part is actually defining the different agents and which model it will use. So for me, I always use only one model. But if you want one agent to use one model, the other use another one, it is I think is possible. But you need more configurations of LLM Studio and so on. Okay, so basically at this moment, in my LM Studio, I chose the Mistral model, but here I leave it like this. it can run, because I think LLM Studio will recognize this kind of link directly without actually checking which model you are referring to, because actually the server is working with one model. So when you link to the server, it will work. Okay, so this is the code that you need to run the conversation. It will produce a chat results. Okay, so who will start the conversation? Jack will start the conversation, and it will talk with Emma. And the starting message is Emma, tell me a joke. Max terms will define maximum of the conversation passage. Is like if the maximum is 2, actually you have a, you see here, you have a 1, 2, 3, 4. I think terms, one term, two terms. One term is one back and forth. Two terms is in total two back and forth. Yeah. So you can see here the result is very good. Emma, tell me a joke, and Emma starts to tell a joke. Okay, then Jack says, that was a great joke. I'm glad it brought a smile to your face as well. Then Emma, I absolutely agree. So they're actually doing this conversation, right? You can check and test by yourself. I think the more you test, you can find the different results. Okay, so at this point, we have mimic the official example and test it with LM Studio. This is okay. So I want to go to another example, which I tested. To actually, I think if we want to apply this package of AutoGen to other use case, we need to have it in mind. For example, for me, I would really like different agents to build a financial analysis team to actually tell me if the stock is underpriced or overpriced, and if I should buy it or not. I think there are many examples on YouTube. You can also check, but here, okay, I just test what's my initial construction of this team, and to let them talk as a group. So this code, at the first part, I also define the different model, but now I'm more specific. I want to define the Mistral model that I'm using. So just to make sure that I understand the whole picture. The other two, I leave it here, but it does not make any impact. If you want, you can delete it. Okay, so about the agents. First of all, I created more agents. I create a team head of the team. The team head will do a lot of job. I just describe them all here. I think my code is correct, but if I'm wrong, feel free to mention it. Um, and here I actually describe the job it will do. It will be the leader of the team of stock analysts. You instruct the general analytical framework and ask analysts to process data and give investment strategy and suggestions. In the end, you combine opinions from both data analysts and the news analyst. Okay, in this part, I think the better you define the agent's role, the better it will run and get results in the later stage. So I also have the analyst on data, analyst on news. So basically, one will check the data of the stock, financial data. I did not specify, but if it is recommended that you specify in a more detailed way. I also ask it to actually analyze trend, plot a line graph, and so on. Then about the analysis on news, I ask it to check the news and also give some summary and also provide the recommendation. So in the end, I want the team head to summarize. So go to the next part. The chat will initiate from the team head to the analyst on data, team head to analyst on news. Okay, so let's check the results. Maximum turn is 2, so I expect that it will be 2 back and forth. So yeah, the message is analyze Apple stock. Okay, so basically the team head actually first talk to the analyst on data, give some feedback. I think this was the results we get from the model itself because it was trained on massive data sets. So actually, the model actually figure out this by itself. It I think it have to be not 100% accurate. So, but you can see here it structured this information I think very well. You can see historical stock price, earning per share, and eventually it gave the conclusion that a solid long-term investment opportunity. Okay, it looks very good. And you can also try in your local environment to check the whole response. Okay. Also, the if you check the LLM Studio because you are running a server, you can see the conversation and all the log. It is very satisfactory because previously I tried. If I remember correctly, is the UI version of the AutoGen. Actually, the configuration of the different agents and so on. Of course, you can do it in the browser, in the web browser, but it's I always meet some problem. For example, if the prompt is just one word, and the feedback is just two words, it's not working. But in VS Code with Python, Jupyter Notebook, it works well. Okay, so let's see. First of all, here, the first response from analyst to team head. Oh, okay, then team head says, actually, the team head is working like furthermore. He actually tells the analyst on data to pay more attention on the market developments and so on. So it's not like okay, I get your advice and I summarize your advice and that's it. Okay, it actually want to dig more to explore more with analyst. So yes, analyst also give additional comments about add additional information about the stock price, investment potential. So actually, it stops here. Okay, so when I reach this point, I realize that actually there is not another feedback. So the conversation is complete. But if I want to get the conclusion from the team head, it does not give. So I need to configure either the conversation terms or I change the description of the team head and make sure it works better. Okay, so the is still prompt engineering as a basis. So the better you engineer the prompt, the better you get the results. So the system stop here and goes to the next conversation. Is the team head to the analyst on news. Okay, so at this point I realize it's a separate chat. Okay, so it asks the analyst on news to check. Okay, and it says I'm an AI language model, don't have real-time access, of course. So it actually it gave some general analysis based on the information it has. For example, like this information is dated in 2022. So from the pure conversational point of view, I think it's working. Yeah. Then the team head tells to the analysis to news, in addition to the analysis above, it is crucial to consider both quantitative and qualitative factors. Uh, in my opinion, this is not very necessary because I would expect the team head to combine these two parts. Because the analyst on news is going to focus on the qualitative part, and the analyst on data is going to focus on the quantitative part. So that was my original design. But okay, so it asks this. I think in the future I need to better refine my prompt and the description of the role. Okay, so analyst on news says, okay, it actually does the work it asks to. Not only analyzing the news, but also to give some comments about the data and also examine the KPI and so on. And also it did the competitive landscape, management efficiency, and industrial trend comments. Okay, so actually the analyst on the news is doing the job for the team head. You can see here the team head should do the final comment. By combining both the analysis, you can develop a well strategy. Okay. Uh, okay. But eventually you see this one, the model becomes very prudent because it suggests that you should consult another financial advisor. So technically speaking, it is not doing its job. Okay, but you can see this flow of conversation is going, so you realize there should be some more adjustments, either with the prompt, with the max terms, job description here, system message, I call it as job description. Okay, so then I further refined the code. I tried the user proxy agent because I consider user proxy agent is that the user inputs will actually influence the conversation. So I set up this user proxy parameter according to the documentation of the AutoGen. So you can see here, there are some informations here, like a name and so on. So then now I start a group chat. So the group chat is going to actually involve multiple agents here. For example, I have 3 agents: the team head, analyst on data, analyst on news. And also I have max in around 6. Because I think there are too many agents, so maybe I need a longer conversation to get a meaningful result. In the meantime, I'm trying to input my prompt. Okay, so it's not like previous version. Actually, I write the prompt in the code. Now I want the user input, so I input the prompt. Okay, the conversation starts. You see the user proxy is the user, me, will start the conversation. And conversation to the manager, and so the manager will go to the group chat in this sequence. Okay, let's see. Okay, the system take my input as the user proxy to chat manager conversation, and then analyst on data. Okay, says okay, I'm doing the blah 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 analysis. Okay, and yeah, it talks to the chat manager in summary. Okay, Amazon stock blah blah blah. Okay, it does not give a very precise conclusion because it says you need to do further analysis. So it's not working very well. And then it says that it is important to keep in mind the past performance is not a passion. I think this is like a disclaimer from the banks, investment banks. Yeah, it's quite interesting. Yeah, so then the group chat select the speaker field to resolve the next speaker's name. I think there are some issues with the naming of the agents. So if you see this kind of message, I suggest you to actually check. Actually, the next part, the conversation goes to analysis of the news. Analyst of the news, it says, yes, you're probably right. It's important to remember historical data. Okay, so it actually takes the as message of the disclaimer, so it does not do much job. Okay, and then it says absolutely providing clear. Okay, it's like not so useful, right? It's a writing disclaimer. So at this point, you can see the group chat actually goes, but I suppose there should be more definitions, like either in my prompt or in the structure of the team and of the job description, right, to configure better these agents. But as a start, I think I would say this is okay. Okay, this model works, and I need to further refine to actually do the jobs that I intended to have them done for me. Yeah, so this example stops here. Okay, so just a quick wrap up. You can do 2 agents back and forth conversation, or you can have a group conversation. Okay, so the next example, for the models, the definition are the same. I did not change. Uh, Actually, you can see, like the previous example, I ask the analyst on data to plot, to analyze the trend. Of course, it cannot. Okay, so I need to further work on it to see if I use some resource code to let the agent to act on to draw the graph based on the data, or I should I just should test the different alternatives. But at this moment, I keep on going. So the job description actually, I did some improvements, some adjustments, and I'm inviting a coder and a tester. So, in my opinion, if you are going to invite a coder and tester to a conversation and you want them to write the code and test code, of course, there are many use cases that you can check on YouTube. But at this moment, if you only define it here, it will not work. I'm going to show you. So this part is the same. We are going to have a user proxy. Yeah. So just a reminder, whenever you see there are some comments here, you can stop the video and check. Some of the comments I leave the error message just for future check. For example, the original proxy code actually it asks for the Docker environment. I have never used it, so I want to skip it. Okay, so I need to set here user Docker force. If you want to refine this code, I think first of all you need to understand the document of autogen of a specific function, and if you have some difficulty to modify the code, you can ask ChatGPT to help you. But remember, ChatGPT has limited capability. So the next part is still the group chat, but here now we have the coder and the tester. Okay, next round 6. I manually insert my prompt. Okay, and here, I think you need to pay attention because the system will recognize the whole part. The message should have 2 components, okay? A complete one. Not only like this, the text information. You can try because you are going to see the error message. So I'm going to start the chat again. Okay, analyze Tesla stock. Okay, the log actually says group chat select a speaker field to resolve the next speaker name. Yeah. So there is some error, but here the team head starts to ask the analyst on data. Can you provide me the Tesla stock price and share the recent news about Tesla? And ask the analyst on news to share the news on Tesla. Both of them are working. Okay, so first of all, it promised that it will actually work and get the information. Yeah, also the news analyst on news, and the team has based on information. I would like to remember buying Tesla stock at current due to the strong financial from the earnings reports. I would say I don't see much data here for the team had to analyze. For here, the news, yeah, the news is positive. Okay, surpassed the expectation earning. Okay, so it makes sense. But the capability of individual agents, like I said before, we need to enhance their capability. So this is a part of the conversation. Actually, the channel manager actually talks to team head. Team head talks to analyst. Then we go to the next part. Is the team head to the channel manager. Okay, give actually a response, right? It's very structured. I like it. Introduction. This is which company, fundamental analysis, valuation multiples. I think if you further modify the code, you can get quasi professional report from this model. Okay, then you can see here. You also did technical analysis and also news analysis. I mean the accuracy because it's not a link to the third-party API, not getting the news I think is not 100% reliable. But the next attempt in the future, I would try to like use a Y-Finance or use the Google News Google News package or API to get such information to the model and let it analyze. Okay, so at this moment, we are always utilizing the knowledge base of the local large language model. Okay, so pay really attention to this. If you try to have fun and to test the model, yeah, it's okay, but to really use it, be very, very careful. Then here, uh, okay, you can see this is different from the previous one, previous examples because we have more agents and actually we have modified some of the this job description of the of each agent. So you can the result has some improvements, I would say. And then we go to the next part. Actually, the team head. Now it's your turn to play a role. Which of the following roles would you like to assume? And what instruction or question would you have for the team members? Yeah, so it will select them and provide the instruction to ask question accordingly. Okay, so yeah, now analyst of data says diversification is an important thing and so on. This is quite general discussion now. And the coder says the manager, yes, diversification is okay, but the coder is not doing its job. So there must be some problem with my setting. Okay. In summary, it suggests a diversification. I mean, the primary job of the coder is to code. Okay. So actually, uh, okay, let's see here. The coder starts speaking again. Well said. Okay. I'm not sure which agent actually talks to this agent before because I don't see it here. Anyway, you can do different tests to check the workflow. There is also a very clear documentation of the autogen. I recommend you to read it, okay, because I'm also still learning. So in the next part, I actually make my prompt very, very complicated because I see the result is not so well. I said analyze the Tesla stock, starting from the team head to get a general plan of the task, then analyze on data to discuss with coder and tester to run a functional code to get analyze stock data. Let me see if I have a chunked version. Yeah, it's this one. It's easier to read. Analyze Tesla stock, starting from the team head to get a general plan of the task. Then analyst on data discusses with coder and tester to run a functional code to get analyze stock data and financial data and to give advice to the team head. Then blah blah blah. So now I give a very very clear instruction to the group. Let's see how it goes. So it takes the prompt, okay, and pass it to the chat manager. Okay, and the team head starts to talk back to the chat manager that I'm a team head. So yeah, how these agents will work. Okay, it's very well structured, right? So it first of all says that it will assign the task based on the expertise of the team member, three team member, very well organized. Okay, and it says using tools like Bloomberg, Y-Finance, Fred. Here I do not provide the Fred API or the Bloomberg API, so this is a very good assumption, but not very realistic for me to implement a free version on the local environment. Then once they complete their analysis, I'll combine the insight and give a report. Yeah, it's very good. So report, the outline of the report, it also describes, is very comprehensive. I like it. But you see here, group chat select speaker failed to resolve the next speaker's name. This is because the speaker selection call returned nothing. Okay. So I think this problem repeats In the future, I need to check did I misspell the name of the agents, or there is other problem. So let's keep on going. The next part, actually, I think there is another solution to this kind of missing next speaker. It will pick another speaker based on the chat. There must be some logic behind. If you want, you can further check. So basically, now analysis on data, I think is based on the plan. It starts to check to talk with the manager. Okay. And the team leader, I fully understand the analytical tone and follow the objective. So there is a kind of mix up because analyst on data is not a team leader. Okay? He understands the job and starts to work as a team leader. So, but some of the part like this part, yeah, you are actually repeating the previous conversation. Not very useful. Okay, so now the team head to the manager, and the team leader, my primary goal is blah blah blah, define blah blah blah, ongoing monitoring. Okay, sorry. Yeah, here. It describes its goal and so on, but not very concise, not very useful to actually deeper with the conversation. Then failed to resolve next speaker again. So still, this analyst on data chats with the chat manager. Okay, so it did what was already there, and he is taking responsibility of the team leader. Okay, but from the information of the step, you can see there are also some errors because here you see from point 1 to 5, then from 1 to again. So I think there is some problem with interaction with local LLM because the description of the task is too complicated, so the system cannot handle it. I see this kind of error sometimes before, just during the conversation with Mistral model. It will start to hallucinate with different code. Does not make any sense. Okay, so you see here, it tries to make up a lot of numbers, but they do not have any meaning. So at that point, the local server continues to run. I manually stopped it. Okay, so you see the error message here. This is part of the server log. You can see I take a screenshot. The server log actually shows infinite numbers. Okay, so that basically says this project has to be stopped. We need to change either the model, either the structure of our agents. Later, I try another way. I do not manually insert the prompt in this window. I actually define the message to feed to the system. Yeah, I think this is another way to feed the message to the system. But somehow it actually only gets okay, it asks my input if I remember correctly, but you can try. This is not a very big issue. You can either write your prompt here or you just manually input here. Okay. So at this stage, it starts a group chat again. Okay. Select speaker field. Okay. So at first it gives some comments. Okay, so but here we have some improvements. I will now step aside and let team head handle the analysis with using historical data. It's not 100% correct because I do not want the team head to do anything with historical data. So you can see there are more complicated configuration with a more complex conversation. That will be needed. So to the next part, let's see the team head to chat manager. Okay, to provide the analysis, I will do a combination of formula and technical analysis. Okay, it's good. both a data analyst and news analyst. Okay, it's going well, and it starts to fundamental analysis. Okay, it tells you uh, part of the information, and also some subjective conclusion here. But the problem is that the two analysts have not said anything. Yeah, so this is I don't know how to define a hallucination or what. Uh, Here you can see the team head to the chat manager. Okay, disclaimer, blah blah blah. This is kind of a standard term again. So representation. Okay, subject to what? Okay, the group chat select speaker field again. Okay, so if it failed, actually the talking, I think is like the LLM one side output. It does not say who is speaking. So I will leave this kind of issue in the future to resolve. And at this moment, yeah, this is actually the one of the result of the server log. It shows a very messy picture. So just to wrap up, we have some issue remain. For example, this error code and the insufficient assignments of the job to different agents. And in the end, I think we can improve in the future. Like I said, the prompt, the agent's job description. I see it like this, and also the detailed configuration of the usage of AutoGen. I think we will find also tons of example on the website. The problem is that most of the example on the AutoGen documentation is based on a OpenAI API or other uh, structure, which you have to link to the API of the online LLM model. But if you are going to do with a local LM Studio, you always need to do some tests to change the code to adapt to the local large language model. Yeah, I wish you find this tutorial useful and happy coding. If you have any question, feel free to leave a comment and I'll reply and also to have a discussion with you. So let's advance in the AI agents creation. Have a nice day. Bye bye. Hello everyone, welcome to my channel again. I'm going to show you another project that I have already done and see some very useful results. First of all, I would like to introduce this tool to you. It's called Streamlit. Basically, it is a set of open source Python framework for data scientists and AI ML engineers to deliver dynamic data apps with only a few lines of code. So I find it very interesting because the deployment of this open source Python framework is just by pip install the package and you can actually dynamically show the data in a web page. By the way, if you are already familiar with the different packages in Python, you know that you have millions of ways to plot the data. But this one is interesting because it can deploy also in their website. I think in the app gallery, you can see here, there are lots of projects by different people, and you can try each of them. For example, this one. This one is showing you a different type of chart. Okay, so example, you can see the code below and you can see the graph above. So basically, there are so many possibilities you can realize with this toolkit. For example, this one pretty map, I find it very interesting because you just input the name of a city and you are going to get a very cute map. For example, you see this one. Yeah, I think it's Macau. Yeah, you can see the map in a very interesting form. So without further ado, I'm going to go to my project. So my project is to show the stock price dynamically. So the idea is that whenever I choose a different the stock label, for example, AMD, right? I'm going to see the candle chart and also the 30, 60, 90 days moving average of the end of day price, just to visualize the stock price. Okay, this is a quite a simple task. I mean, you can do it in many different ways using Python package. But here I just want to make something like a dashboard. The dashboard, I make the upper part. One upper left is about an individual stock. Then the SP 500, the entire SP 500 performance, and then on the lower side, I'm using some sample macro economic information. For example, this one is US GDP and the interest rate. Of course, you can also change this to your US GDP growth rate to interest rate if you think that makes more sense. Or on the lower right side, you can see the US inflation and the unemployment rate chart. Okay, so basically I want to have this kind of a dashboard to understand the current situation. But based on this, you can add millions of other possibilities to add macro, micro, and even I think in the future maybe we can also explore the possibility to dynamically show financial performance of individual stock. So you can have a comprehensive view of the stock, general stock market, and the macroeconomic situation. Okay, so how do I get here? Basically, I need to have four Python file. This is the first time I try to build a few Python files and make them work together. Okay, so important thing is that you make them in the same folder, and eventually, if you want to run this app you build, you need to streamlit run main.py in your folder. Okay, so I will not spend time to explain to you about how to run it because in the documentation, in the example, there are a lot of description. It's very clear. And if you want to type some prompts to our system, usually you go to the terminal, this part. So basically, let me go through all these documents quickly. First of all, I have the let me show you the different sub-py documents. Okay, the first one is a thread. Okay, for security reason, I have already deleted the API key. You need to get the API key in Thread website. It's very useful. You can get different macroeconomic metrics, the different data sets. okay, like GDP and the federal funds rates and so on. It's very useful. Okay, if you interact with ChatGPT, you can get to the code very quickly. And you see, first of all, you need to be able to import this thread API and also to fetch the dataset. And also you need the Streamlit at this moment. I think the most important part is about this part. To get this to work with the whole application. This is my assumption because I'm not an expert of coding, so I suppose this part serves to link to the app. Then we see the next part is about stock.py. Okay, previously actually the code was more complicated, but I got a lot of error. For example, I wanted to project the stock price for the next 30 days and plot them all together. However, during the process, because there are many definitions, many definition of the functions and the algorithm, it makes the file very cumbersome and complicated. So eventually, I get this rather simple format, I think, because you can see here. Let me try this one. Empty stock. Let me check. Yeah, you see, it only goes to the available information. Okay, 2024 March of the data source. So it does not add the prediction data here. Okay. But I mean, you can do a lot of work to modify, manipulate the data set, but the main idea is here. First of all, to use the Y-Finance, this package, to actually to get the data from different ticker of the stock. Okay, add moving average. Of course, this is to have the moving average line. You can see here. Okay, and you can also cancel some of the data and you see the moving average. Yeah, in this way is more clear. And of course, I make the prediction price this function. I believe this function works to predict, but eventually I failed to put them together, to put in the graph together. Okay, so this is the stock.py. Eventually, let's go to plot. The next one we go to the plotting.py. In this part, I was trying to actually define different plotting function to eventually be used in the main file. Okay, so in this part, I think you can see basically we have two plot function. One is to plot economic data. The other is to plot the candlestick with moving average. Okay, so the most important part is that I'm using the Plotly, this package. I think it's very useful. Like you see, the display of the data is very dynamic. You can zoom in, zoom out, choose different data to show or not show, and come back. Okay, yeah. So in this part, I think the most important part is to debug. Because if you use GPT or Copilot, you can get the code very quickly. But I always use GPT. I do not have Copilot, so I need to check with GPT each time with a part of the code and the error code to debug. Eventually, in the main file, it will import the necessary package, import different functions from the different py file, and make them work together. So in order to get the Standard & Poor's 500 symbols, it actually goes to the Wikipedia page to get the list. Then, of course, you can see here the sidebar here to select the stock symbol. Okay, it serves to give you this choice window. And And the next part is actually to import the different functions of different Py file and make them work together, okay, so that you can check. I believe there will be some more ways to clean this code, make them more streamlined, more easy to read. But at this moment, I get this result. So eventually, this is the application that I get. You see it after I run this code, like I showed you before, stream it, run main.py. It actually jumps to this local server URL, and you can see the result. I think it is okay at this moment because you see different data you can choose, and it shows correctly. Yeah. And I would say this is a partial success. If you want to implement more complicated algorithm and to see more complicated results, of course you can try. And there are already some very good examples on the website you can try. I believe you will get more insight from there, and I wish my solution at this moment will be a start point for you to refer to. Okay, so if you have any question or any doubt, feel free to leave a comment. So I'll see you next time. Wish this will be useful for you. Thank you. Hello everyone, welcome back to my channel. I wish you had a great summer. Now, I would like to take this opportunity to share with you the agentic tool that I have been using lately. It's called Agent GPT. You can see the website in the URL box of the Chrome browser I'm currently using. I'm recommending this tool because it is very easy to use as agentic workflow. Okay, so basically, I think two features of this tool are really attracting me. First one is it shows the tool calling process. The other one is that it is built under the agentic structure. Unfortunately, I have not yet seen the source code or examined in detail of the functionality of the website, but so far I have get some useful results. For example, now if I want to do some web search, I would like to use it to like a starting point, to understand some of the search results. So basically, it's very easy. You just use your Google account or you create an account, and you just log in. For the free tier user and also the paid user, you have different plan. Okay, so I'm just going to show you two examples, just like it is like a comparison of the two scenarios. The first one on the left hand side, I would like to get 10 latest AI news in Italy. On the right hand side, I'm going to get 10 latest AI news in general. Okay, so you just input here the name and the goal. Okay, those fields are mandatory. You just insert and click run, it will start running. Okay, so you can see the first one is actually add a different task. This is very nice. Okay, it is based on your prompt. It creates a different task. So for each task, it will call different tools and to just to get a job. Okay, so you can see on the right hand side, it actually also called the tool to do the code. Okay, to get to write the code. So you can see some code is written. In my experience, if you ask it, for example, now the free tier, you only have the GPT 3.5 version. Okay, so if you wanted to display the graph to output some of the data analytics information. It's not like a GPT 4.0 or GPT 4 where you can see there is a more robust tool calling and output of the results. But here you can get most of the text results and also some coding. You can also ask it to do some coding. Okay, so let's see. Now it already finished. Okay, finished all the tool calling and the research, and you see there is a max loop threshold, and you click summarize, you are going to get the final result. Okay, so it will give you, yeah, cite the source. This one I like it very much, and also provide the information as you asked. Okay, so just a quick review from the beginning. Okay, let's just review it again. So basically, the first does on the left-hand side, you can see there is a stage where it added a lot of tasks. Okay, so it will execute each task. For example, the first one is search the web for AI news in Italy, right? It actually executed it. Okay, it's not 10, right? It actually gets 7. So I guess there could be some improvements. And you see the sources of the web search is quite wide. Okay, it's not only from like some renowned news resource or very well known news resource. Okay, and you see it continues with different tasks. Okay, and you can see this one: visit the top news website in Italy and look for AI related sections. This is kind of like a more detailed task. Okay, so you ask for the AI news in Italy, so it will go to the top news website to look for the AI related section. Okay, this is I would like to say is improvement of your prompt, and actually embed this prompt into a more detailed task so it can run. Okay, then we can see here, read the latest news articles on Italy. I see a little bit repetition here because like the different tasks are aiming at the same thing, just in different way of saying it. Okay, the good thing is that for the web search, each time it will also give you some of the source, the news of the source, the source of news. Sorry, and later we are going to summarize, and you see in the summarize stage, it will get all the information that gathered above. However, we can see that it only summarized five news, and each news you have 1, 2, 3, 4, 5. Everything is get from the web search result. Of course, because I'm using English, so most of the websites are still based in English. Most of them, like this one, Agenzia Nova. You can see it has a name, Italian name of the website. Okay, so it can also search some of the information in the Italian website, but mainly it is bounded by the language used in English. And you see, it also gave some of the suggestion to explore the latest news. You can visit the following website. Okay, so it actually gives you some additional tips that you want if you want to explore the topic. Okay, you can click the website to check. So far so good. Okay, on the right hand side, you can see the result is slightly different. Okay, you can see they actually have the different tasks like open a web browser, search for the news, filter results, show most recent. It looks fine and much better than left one. Compile a list of the 10 latest AI news article. Yeah, all looks good, right? So it actually first one is to let you know where you can find the news. Okay, then you start to search search for the latest news and find some articles and always cited, right? You can see it's very good that it actually inquired the MIT website. So maybe this web search destination is very relevant to the task assigned. And you see here is the filtering of the article. Okay, example code. Okay, I'm not sure if this is what I really want, because I wanted to actually filter the information already gathered, right? So it's like a quick filter of the data frame. However, it offers the a code. I'm not saying that the code is not useful. If you want to run it in your environment, you can try. Okay. So it actually finished here. Okay, so this is just example code. You can see that this is not actually linked to the result already shown. Okay, so I believe this one is useless to actually get the to filter the existing result. But the filtering step actually happened because in the next to calling, actually it compiled the 10 news. Okay, so I guess it already had some running and the ranking of the page in the backend. Eventually, you see here, you get news. It looks much more abundant than the left one because the range I did not limit to the location like Italy. And in Italy, there is also a language barrier. Okay, most of the large language model are focused on training English contents. Okay, so the Italian contents are not so easy to interact with the large language model. Okay, so more or less the same. As I said, it actually does different tasks and summarize. Okay, yeah. The summarization, of course, you need to initiate by yourself. Let's see the summarization part. First of all, you can tell latest news. Um, it actually shrink down the size of the news, the number of the news. I asked for 10. It gave me the summary only 5, and also additional suggestion on where to find the relevant information, and also Python code if we want to use it on our hand to filter some of the information. I mean, if I already get a data frame, it will be much easier, right? And I can rewrite the code. But if you just show here, I think it's just an indication that I could try it, but that's not a function for anything here. So then it actually gave me the compilation of the 10 news. Okay. So in my opinion, some of the results have some repetition, right? Because like here, you don't need to, because my question is not to ask you to provide me with the source so I can check the source. I want you to check the source and give me the result. Okay, so I think there's some redundancy here of the reply. But luckily, in the end, I can see there are different information in the end. Let's try to click one of them. Click a link. Okay, there is the actual page. Yeah, but yeah, because I'm not subscribed, so maybe some of the content I cannot check. Feel free to check to verify if some of these links are real and if the contents are really cited. Okay. So I mean, using this tool can give you a quick start, but eventually, I think we need to, if we use a better model, for example, if you build a model by yourself, you call the GPT-4 or more advanced models, you can get better results in your local environment. If you rely on this tool, like the online version of the agent GPT, if you pay, of course, you get more of the advanced model. You have less restriction on the maximum loop and so on, and maybe you get better results. Okay, but in my opinion, this is a good tool for you to try. And also, if you want to get from this model, I think one is its design. Okay, this is a tool calling and agentic workflow. But here, notice one thing: you don't see one agent talking to another. Okay, but it's called agent GPT. I assume that it is agent that get a different assigned task, detailed task, and solve it, provide the results. Eventually, you have another agent to summarize all the information. Okay, this is just my assumption. Feel free to try it out and let me know how you think about it. Okay, so wish you like this video and wish this tool will be helpful for you for web search, and see you next time. Bye bye. Hello everyone, welcome to my channel again. Today I'm going to share with you one of the projects I have done in recent days. Basically, this project was designed to interact with ChatGPT, another large language model, to build a project with, first of all, a local database, simplified as several CSV file and PDF to contain the information that is useful in my domain. And then I'm going to build query workflow with LLM Studio and also the LangChain. However, after interacting with the GPT, it does not understand the structure of LangChain. it actually diverts me to another sort of workflow to make my query work. So although you see the names of different Python file is called LangChain, I leave it as this just to remind me that this is not LangChain, but it can be a good start point to understand how to make your query to the large language model better or more efficient. In the future video, I'm going to focus on the LangChain documentation and to really utilize the LangChain workflow to improve our large language model query and get better results. Okay, or as the famous method, RAG, just to better utilize large language model. So first of all, let's go through this file. Just want to share with you on the left-hand side, I have two TXT files. I make a record. The first one is about the key points. I actually made a lot of notes, okay, about the different tests, how I improve each file. If you find it useful, you can check it or pause the video and check it. Yeah, and here I'm going to focus on the step. The step part, I actually ask a large language model to better interpret my final result of the of the Python file. So basically, the project starts with first part one. Actually, I created two Python file to get the fine history, which were the history where the GDPR, in the EU region, how the GDPR law was enforced to fine the different corporates. Okay, so there are two information sources. First one, I can go to Google News. Okay, this is a package. I like it very much. Can get the dataset very efficiently. The other one is Wikipedia. In Wikipedia, you can always find some summary, and it is quite useful, more structured data. And the last thing is about the GDPR law. GDPR law PDF is pure text, just the wording of the law. And by running these two Python files, we are going to get these two CSV files. One is called the GDPR Fines Wiki, and the other is called the GDPR Fines. This one is from the Google News. You can modify the code as you want, because now I limit the search result just to make it more efficient. Otherwise, for example, if I want to query like 1,000 entries, it will take a lot of time. But for the Wikipedia page, it's faster. Usually here I have two CSV files with the data that I want to feed into or interact with the large language model. I think is more updated and more focused on the use case that I want to implement. Then about the GDPR law, I actually downloaded the law PDF file and save it here. Right, if you can check it on Google and download it from the GDPR website. It's very easy. So then I go to part two. The original idea, like I said, I wanted to use LangChain to interact with large language model, but I take the shortcut to use the LangChain documentation, and my idea, I feed it into large language model. It cannot understand how to use LangChain. So I suppose that either the LangChain methodology is too nuanced to the large language model, or the large language model just cannot logically decipher the new methodology in the coding. Okay, like LangChain, the different mechanism to interact with large language model. But I followed it and step by step get the results. You can also check the test versions in the past. I'm going to show you one of the example here. Here So basically in this page, you can see on the left-hand side is the standard LLM Studio query and response. It's very simple. Just give the prompt to the local large language model and get a response. On the right-hand side, it was a mistake here about the HTML file, but actually the prompt to the system was part of the law, which is more relevant to the to my query, and feed both the relevant law part and my query to the large language model to get a more comprehensive response. Okay, you can see the difference. But I can tell you during different tests, different trial of my code, I fixed a lot of bugs. For example, sometimes if you do not use the efficient query method to link your query to part of the text message, some of the query, some of the matching mechanism will just fetch the first paragraph of the law. It's not going to get the most relevant part. If you are interested, you can check my past record, okay, in the test versions. Otherwise, you can go directly to the final version of launching LLM Studio version 5 or version 4. So let's focus on this final version here. Okay, we have the dataset ready, and we have also the PDF of the law ready. So now we're going to go through the project. First of all, importing the different packages just to make sure that your code will run. The first part is to download the PUNKT. It is a data package for tokenization, for sentence splitting. Then my code actually define a simple vector, this class of simple vector. It defines how to store the document embeddings and the text documents. Okay, and especially about this part, about the search, this function of search. One time when I tried the code, I actually ignored some of the variables. So even if the code can run, sometimes if you miss feeding some of the variables to the different function, you can get a result. But it is not a complete circle, complete workflow. So I really recommend you to check that every variable is utilized and to make sure that they are fed, they are working in the workflow correctly. So in the next part, we are going to load the pre-trained, it's called pre-trained universal sentence encoded model, okay, from TensorFlow. Okay, it is also part of the very important part of the code. Then this code defined different functions. For example, you can check it one by one. The embed text function converts list of text chunks into embeddings using this universal sentence encoder. Okay, so basically, yeah, this is I think one of the most important parts of the whole code. Then there is load CSV data. So this load actually all the CSV data to put it in one data frame. It is not a very, I think it's may not be the best option to put them all together, but I just want to feed as an integral part of the data. Okay, then I also change the CSV to text, because in the model, if you are feeding a data frame to get embedding, okay, it is not working. You need to transfer it to text. Then, okay, this is the load CSV data and also CSV to text. About the CSV to text, really pay attention to the encoding. If you get any error, you see some result are not good, you need to change it. And one thing I want to mention about like here, like load the CSV data. If some of the data type is not recognized by the system or by the code, you need to change it, okay, or to specify it. Then we'll go to the next part about load and extract text. So basically, at first I only have the PDF as text information. I did not have the, I had also the data frame, but eventually if I want to make sure all of them are processed, I should both process the PDF and also the text TXT file. Okay, this is just to make sure that all the files can be passed to this function, and the text can be extracted. So this serves as extract the text from the file. The next one is NLTK sentence splitter. It actually splits the text into sentences using the NLTK. Okay, so then it will load and split the text, into sentences. Okay, so all these functions seems so complicated, but eventually I'm going to summarize the whole workflow later, so you can have a better understanding of it. So basically, each function will quote another function to give a periodical result, a sectional result. So you need to really pay attention. Okay, so basically, let me just repeat here. TK sentence splitter is going to return the tokenized information, and the load and split text is to split the document text into chunks. Then here, I think here these two functions were only one function, because at first I only passed the PDF information to set up the vector store. Okay, it's like a query database. But later, when I realized that the data frame is better to convert to text, then pass to the function to get another vector store, I chose to create two functions just to make sure that I understand I'm doing two conversions from text information to vector store. If you find it too complicated, you can of course change this part, as long as it matches your user case and make your code better. For me, I just keep it like this. So basically, the most important part is that for after converting the text information to vector store, okay, it will return this vector store as a result. Then there is the function to define a generate response function. Actually, this one is the interaction with the local large language model. It follows the pattern of LLM Studio. First of all, I want to say the reason I set the input variables as two vector store is just to make my workflow clear, so I understand there are two vector stores utilized. So my query will match, first of all, the PDF of the law, the information. Then it will match the data frame I provided, but not directly. They are going to check on the vector store. Okay. So this query embedding is going to, first of all, transfer my query to embedding, then find the similar documentation from the respective vector store to find the most similar information from the two vector stores. And eventually the prompt will combine these two and with my query. Okay, so this will be the formal prompt to the local large language model. Here, I want to emphasize the interaction with LLM Studio is nice, is local, is safe. Okay, at least for now, I think it's safe. But now I do not see a very comprehensive tutorial on the internet to let you know how to avoid different mistakes, how to debug everything. So you need to try. One of the way is to actually focus on the completion, this client chat completion, and create a function. Okay, you need to check here. This is a documentation of the explanation. You can copy this part to your local file so you can check it quickly. This is a very comprehensive explanation. From here, I actually debugged several things. For example, I set the presence penalty and the frequency penalty to avoid that in the end. For example, if I have a max token of 3000, the system will generate some random code or repetitive code tokens after 500 tokens. So that is not what I want. That is very messy and not beautiful. So here, as you see in the document, I actually used both the frequency penalty and the presence penalty, these two penalties, as the max value of 2 to avoid the system generate the error code as repetitive nonsense characters. I think both penalties work similar. But just to avoid the error I saw, I just put both of them as maximum 2.0. Okay, so like the frequency penalty, it will penalize new tokens based on their existing frequency in the text so far, and the presence penalty will penalize new tokens based on whether they appear in the text so far. I think their functions are very similar. Of course, you can try different variations. At this moment, I put all of them at the maximum value. Also, I checked some of the Google. I searched in Google how to debug this issue of repetitive characters that makes no sense in the LLM Studio when we query a large language model. Some people say that we may change the temperature because your temperature is too low. It will limit the performance, and for example, my use case, I would like my result very precise. I don't want to get more creative output because I am analyzing a lot of GDPR. I want to get the relevant output as a report that I care about. So here, my use case actually defines that I should limit the hallucination and creativity of the model, so I cannot loosen this parameter. Just want to share with you this point. About maximum token, however you change it, the result does not change very much because like the Llama 3 8B instruct model I use, it will more or less stop at 500, 600 tokens every time. Okay, so the output window is quite limited. I mean, we can explore how to expand the output range, but at this moment, after multiple trials, this is 600, 700 is the maximum token size I can get from the response. So in the end, if you want to try different maximum token threshold, you can try it. But as my experience, there is a limit. Okay, with interaction with LLM Studio and the local models. So the next function here is to save the record, okay, to HTML file. I really find this kind of function very useful, and the format, you can define it very easily, and GPT can actually produce very high quality code to make sure that the HTML report you see is well organized. And you can see also here we can quote our queries, answers with line breaks, and so on. So eventually you are going to see the HTML file very well organized, so you can utilize it to view your results. In addition, I also save a HTML file of the save debug info. The reason I want to see this one is that I want to see the flow of the whole Python file, the whole program, because from there I can check, for example, if some steps has some problem. For example, if the chunks of the text is empty or the vector store is empty, I can better debug. Of course, for professional debugging or the traditional way of debugging the softwares of the code, I think you can find many useful resources. But at this moment, I find this quite useful, so I use it to save the debug info. Okay, so you can see the different variable in each step. Like this one is about the text chunks. This one is about vector store. Later I'm going to show you. And in the end, here is the execution sequence. So basically, you can see first of all we load the CSV file, then we convert CSV to text, then we split the documentation to chunks. Okay, and we actually have two operations. First of all is text chunks, is raw PDF document to text chunks. The other is the dataset, TXT version of the dataset split in chunks. Then we get the vector store one for the text documentation or the PDF. The vector store 2 will aims to store the vectors of the data text chunks. Okay. I know I repeat some of the wordings here. Maybe I can make this function and display more neat. You are free to modify it. I just make such a separation to make sure that I understand the flow better. In the end, there is a user inquiry. The user inquiry you can always modify. I'm saying I am an IT company and want to mitigate a GDPR risk. What should I do? What are the penalties for non-compliance with GDPR? Use plain non-legal tone. Do you have some examples? I also ask. Provide a comprehensive report. Okay, so this is my user query. And when we want to generate the final answer, we actually use the generator response function to put our user query with a vector store 1, vector store 2. So as you see the function above, it will interact inside, get a more comprehensive prompt to feed to the local LLM, large language model. And there we're going to print the final answer and also save the different information to the report HTML and the debug HTML. Okay, so that's it. The program finishes here, and let's come back to the left-hand side. You can always check there are different. This is a summary, okay, and let's check again about the main execution. Okay, the main execution is about the different steps. Okay, I really recommend you, whenever you finish this workflow, just ask a GPT or ask a large language model to organize the code, explain the code, get a summary of the sequence. So this one is not actually generated by GPT-4. It was generated by Hugging Chat using Llama 3 model. I think it's a Llama 3 8B. So I can have a better idea, because after all these complicated functions, workflows, in the end, sometimes you forget. Okay. And the general workflow here is a more summarized, more high-level workflow. Okay. So basically, I think just to put it in a nutshell, we load data, we set up a vector store, we define user query, we generate a response based on the above resources and prompts, and we save the query and response to HTML and debug to HTML. Okay. And following up, You can see here I make some notes about version 4. Some of the major debug actions I did. First of all, I solved the tensor issue with converting data frame to TXT. Because like I said, when you feed the data frame to the vectorization process and so on, maybe you'll meet a problem. It's safer to transfer the data frame to text information. I did additional data cleaning. For example, like when the data frame actually had the non-available value, in some functions, sometimes it will generate error code, and incorporate the text doc handling. Basically, it's related to the data frame to text and the text to text chunks and to vectorization. And the last one is change the data input as text input. Okay, so text chunk 1. So basically, I did multiple debug actions to actually make it work, as you see. This kind of description is quite summarized and with few words. If it's not clear, you can refer to the key point page. I'm going to scroll down again, and in the end. So if you have any question about any point, just feel free to ask me. My suggestion is that to keep your record registered, because in the next step you can come back and see how the journey goes. Okay, you build up this program to go through the whole workflow to generate better prompts and ask the local large language model. And in different version, you did something which could be very useful for your future projects. Okay, and let's come back. There is one last general comment that was generated by GPT-4. Let's read it. The code extracts and processes textual data from documents and structured data from CSV files. It uses embeddings to determine the relevance of stored documents to a user prompt. It then combines these relevant documents with the prompt to query a large language model, generating a comprehensive response. So let's go back to the beginning. I ask GPT to use LangChain framework to actually help me improve the performance of large language model. Okay, my objective was to generate a report, a GDPR risk is like a risk assessment report. Okay, suggestion report based on the dataset I gave, based on the law I gave, and ask a LLM to wrap them up altogether. And then regarding the database management, it also gave the comment like, okay, we are not interacting with SQL, non-SQL database. I mean, if you want to make it a higher level interaction, of course, you need to have such a database to actually make sure the large language model to interact with such especially private data in your local environment. About vector store as a simple data repository, yes, it acts like a rudimentary in-memory storage system. This is quite important because it actually transfers the text information into this embeddings store, vector store, so you can query very efficiently. And about data loading and some of the techniques that we manage the data, of course, it also made some comments. Yeah, so remember, here it only mentioned about merging the data, and one more important point is that the data should be converted to text, at least for my example. I think it works in this way. Then, if the application requires more sophisticated data handling and persistent storage, okay, you need to have a proper database. Okay, is like the point number 1. And you also need to have further considerations. Okay, this is just a quick go over of this project. Then let's quickly check some of the results. You can see this is the HTML file result. Left hand is debugging report. Right hand is GDPR compliance inquiry. And this report you can change the name as much as you want. So let's go through the debugging report first. So basically, we combine the data frame that we get. Is about the sanction historical data, how much fine was the GDPR authority actually sets to the different company. Okay, but you see the format. Okay, like the second table, actually the format is different because we have different column title, so it actually moves to the right. Okay, then in the following part, we can see the first few sentences from the PDF, first few documents stored, okay, and the first 4 documents stored for the dataset. As you see, the dataset is also transformed to the text format. Then we can see the first few embeddings. Okay, it's all numerical vectorized data, and it's quite long. If you see, this is just the first few. I think first 5, yeah, if I remember correctly. Yeah, this is also the first few embeddings. I think this part is about the data frame, and in the later part, we can see here is our query. Okay, as you see, the query was in the code, but this part I only showed the user query, but in the actual running of the program, the query is more complicated. Okay, it's not only about this part of the query, it's about the query including the embedding search of the existing knowledge base and also your query. Okay, so we can see in the end, we can see the generated response. I think it's quite comprehensive at this moment. Okay, you see that fines can be severe, and it actually quotes the both the clause of the law and also some of the information, I think, from its knowledge base. And what should you do? Okay, this one, conduct a data protection impact assessment. This one, because according to my work experience, I understand there is such an assessment, so it's pretty accurate. And about a different suggestion, I think they all make sense. It's not 100% comprehensive, but I think it's a really good start point. And then it quoted some of the historical data of the fines. But here I doubt it actually used the data frame I gave, because I think the Llama model was trained actually before 2023, the data, or the beginning of 2024. So basically, most of the data I get are historical data, so which matches its training data. So here, I'm not 100% sure it actually queried my knowledge base, but of course we can check the log to make sure of it. Okay, if we are not sure about the query, how the query was constructed. Then about the comprehensive report. Okay, so it actually gives several sections. Then comprehensive report is here. Okay, we did do data mapping, privacy impact assessment, implement the security measures, training employee. Okay, it actually repeats a little bit from the previous section. Of course, we can further adjust our prompt or the penalty score to get a better result. Okay, really pay attention to the penalty score, because when I did not set it, I get a very long and very useless information. Additional tips, additional tips are also informative. Yeah, that's it. And you see here, we still have some of the not very good parts about the, I think it is like the repetitive nonsense characters. For at this moment, I do not have a solution to it, but of course we can try to give some more clear prompt, structured prompt, even prompt template to actually confine our outputs in further step. So I think is okay. Then on the right hand side, you can see this is a much better structured. compliance report. Okay, this is my query, and this is the response. Okay, the same as the left-hand side. But on the right-hand side, it looks like a very good and well-structured report. Okay. One more thing I would like to share with you is that whenever you come back to the to see the test record I gave, you can check there are different versions of the debug report, GDPR compliance report. So basically, every step I improve some of the coding or improve some of the strategy. I actually build the different building blocks of the program. And when I realized some of the variables were not fitted into the different function, actually that was almost the last 2 or 3 versions. So basically, for the first 4, I think first 4 versions, I did not actually include the vector store of the data frame. Yeah. So this is just a reminder to you that whenever you build this kind of program, really pay attention to see if all the functions are called properly, and to make sure that your answer is at least including all your current assumptions and resources. One more thing I want to share is that if you are asking large language model to give you, for example, like this search embedding part, okay, so at first it gave a naive strategy, okay, so I realized it only after I implement the code several times. Then I realized it's called naive search in the beginning. So naive search is just to give you the top 5 chunks without actually running any similarity algorithm. So when I notice that, I ask again. So actually, GPT suggests me to do the suggestion to do the similarity check. I think is a cosine similarity. Okay, just to compare your query with the vector store. Okay, the document. So document embeddings. So in this way, it does not only show you the first top 5 of the according to sequence. Now it shows you the top 5 search results based on the cosine similarity calculation. Okay, so this is another point I want to share with you. The reason I want to share with you in the end, because I think this one is actually going to determine if your prompt enhancing strategy is working or not. Because at first, I only used the naive query, so the response change was not very obvious. There are also some other documents I want to share with you. For example, like when I did 2 versions, okay, the pure LLM Studio query on the left and the structured query on the right. At this moment, it was only combining my query with the naive search of the legal document. Every time I compare these 2 results, okay, I see which one makes more sense. It's like your local prompt arena. You can compare them. And even in the naive search phase, you can see that the right-hand side result is that does make more sense and can be more comprehensive. But you can run multiple tests. And of course, based on your different HTML, you can feed it to GPT or other large language model interface where you can upload the document, okay, to ask it for ranking. It is very interesting, actually. You see, GPT actually ranked the LLM Studio response. This one is a very basic query result. Actually, give it a very high grade. But then you see the following 1, 2, 3, 4, all are the versions with the more reached prompt. Okay, where I have the query merged with part of the information that I provide, which I call it a local database. Okay, so you can also try this to grade the results. But again, however, it creates the result. The user is you. The use case is based on your use case scenario. Always check to make sure that this output is matching your expectation. Here, as a final display, I would like to share with you the latest two running results of my code. So basically, this is the ML Studio server, first of all. Um, and on the left-hand side is the first time I run this code. On the right-hand side is the second time. So you can see here with um, all the functions, all the functionalities of my program, now I can actually enrich my prompt with a lot of data. First of all, um about the data set I provided to the system, so it can actually refer to that data set. Okay, so you can see this is the content of the user. Okay, the system message is always the same. You are a professional GDPR advisor, specialized in GDPR compliance analysis, plan drafting, report generation. Okay, and here we can see the prompt like violation of different GDPR rules and different fines of different company. So I think the system is actually retrieving from the vector base this information. Okay, so the retrieval of this information, I would say, is successful. Uh, on the right hand side, there is not much change because I think the similarity of the vector store and my original user query remain the same because I use the cosine similarity. So basically, the engineered prompts are similar. They are all fed to the system to get a response. Okay. Uh, Previously, as I mentioned, I only included the law part. Okay, the legislative uh, PDF, and the system is fetching its vector space, vector store, and get the relevant information. However, after introducing also the dataset TXT, we can see, of course, the information is more abundant, but we are not sure about the results. And very interesting is that now I think the system recognize less about the PDF part. Okay, as you can see here, almost everything is about the past um, violations of different company. Okay, so I guess from a similarity point of view, the system now or our program is recognizing the similarity more on the data frame and not the lower part. Now let's skip to the final compliance report. So both versions, I think, show a good template. I think for us to understand the how do we mitigate the GDPR risk for an IT company. Although you see there are some small differences because each time you prompt to the LLM, it can generate different type of answer. Then let's go down. About the end of the report, you see the problem shows again. So basically, before this version, I actually, like I said, I tried to limit the presence penalty and the frequency penalty. It worked, okay. But however, when you restart the program, sometimes it does not work again. So after these two attempts, I actually did one last try just a few minutes ago. And this version, I limit the token size to 1,000. Previously, it was 3,000. After limiting the token size, okay, the debug report is the same. because our PDF text information, our data frame text information does not change. And let's see the final result is better, okay, but you still see here, okay, it was trying to generate some examples, okay, but it stopped because we have a limit of the token size. So in here you see there is no repetition, and of course the answer is structured in another way. You can see here. What should you do? Data protection by design, transparency and communication, data protection principles. Okay, it's like and I think this is more structured, like the legislative structure. Okay, but let's check this log because I just run it. I think we can open the log and see. So basically, whenever you open the log in LLM Studio, you can see here. Okay, this is a prompt. Actually, after incorporating our database and the law, this goes to the system. You can see here, most of the information is about the past violation of the law, the records about the fine amount, and also the company name and so on. Still focusing on the data set. And because I have one of the CSV you saw, actually it get only 5 records. Okay, actually for that document, I think almost everything was cited. Okay, in this way, I suppose some of these characters, for example, this is the URL link. Okay, it's very complicated. It does not mean anything. But when we pass such type of information to the large language model, I do not think it will improve our results. Maybe create some confusion and so on. So anyway, in the last version, I think I just showed you the way to actually limit the error in the end of the answer by adjusting the token size. As I said, you can try multiple times. Okay, and also maybe also try the prompt template to actually get a better result. Okay, so just a wrap up of this project. First of all, I tried to ask GPT to incorporate the LangChain documentation with my project idea. It gave me alternative, so I have to refer to a different source, okay, to process the local information I have. Okay, also it was downloaded from the Genius package and also Wikipedia and also the GDPR website. Okay, it can be considered as external, but I save them as local, so I refer them as local. So I have this local data source that I incorporate with my query. Okay, so I get a final prompt. Okay, the chosen text message is based on the similarity to my user query, and I put them all together and prompt to the system and to get a final answer. So as far as I know, LangChain is utilized in more complicated scenario, but from what the GPT suggested me, I think from this project, I actually have some idea of building some simple project similar to this one. But the choosing of the embedding, vectorization, different method, I should be more careful and choose the best one for my use case. And I think there may be additional variations from this project I'm going to try in the future. For example, if I want to be an expert in interpreting the accounting regulations or accounting rules of a specific country like Spain, I might get on official documentations, most of them PDFs, okay, and save it locally. And I can also get some accounting ledger example from the website, from different website, different open source information. Put them together to improve my prompt or to make it incorporate in the chain in the future. In my example, I only improved my prompt, but I do not yet incorporate the chain. But I think after this project, the basic idea I already get. Okay, I wish this could be useful for you. You may check all the example HTML, different Python program files. And if you have any suggestion and any doubt, feel free to let me know. So I wish it could be useful for you. This video is a little bit long, but I just try to go to every detail, every trial, every test as much as I can. So wish you good luck building your program and see you next time. Bye bye. Well, welcome to my channel again. Today I'm going to show you the pros and cons of using ChatGPT, which is my personal experience utilizing ChatGPT for coding, for data analysis, and also for the daily Q&A. On the pro side, first of all, it can be the inspiration and idea generation source. It can serve to do the brainstorming, help to structure and generate ideas. Then it now can interact with external resources, like it can link to the web search engine and to enhance the information retrieval. Then it now can provide more options of customization and also the query mechanism. First of all, it can let you customize GPT to limit the scope of the GPT to feed different reference documents to make it more task specific. And by default, the fine-tuning process of the output can always include the prompt engineering. I think now is a very important topic that we can explore. About the cons, I really would suggest you to pay attention to. First of all, there is a usage limit. Of course, when you use the ChatGPT 4 model, at a certain point, it will tell you, okay, now you reach the limit. You need to downgrade to 3.5 model and wait again for the limit to be restored. So this can be sometimes very inconvenient because when you reach to a certain step of the project, of the Q&A sequence, suddenly you lose the capability of GPT-4, you need to use 3.5. It may deviate from your original designed trajectory of Q&A. There is also a hidden computational limits. I really would invite you to pay attention to this because as sometimes when you ask a very complicated question or you would expect more robust output, more comprehensive output, when you hit the computational limits, the answers will be very simple, very generic, and it seems like a protective mechanism of the GPT. So this is just my understanding. Then, based on all these kind of limits, I think the recursive improvement challenge is also a result of different limits, like usage limits and also hidden computational limits. Because eventually, when you repeatedly ask a question to improve a part of HTML code, actually sometimes GPT does not improve at all because its knowledge is limited at some point. For example, when I want to modify a specific line of the code, I want to, for example, improve the aestheticity, the display of the HTML, it cannot do it. So in the future, if I have the chance to show you some demos, it will help you understand my point. But for now, really pay attention to this. Sometimes we ask a question again and again, it may not get better answers. And furthermore, outdated information, it actually relies on the training data a lot. So if the training data is outdated, you cannot expect the large language model to get updated information, but you can improve the response from the GPT utilizing the updated data to feed in the data sets and so on to actually get better results. Okay, but still be careful about the information generated from the large language model, especially when you ask the question without feeding additional information. Uh, there is also additional personalized GPT limitations. For example, when you utilize a GPT, like one of the GPT I created, to ask the GPT to focus on the GDPR, General Data Protection Regulation in European Union, ask it to focus on that law and generate answers based on that law. I uploaded to my GPT. I created this GPT and also write a objective statement. Um, Sometimes it will refer to the document I uploaded. Sometimes it will ignore it and it give me the generic response directly. So I really recommend you to pay attention to this personalized GPT limitation because the answers are not always linked to your document. When you see that sign of a query your uploaded documents, that is the time when you have the results referencing the documents you uploaded, and at that moment, I think you can have a GPT that really utilizing the material that you uploaded. Apart from that, really pay attention. Sometimes it only gets to its own training data and give you the prediction of the words as it likes. Finally, I would like to give you some recommendations. First of all, if you are not familiarized with different strategies of improving the output of the large language model, use multiple online offline models to improve the solution to a problem. For example, when I did some complicated coding, I would do the process like below. First of all, I ask ChatGPT, then I go to the Hugging chat, and then I can also ask the Llama 2 uh, online version, and now we can even use Grok. Okay, so by interchanging to different models, you can improve the answer because their training data may be different, so you can get more insight. And sometimes, hopefully, you can fix complicated bugs. But that is really a rare case. Uh, Apart from this, you can try the RAG strategy. I think now it's very popular because like LangChain is designed for the RAG strategy. It will improve the prompt and also the information retrieval mechanism. I call it a query mechanism here, maybe not a very scientific term. But eventually, the RAG mechanism is the main goal is to get a more robust response output. So in the next videos, I think I'm going to explore, especially on the RAG part, to share with you some of the journey I just made. But like the right hand side, this is the project I'm going to show you in the upcoming videos. Actually, I want the large language model to intake the document description of LangChain and also the local LM Studio code format to help me guide me through the creation of LangChain strategy, which is to implement a RAG strategy on local environment. So far, I can tell you, based on all these uh, cons, okay, the defects of the GPT and also the other language models. Uh, all the models actually direct me to another solution. It's similar to the LAN chain, but it guides me through uh, a journey to actually utilize the local data and the document I have, and to improve my prompt and feed it to the local large language model and get a response. So just to keep it quick, I show you. This is basically the debug report. It actually shows you the steps of uh, the quasi LAN chain workflow. It's not LAN chain. It's how the large language model guide me to a workflow similar to LAN chain. Basically, the code, the final code, first of all, utilize the data frame that I already have in place, and also the PDF have in place, and stored them into documents. Okay. Basically, the first saved documents is about the legislation. The second one is about the dataset. Okay, the dataset actually transformed to the TXT format for easy processing. And we got the embedding store. The embeddings are stored based on the information we provide. Okay, and we feed the query to a large language model. So here you see the query is only the query I designed to prompt to the system. The actual query to the system, to a large language model, is more complicated like this because it also retrieves from the two embedding stored in the system to get the most relevant information from the law and from the dataset I provide to the query, feed to the large language model, and get the below response. To be honest, when I get this response just 30 minutes ago, it is actually improved version from my previous results. So basically, next time when I share this project in detail with you, I'm going to share also different tests I had and some mistakes I made. But this eventual response I get is, I think I would grade it as 6 to 7 points out of 10 because first of all, it is not a very robust RAG mechanism I would expect. Second of all, this code structure and also the embeddings I created are not so robust. I'm going to share with you some of the defects of the project and also this result. You can feel free to replicate it and to try it. Okay, so basically today, just a quick wrap up. Whenever you use large language model for coding for different tasks, always pay attention to its downside. And you know, now we have different models coming out like every week or even every day. Always pay attention to check it if it is suitable for your use case and try different strategy to improve the output to get your desired result. Just one last thing I want to remind you is that this HTML file you see on the left hand side is actually the result of this code. Here is called GPT summary. Here, actually, this summary is generated by ChatGPT. I mean, for this task, it's quite easy. I just ask ChatGPT to make my ideas, the information I want to share with you, into a nice nice displayed format in HTML. Actually, it did a good job. I think you can also try this. Okay, if you do not want to use PPT, if you want to use PPT or the Google Slides, is another story. Okay, so I wish you like the information I share with you, and I wish you enjoy utilizing large language model. And feel free to make any comment, discuss anything with me. If you like the video, give a thumb up and subscribe. Looking forward to share with you another project in the future. And thank you. Bye bye. Welcome to my channel again. Today I'm going to show you how to make a chat interface or user interface similar to ChatGPT in local environment. Basically, it requires you to download and install Llama and Open Web UI and Docker. So basically, with all these components, with Llama, you can host your large language model in local environment. Basically, you can directly interact with the large language model via the CMD interface, local command interface. However, if you want to go more advanced, you can link it with a user interface or interact with your Python code, Python environment. Okay, so Llama, the downloading and installing is very intuitive. This is the first step. Then you should install the Docker application. For me, I'm not an expert of Docker, but it seems like it runs the local server and provides you with a link where you can access the large language model. And the last thing is that you need to install the Open Web UI. The document is very clear. How you start with Docker. Basically, after you install the Docker, you should run the first installation instruction in your command interface. So just copy this one and go to your prompt. CMD interface is like this one. Where you can type CMD in the search button and you can go in here and just run this line of code, and it should install an image in Docker and make sure you can run it. So basically, after all these steps in the Docker interface, you are going to see this one is an active container and with a port. Okay, you can open here and you are going to be diverted to the interface. Before you chat, you need to choose a model and you can start chatting. For me, I already downloaded the models from Llama interface, so I have several in place. The others I don't recommend you because after the testing, I don't think they are good. But the Llama 3, of course, I think is best so far. I've tested in local environments where its size and computational consumption are reasonable. So basically, how to use this Open Web UI? You can go to GitHub or their official website. This is Open Web UI documentation. You can find all types of suggestions. For example, like this one, tutorial. If you go to tutorial, you are going to find a lot of content. You can find the ones that you really want to use. For example, like the rag section. And for example, how you can chat with a website. Okay. So let's take a look at the real user case. So basically, I take the information or the idea from my previous project, where I ask the large language model to generate the GDPR risk mitigation suggestion report. As you see here, I made some typo, but large language model can easily identify what I'm talking about. And as I said, I asked the large language model as a professional GDPR professional, generate a GDPR risk mitigation suggestion report to a new fintech company which plans to start business in Italy soon. Refer to, first of all, is the Wikipedia GDPR fines and notices web URL, and then the GDPR law URL, and also the additional legislative content. So let's open this. Open these pages. As you can see, we have everything ready, and let's see how this model works. So basically, this report is well structured. I'm not going to the details with you, but from my understanding, because I also worked on the GDPR compliance framework design of a company, so I think the general content is useful and insightful. Of course, if you want to add more information, you can always do that. At this moment, I think is quite comprehensive, and especially it also cited the different sources that are utilized in the prompt. Okay, and you can see it also mentioned the Italian Data Protection Authority, Garante. This is an actual local authority to enforce GDPR and to enforce the Italian local data protection laws. So it's out of my expectation because it actually understands the specific country would require a different legal framework. So let's keep on looking the following content, like the conclusion. Yeah, it actually gives a very clear conclusion, and you see, because it's a suggestion report, it also had the ending showing some of the placeholder to show that this is a report from a GDPR consultant. It's well structured, and as you can see, the result we get requires us to install different software, different packages in local environment, and we can run it. And this is a complete RAG workflow because we provided the context for the large language model to consume and provide such information. And because about the sanction data, I think it did not mention any actual cases, so I asked the model to add some cases. So basically, all these cases are real. I already compared with the data. You can also do the comparison. However, because I asked it to rank the top 5 sanctions from the Wikipedia website, it did not actually make a ranking. And you can see if we really rank the numbers, I mean, if we only look at the Euro ones, there is a WhatsApp sanction about 225 million. Let's see if we have that. No, it was not included. So there are still some limitations. So either we provide a cleaner ranked reference data for the rank process to reinforce our generated output, or we can do further prompt engineering. There are different ways to resolve this problem, I think. Then I ask a further question. Hypothesize two scenarios where company breaches which clause would be sanctioned with which amount or be taken which action, cite the law. It gave some hypothetical scenarios, and although the hypothetical sanction amount, the fine amount, may not be so realistic because it does not apply any model to predict that number, but the general simulation of the scenarios are good. And if you want to check against the law, I think at least from the article general title, it is correct. Okay, so if you keep on asking questions during this the chat, I think we are, first of all, we provide outside third-party source information. Then during this chat, it actually does a second round of the RAG output generation, so we can have more comprehensive outputs. Then I ask it to consolidate the report. Of course, the general starting points remain the same, suggestions the same, and the top 5 sanctions listed, and the scenarios. The model kind of reduced the context, the token size of this part, but it is still acceptable if your expected report size is like this. And we have also a conclusion. Yeah, you see, conduct regular data mapping exercise, implement robust consent management procedure, develop comprehensive data protection policy, provide training to employees on GDPR requirements, and best practices for handling personal data. It's way above my expectation, because if you saw my previous video, I tried to do it with local RAG, and either LLM Studio does not work as expected, or we have any other issues. For example, if our local reference data structure is not handled properly, and or our similarity check of the documents behave out of our control. So basically, at this moment, I think it works very well. And furthermore, I tested also the coding part. I have to tell you, I tried both to generate a PDF report based on this information, because I know this model cannot directly provide me with a PDF report to download. At this point, it's not as, for example, ChatGPT can already produce some. For example, if we upload a CSV file, ask ChatGPT to handle it, to modify it, it can provide the result. Or if we ask it to generate a HTML report, it can generate. But I don't expect the local one can do that, so I ask it to generate the Python code for me. Unfortunately, that does not work. Then I tried several times. All of these does not work. Okay, so I guess if we are asking it to provide the code to represent the chat history, it has limited capability. We can have a different alternative. For example, we can ask another model to provide a simpler HTML format structure, so we can insert the information inside, or we can ask another model to provide a full code to embed the content in the HTML code or the PDF Python code. So you may try that, but at this moment, I understand its coding capability is limited, at least for this use case. So I would suggest you to also try out and explore more examples from the official documents, or you can go to different functionality in the local server interface. As you can see here, when you click the documents part, you can actually upload your documents or even import document mapping. As the introduction says, it provides you the capability of local RAG ChatGPT capability. And also, as you can see, this prompt, you can also save your prompt, discover prompt, and you can see there are also model files. There are so many more that you can explore here. But as for my very simple user case now, I would stop here and leave you to explore the future use cases. So if you have any doubt, if you think anything is not explained clearly, feel free to leave a comment. If you like this video, give a thumb up, and I really wish you could utilize this amazing tool to start interact with it, or get insight, or get a task done in local environment. In my future videos, I'm going to keep on exploring how to better use large language model on different user cases. So until then, I wish you a good day, and please, if you like the video, don't forget to subscribe. Thank you, and have a nice day. Bye bye. Hello everyone, welcome to my channel again. Today I'm going to introduce you the tool to help you code faster and to assist you through all the procedure of coding. The name is called CodeGPT. It can be searched from the extension store in VS Code. The one thing I want to mention to you first is that you need to pay attention. There may be some other extensions which share the similar names. I think when you focus on the download amount, like this official extension has over 1.2 million downloads already. So I recommend you to check carefully. And of course, if you want to explore other similar tools, you can do it. But if you want to, first of all, find the most popular one, you can choose it with careful examination. Just do not, for example, like this one. It has the same logo, but it does not mean the same thing. So let's come back. First thing, you need to install it, and it will be ready. Having it installed, on the left hand side you can choose it, CodeGPT chat, and this is the interface. You have many different options. For example, if you choose a provider, you can choose LLM Studio or Grok. These two are the interface or the large language model source I prefer now, because LLM Studio, I can interact with my local models. Grok, I can interact with the Grok interface to leverage the LPU calculation. It is very fast. But if you want to use Grok, you need to get the API key. Get the Grok API keys. It's very intuitive. You just go to their website. If you have not registered yet, just register and go to the API key section and create one. So copy it, and you will going to use it in the VS Code environment by linking to the GPT code. We are back because I already have both the Grok and also the LLM Studio both set up. So I'm going to show you how they work in practice. Let's just test with a very simple code generation and see if it goes well. Interact with LLM Studio in local environment. The first thing is to open LLM Studio and choose a model that you prefer. For example, for me, now I choose a Meta Llama 3 instruct. And after a while, it will load the model. Yeah. And after starting the server, it is ready to go. Back to the VS Code environment. Let's see here. We choose LLM Studio, and let's try. Okay, write a Python snake gain. Okay, so it just starts writing the code. The speed is quite okay because it is a small size model in my local environment. And I just created this Python file. And you see, when you go back to the top, there is an option. You can either copy and paste the code here, or you can directly insert the code. Let's try insert. Okay, the code goes to the right hand side. So let's try it. After installing the Pygame package and run the code, I see this pop out window. Let's try if it works. Yeah, it works very well. And the speed is okay. You know, some time ago I tried with ChatGPT, and sometimes the result of this Pygame either has very fast speed or the interface is not very well. You know, it's not like this. So I think we have a success with LLM Studio. Let's see. Okay. It cannot just go past the right border and emerge again from the left. Yeah, so let's stop here and let's try Grok. Let's choose the other option. It's called providers. Let's go to Grok. Okay, you can of course choose a model that it now supports. For example, now I choose a Llama 370B. Okay, because I already have my API set up, so it should work. Okay, I just copy the same prompt. Let's try. It's super fast. This is one of the advantage of it. Okay, just to save time, I'm going to directly insert the code to replace the old code. Now let's try again to see if it works. Okay, it is working. Let's see. Okay, let's get it. Yeah, it's okay. Some special case like what I just did. It still has some problem like when you hit the wall, it does not show a prompt. Yeah, you just restart the game. So in general, both code work. Yeah. And furthermore, if you want to understand the code on the right hand side, or you want to change something, the most direct way is to select the code you want. You want to change, you want to do any action, right click, and then you are going to see Code GPT explain, refactor document, find the problems, unit test. Okay, there are so many options. For example, let's try the explain Code GPT. Okay, so the code just go to the left hand side, and you can see the explanation just goes on and on. Okay, so it is very convenient. Let's see if we can do the unit test. Okay, so yeah, it's working, and it shows unit test for state gain initialization, test case 1, test case 2, and so on. Okay, so I rarely do this unit test, but I think it just provides you more flexibility to test the different part of the code. Okay, so just feel free to try any of the function, and wish you find this useful. Just remember you have it on the left hand side, and it can interact with your code interface on the right hand side. And pay attention if you want to use like the interface like Grok or OpenAI. You need to have the API key. And of course, you can also choose Llama or LLM Studio. There are so many other options. Yeah, just find the one that suits you best. My personal suggestion is to have a paid service like the paid GPT API and a free local version like Llama or LLM Studio. Because it just provides you with more flexibility, and when sometimes like I meet the I met some of the problem before. If you meet a repetitive situation where the large language model cannot help you with the coding, uh, changing different models sometimes may help. Yeah, this is just my suggestion. I wish you find this video useful. If you have any doubt, any question, any issue, anything you want to ask, you want me to explore in the future, feel free to let me know. So until next time, have a nice day and happy coding. Bye bye. Back to my channel again. Today I'm going to show you one of the example of data analysis, which I did some time ago about analyzing the Melbourne housing market data set. This data set is available in Kaggle. I chose this data set because it was available, directly available, and it is very useful for us either in academic research, data analysis training, or in applying to a real world scenario where you want to determine if the housing price is overpriced or underpriced. So I think this data set is very interesting. So in this video, I'm going to show you the comparison between the GPT-4o and my own project analysis. So on the left-hand side, I ask the ChatGPT to process this dataset, and on the right-hand side, I'm going to show you what I did. So basically, let's first look at the ChatGPT. First of all, I ask it to analyze this dataset by providing this URL. It cannot directly solve this URL, so it asked me to upload this CSV. Okay, so I uploaded this CSV. It started by showing the head of the dataset and so on. Okay, it starts to process the data, and I did not define the exact models that I wanted to examine to run. So it actually it started thinking about which model is the best model to start the supervised learning process. Eventually, after checking the data set and so on, it started to suggest the three models: linear regression, decision tree, and random forest. If you are not familiarized with all these models, I suggest you to check the information of each model to make sure that you understand how it works. Okay, these are the very popular supervised learning models. So let's see how it does. I really like that the GPT tries to put all the models in a bundle, and it uses a for loop to actually try the different models. It's quite neat, this code structure. My project, when I tried to run different models, I did not have such neat coding structure. I actually write for each supervised learning strategy. I actually write independent code in the R environment. So let's see how it goes. So basically, GPT starts to train these models and found that one of the model took too much time, so it actually stopped. So tried a simplified version, and eventually it manages to train two models: linear regression and decision tree. So this means that if you give ChatGPT a very open, very wide question, it will, of course, try to exhaust some of the possibilities to reach a comprehensive result. But eventually, if it cannot give an immediate result, or the process actually takes too much of the compute, it will reduce the complexity and give you an intermediary or simpler version. So it starts to, because in my prompt I asked it to analyze the overfitting issue, it started to plot and so on. and you see the connection was interrupted. So I really don't know why there was an interruption of the connection, because my internet is always connected. However, let's see, it tried again. But there is still technical issue. So basically, by showing the plot, I do not think it's a very daunting task, very difficult task, but GPT cannot do it. So later, I still do not see any graph. However, it gave me some conclusion. I think just like any internet product, they do not want the user to wait too long. Otherwise, it will be a very, very inconvenient way to lose the user. So, just to briefly show you, I don't want to go to the very detail of each line of code and the result, but I can tell you this is it does not consider the complexity of the dataset. It did not show the steps of handling missing value. If you need to scale the variables, if you need to take a log value or not, and for me, this is a very rudimentary and very basic form of analysis. However, if you are interested, you can try to focus on only one model and see if that one model can be better handled by GPT. Let's look at the right-hand side, my project presentation. So basically, I did both supervised learning and unsupervised learning techniques to analyze this data set. Today, I'm going to focus only on the supervised learning part because I already got some response from GPT. I just want to show you that if you are going to analyze a very complicated data set, I mean, this is not very complicated, but in a sense that GPT find it complicated to implement different learning algorithms. I really suggest you to really get your hand dirty and try to solve the problem yourself. But of course, if you need some coding assistance, you need to clarify some of the concepts, you can use GPT. But remember, always interpret the result from GPT with great caution. So, first of all, I tried to use the most simple one of linear regression, but it also incorporated the feature engineering and the AIC step to find the best models, just to shrink down the independent variable size or the feature numbers. So basically, first of all, we need to have a clear idea what are the variables, categorical variables and numerical variables. So then, in the analysis, I would suggest you to always have a histogram to see all the variables. For example, even if you directly go to see the price variable, it will be very skewed and have a very concentrated in a specific range. So in that case, you will notice that it is not a very good sign. So you need to have a strategy to actually do the feature engineering, actually to find a better variable to explain the value of the house. So I'm going to show you later. Okay, so here, like you see here, if I take a log value of the price per building area, so the value will be more, how can I say, closer to the normal distribution. It will not just concentrated in a very specific range, and it will give you more, how can I say, a distributed sense. At this moment, I do not go to very technical terms. I just want you to understand. For example, if in a daily basis, I want to understand the situation, I try to use some terms that I understand better. But if you are going to write a paper, if you are going to discuss in some academic situation, I really recommend you to make sure that all the wordings, all the terms are very statistical and really about the essence of the statistical concepts. So here I just try to use some plain language to explain to you. So basically all the variables, like I said, you try to examine its property and to decide if you like. I do not use a price directly. I use price per building area because I think it makes more sense, and because the distribution was not very dispersed, so I decided to take a log value to make sure that the scale does not impact distribution largely. Then about the other variables, of course, when I actually do the analysis, all of the variables are scaled. So if you are handling this data set, of course, you need to ask some questions. So if you already have some domain knowledge about the housing market, I think you should make some assumptions. You should understand that, for example, like I understand, the property price change over time. So if the data set contains one housing price at the beginning of the year, the other one at the end of the year, this information actually can change drastically. And if I'm only analyzing it using the simple linear regression, of course I'm ignoring this factor, so my result will be biased. And the factors that influence the price may not be easily exhausted, which means that there may be more than the factors that's shown in this dataset. So you need to be prepared that the regression result may not be so accurate. And of course, the factors that influence the price, for example, subjectively, based on the agent and seller and the buyer's judgment and so on, these are many human factors that could impact your analysis. And based on is like a rule of thumb. If you are going to implement the supervised learning algorithm, or even unsupervised learning algorithms, it is suggested that you scale the data. Do not let the scale of the data to impact your analysis. And also pay attention to the dummy variable, because in one of my analysis, in the following page, you are going to see that if the dummy variable is too many, it actually create more complexity to your interpretation of the models. And always pay attention to the outliers. Outliers may be business opportunity, maybe a bargain, but most of the time it will just make your model derail, just show you more, make your model more impacted by the outliers. So about the methodology and so on, I'm going to go quickly. Especially there is the AIC process. The AIC process is actually optimization process to help you to choose the best and most significant independent variable. So linear regression, the assumptions, they are very intuitive. If you're interested, you can check it. I'm going to go over. So here, I'm going to show you the models. So basically, if you are going to ask GPT to do all these complicated matrix, I doubt it, because you see, I have different strategies to handle the feature engineering design, to manually select the features or use the AIC procedure, and I can also subjectively implement the outlier treatment methodology. For example, like the first two columns, you can see that I actually set value threshold to actually eliminate some of the outliers. So basically, here I'm trying in different scenarios to see which one is the best situation to do the linear regression. About the selection of the variables, because we also have the choice of a distance or cluster, so there are also different choice. For example, if you calculate the distance of each house from the center, you're going to get an additional variable. It's called distance. Or if you already use a clustering, k-means clustering, to separate these housing these house regions, you are going to get another dummy variable. It's a subjective choice. Okay, you can try. The reason that you introduce additional dummy variable is just to make sure that you understand the distinction between the different regions or different dummy variable, and to actually have a better understanding if your clustering really makes sense. For example, if we are separating in the Melbourne region into 4 regions, sometimes it doesn't make sense because each block has different characteristic, also the different price range. As you can see here, traditionally we use adjusted R-square as the fit, okay, to see if the model is fitting well to the data. So by this sense, 55% of the accuracy on the stepwise regression to use the AIC procedure to choose the best variable. And also I took a log transformation of the price per building area. So here I just want to say either you build the models step by step or you interact with the GPT and so on. Always make sure that eventually you are going to compare all the metrics of the algorithms and to have a better idea to see the trade-off. Because here you see that we have many dummy variables in the stepwise regression, best of R combo, log this model. So when you interpret such a complicated model in business scenario, it's very hard. So you need to have a balance. So if you choose, for example, the second column, the distance, and a simpler model, it's easier to interpret. Okay, you can have more direct interpretation. You do not need to say, okay, now we have this this house in a specific block, and the price is blah blah blah. Okay, when you are going to describe the general situation of the whole region, a simpler model will give you more flexibility. But if you have a more complicated model, you are going to be more accurate, and of course you need to know which is the reason that gives it such better enhanced precision. For me here, I think the main reason is that we introduced many dummy variable about the different small regions of the city. So there is also always a trade-off. So I really doubt that GPT can grasp such details when you are going to implement different models. So use GPT with caution. Here you can pause to check. These are more detailed descriptions and also the model itself. which variables were in the regression, and always take one final look back to the model itself, the best model. So eventually, if you still find many of the assumptions of the linear regression was validated, the model itself may not be the best. But from the beginning to the end, you know how to handle your data, you know which choice you made to choose the independent variable, the features, and of course, you know exactly which model for which reason is the best, and when necessary, how you make a trade-off in a real scenario when you implement these algorithms. So these are the key findings through my analysis. So I will not repeat it. You can check it. It's not comprehensive, but it can give you some idea that always own your data, own your analysis procedure. Do not 100% rely on a large language model. It can help you code, it can help you to organize the data, or even help you improve the data handling process. But always remember to use it carefully. That's all for today. I wish you like this video. So basically, this video just give you some comparison between the new GPT model about data analysis with the human lead data analysis results. It may still not be very conclusive and comprehensive. I really suggest you to try for yourself, and remember that tools are tools. Use it carefully, and we may improve ourselves better and faster. If you have any question, any doubt, any video that you want to see in the future, feel free to let me know. And see you next time. Bye bye. Come back to my channel. Just after checking the GPT announcement video, I feel that it would be useful to share some of my comments for your reference. So basically, the first question I would ask myself is that how do I feel about this upgrade of the product ChatGPT? The GPT 4.0, I already tried this model. I do not find it very impressive because what it brings to me does not change much, especially some of the functionality will be introduced next week or in later days. At this moment, I do not see that it has superior speed upgrade or it has a very huge gap between the other models like in HuggingFace. As if you check the HuggingFace, the different people who work in HuggingFace, they post the model evaluation, multiple metrics you can check. It's not very evident that GPT 4.0 is really a very big breakthrough. So then, talking about different GPTs or two phones, both has GPT 4.0s talk with each other, is similar to agents who talk with each other. We know that with open source community resources, we can now create agents locally, and this functionality just brings that talk to voice and make sure that each function call or the interaction between the agents are more smooth. So I also do not see much improvement compared with the open source resources that we can have. The problem is that if you want to make the talking agents to make the text to voice, you need to integrate more tools to your pipeline, to your workflow. And of course, like LangChain and different tools can help you to realize that functionality. About like this example of sarcasm with GPT-4o, for me it is still a problem of agents. So the agents could have personality, have some specialty to do something. We can design it, and especially with the RAG, and also like the tools like a line chain, different framework interchangeably work with each other. The agents or the workflows can work much better than before, not like a random walk in the large language model. So now they can be more focused, they can have personality, they can solve a very specific task, a very nuanced task, um, and more specifically, you see the live demo are all the simple examples. If you go to chat with this GPT-4o, like what we did before, ChatGPT, please give me a joke, or be sarcastic and give me a response to a certain chunk of text, it can do that. But if you compare only this text generation to Grok, or making the ChatGPT GPUs compared with LPU, you're going to realize that ChatGPT has reached a certain limits of the innovation. So we need to keep an eye on the new products and new improvements in the open source community in the next weeks. From a product point of view, I mean, the display of dog meets GPT-4o is funny, interesting, and some people would think it is a kind of interaction. This kind of interaction with AI will make your life with more color, or make your life more joyful. But from a point of view, it is not so useful. And the real-time video to voice, um, I I can only see that they have a much more computer upgrade uh, for the past few months, and they can now process the video faster, because videos are piles of image recognition is nothing new, and also the image to text and to voice pipeline is already a very mature pipeline, so there's nothing new here for me. It's interesting but not new. Then about the real-time translation, Google Translate some time ago already achieved that. The problem is about the translation quality. Now there are many AI tools to enhance such functionality to make sure that the live translation could work more smoothly. And I already tried some of the translation with GPT-4o. To be honest, its quality to from English to, for example, Italian, it's the quality is still medium. It does not change drastically from the previous version, like ChatGPT 4. So my final point is that as we have this more potent, more able tool in our hands, like GPT-4, GPT-4o, we still need to focus on the development of open source community, because in the end, the free open source resources that we can utilize, implement in local environment, will prove to be more valuable if you consider different variables. Like if you consider privacy is paramount, if you have many domain knowledge sets, domain data sets that you want to work on, they should be more useful than the large language models in the cloud. Because I also see some opinions which says that the large language models in the cloud or trained by others serve for uh, the trainer's objective, is not for everyone, because I totally agree that user case is in the hands of the users. So I would like to see the option that the users are empowered to solve their user case using the local large language model solutions or implementations. So I really encourage you to keep an eye on the development of the open source community in response to the GPT for all new functionalities. Uh, that's all for today. This new announcement from ChatGPT OpenAI is quite interesting. So I just give you some of my thoughts, and I wish you like it. And see you next time. Bye bye. Today I'm going to share with you two of the use case I have tried with AutoGen. So basically for the past few days I have been trying to use Llama Index or use AutoGen to create the workflow, the pipeline utilizing RAG. But using Llama Index, I found that there are more complicated parameters during the coding I need to configure. But with AutoGen, because we already have some successful example of conversible agents interact with each other, so I decided to come back to AutoGen. And here I present you two use case. So number one is based on their case example. It's called perform research with multi-agent group chat. So basically, if you are interested, you can check the official documents, but I'm going to show you the adapted version. So basically, at first we need to import the relevant package and also set up the large language model configuration. So I'm not using API, so I use LLM Studio. So I need to follow this format to actually set up the local LLM interface parameters. And then we need to actually configure the different roles, different agents. This part actually is the original example from the official website of AutoGen. I use this as a template to interact with ChatGPT to help me to modify it to adapt to my user face. I have to say, ChatGPT has the ability to adapt it to a very simple version, so it does not always get to the point of different configuration inside of each agent. Example, if you ask ChatGPT to change this code to adapt to your user case, for example, like here, human input mode never, this kind of very detailed points may be ignored by the large language model. So I encourage you to read carefully of the documentation and make sure that each choice of the configuration is adapted to your user case. So below are the change code. You can see here, first of all, I need to make sure that I imported all the relevant package and the elements inside the package. Then I set up this thing. Basically, this is a simulation of a bank, which it has a general manager, chief compliance officer, and the compliance manager, chief operational officer, operational manager, and the general. And I created this group and let them to interact with each other. So if you want to check how I set up, how ChatGPT helped me set up these roles, you can check here. But again, if you want more in-depth results or more insightful discussion, you should change the parameters like the system setting, like your prompt accordingly. After setting all the roles from on this part, we have all the agents ready. Then we need to set up the group chat part. So it actually defines the group chat, how it interacts how the agents interact with each other. So basically, you need to have the agents, which agents you want to involve in this conversation. And the other important thing is that the max round will actually limit how many rounds the conversation will go, and also to make sure that there is a selection method of which one is the next speaker. Of course, you can also design a very complicated, for example, which agent should speak 2 times or 3 times. You can, of course, define a function which will complicate the situation and provide you with more control. Otherwise, you should follow the speaker selection method, and in the official documentation and also in the description, you are going to find the different ways. This is like a default vocabulary, default dictionary, different types of the selection method. And if you allow the speakers to repeat. Okay. And then let's see, the next part is about, I think it's a default setting. So for every initiation of the group chat in AutoGen, you need to have a manager. Is a parameter. The manager will hold this talk of the group chat. It is a group chat manager, but the group chat manager is going to hold this parameter. First of all, which is a group chat you have defined, then which is a large language model you have defined. So we just use a simple case. Our large language model is a Mistral or Llama 3 on local environment with a LLM Studio, so it's quite simple. So I will ask the CCO, because the CCO is also the user proxy agent. I did not change this part. Of course, you can try different setting, but usually in the pipeline, you need to have one user proxy agent. So I leave the ChatGPT recommendation here. I do not change it. And the prompt is how to create a suitable AML policy on transactions. So this is based on my work experience. I want to dive deeper in this topic. I'm going to show the result below. Before that, whenever you meet error here, for example, sometimes AutoGen website will give you example. For example, it's a string. Okay, so string only have the later part. Sometimes it works, but sometimes it does not. So the strategy is to read the error code carefully. So if it is not passing the information correctly to the different Python functions in the environment file, in environment folder, you need to inspect it carefully. For example, here, if I use only a string, or I use this whole part as a string, both parts does not work. Okay, it may be my local environment problem, it may be the problem of my setting, but eventually I change it to this format, it actually works. Okay, just a reminder. So if you meet a problem, you need to investigate for the reasons and adapt to it. Another thing is that when I see more complicated errors, I try to inspect the environment code. It is super complicated. If you want to change that code, you need to tread with caution. Okay, otherwise you may make additional problems. So let's see. Okay, so the chat actually goes on, and because I did not say user input is false, so each time the conversation comes back to the CCO as user proxy, I always need to input my my prompt. For example, here I just ask them to go on. So this conversation goes on until I say terminate. Move to the next part. So this part is based on the official documentation of AutoGen, introducing group chat with retrieval augmented generation (RAG). So in the official website, it actually introduced the workflow where during the conversation there is a coder to write the code and to execute the code in the environment. And there are many specifications inside. If you are interested, please check the official website. But to my use case, I want to adapt it to my use case. It's called internal audit debugger. To design a internal audit debugger, actually you need to think about the different things. First of all, you need to have a existing workflow. You need to have some work results. You need to have the internal audit procedure. You need to have the different teams, right? It's quite a complicated picture. So before I go to that complicated situation, now I only ask it to set up the internal audit policy, procedure, and regressively check its validity with simulations and scenario simulation. Let's see if the agent group can do it. So here is a prompt I show you first because this is actually the core of the user case. So let's come back up. First of all, we need to install the dependencies. If you're missing something, no problem, come back to pip install. That is quite intuitive. Importing all the dependencies and also set up the local large language model. I'm using LLM Studio. And also about LLM config, this is a standard setting. Yeah, just make sure that it adapts to your user case. At this moment, I do not change it. It is as the default example. And here there are definition of some functions to the function of reset all the agents. So to avoid that the agents may store some information. This is my assumption. So each time it's safer to restore all the agents to its original state. And here is also a termination message function, which actually can put inside of the agent as a property, as attributes. So when such conditions meet, for example, if there is already a message generated, and also there is a terminate wording inside of the message, function will provide you with such functionality, and it is optional. If you don't want it, I think you can leave it out. Then in the below part, because I suspected that passing the PDF file to the agent, especially the RAG agent below, I suspected that sometimes it may not interpret the format of the PDF very well. So I add one step here, actually, to first of all install the dependencies and run the code to actually transfer this knowledge that I have to a local markdown file. So in order to let the code to interpret the text string in a easier way. Yeah, but of course, if you try the PDF format, it works. You do not need this step. Okay, this is just a step to transfer the online PDF to a more could be easily handled empty file in local environment. Then we define the roles. In here, it's very interesting because actually in this official example of AutoGen, I find like the auto reply, it always have a reply terminates if task is done and confirmed by everyone. So originally, I think it was simpler, but I actually make it more complicated. So basically, original example is to terminate. So I say terminate when everybody confirmed that the task is done. And first of all, you need to go on with the discussion. But you can also change this part to different content just to try. The description, of course, is basic description is like a job description. It's quite intuitive. And here the name is not an important variable, but you can set whatever names you want. It will display in the conversation. About human input mode, like I said also before, if you are user proxy, if you don't define it, it will ask you to input a prompt. If it is actually set as never, so it will not ask you to input anything. The boss 8 Actually, this name I did not change from the original example, okay, but the content I changed. So basically, uh, the default auto reply is working on current task. The important part is here. Retrieve configuration. Retrieve configuration actually defines, for example, the task, the document that it needs to do the retrieval, okay, and the chunk size of the processing of the document, which is a model, and so on. I try to make as much as default because I really want to see, first of all, how this code can run. But during the different tests, I found that, first of all, the task, all the variables, you need to check the environment Python file to see what are the limits, what is the range that you can put here. For example, here the task original example is code, which means that the both agents will perform the coding retrieve configuration. So you need to be careful. So I choose default because this is one of the options. I do not want it to do coding here. And also pay attention to the doc path. If you do not use my previous code to transfer the online PDF to the markdown file, you can change here directly to the PDF. It can read that. It's no problem. The chunk token size, at this moment I'm still trying for different value. I do not see any difference, any obvious difference here. So when actually the system is doing the RAG pipeline, it will actually retrieve the chunks to the conversation. But here I do not see how that workflow is in detail constructed. But if you evaluate, you try to check the environment file, you may find some clue. At this moment, I want to keep it as simple as possible. About the model, if sometimes you find that the model name is actually checked in the pattern file, in a different pattern file, you need to go to the Python file and to add it to the list. So basically, AutoGen originally recognized several models, but some models are not inside yet. If you have sometimes this kind of error, like the model is not found, you can actually add it to the dictionary of the file because it's all everything you can modify. So just pay attention to that. And one thing to mention is max consecutive auto reply was set to less than 10. I try to set to 10 or cancel. It does not change my use case now. Okay, but you can also try that. So basically, there are so many different parameters you can change, and I would suggest to stick to your use case. If you want a quick result, just make them as simple as possible. Follow the default example. So let's move on. Here about the coder and the reviewer, I leave it here. I do not want to touch it because maybe in the future I can use it. Okay, and I'm not going to quote these two agents in my following code, so I leave them here. Important thing is that now I have the internal auditor and the accountant, so they also have the different roles to play in the conversation. Next, as in the beginning I said, the problem is a prompt that you need to think and then make it ready. Of course, if you want to make it more complicated, of course, you will get a different result. So next part is about the definition of the chat function and also run the chat. Just for our convenience, I already put the calling of the function directly in the same code block. So when I define the chat, I can go on execute it. So in this function, I did not change much of the structure from the official example. First important thing I want to share with you is that here, the LLM config. This part, if you have any error, do like this. I just make the Mistral this model configuration to this LLM config variable again. It will solve the problem. Sometimes it will say, okay, there is a string variable problem on this part, as you see here. In the AutoGen group chat manager, in the assigning of the variable, this part, it will show consistent error. So one way to solve it is to attribute, to put this Bistro or any model you like, this model structure again to the variable. It will solve the problem. This is point number one. Point number two, here about the initiation of the chat. Of course, this is a standard format. Number of result is actually linked to the vector database doc ID. My assumption is that if you use it as 3, it will actually separate your original information to 3 documentation. What happens if you change to 3? I always get error. So my assumption is that it actually changed the structure of the vector database. Okay, because you need to separate the documentation, put it in a vector database so you can query fast. This is a standard rag. I believe AutoGen follows the same methodology. But if I'm wrong, please check the official documentation. So at this moment, if you change to 100, 50, or 30, you can get different results. When I change it to 100, the code works. Okay, this is by far what I can tell you. And here you can also see Mistral model not found using CL100K base encoding. So based on different model you select, the backend Python file will choose a different encoding method. About that part is quite complicated. If you want to try, you can also change the default setting. But for me, if I use Mistral and it's not found, it's no problem because eventually there is still one of the encoding method here. Okay, so come back. The group chat definition here. The players, of course, you need to put inside. Pay attention that 2 players are considered as a very limited group. Usually, you will get a prompt in the running of the code and saying that 2 players are too less. You can try to add. Okay, so the other are standard. So if you do not want to implement a very complicated speaker selection method, just like this one, I use a round robin. You can check the official documentation to see its detailed meaning. Then here, like you see here, I run the code. It actually goes to separate the document to different chunks. It's very, very long. And here it starts the conversation. So, like you see here, you are retrieving augmented chatbot. This part is nowhere that I have is in no place that I have defined before. So I guess this is system prompt, system definition, because originally this example matches to a situation where there are a group of agents talking with each other, and this boss assistant will write the code and provide the result. But here I have not changed this part because I have not found the place to change it. I believe it is a default setting. Of course, you can change it somewhere. Let's check the output carefully. So I actually copied it to an MD file. You can see here the vector database actually have a lot of docs. I think it's just 100. And this is what I said to you. It should be the default information. And here, user's question is, this is my prompt. Okay, so actually first it actually retrieved the below context. I think it's not useful because it's getting the index page of the book. It has nothing specific to be helpful for me to do to implement my idea. Okay, it shows the source of the context is this one. Actually, this one is correct. Let's see here. Yes, we do have this markdown file. I think also saved in here. Yeah, internal auditing handbook. Yeah, it's right. So showing this source is okay. And you see, I think this is also system default message. If you can answer the question in the end of your answer, add the format of source 1, source 2, source 3. So my assumption is that if you add more regular resources like different websites, it can also show here. I already put it in local environment as markdown doc, so it's shown like this. Okay, so as we can see here in the previous results, we see a lot of acronyms and a description of the different short names of the entities. And in the later conversation, actually there is only one player talking, internal auditor. Actually just said, okay, these are related to the internal auditing. And it is not very useful because it just repeats the answer and stop. So the reg process here in AutoGen or either in Llama Index after some examination, I think is quite complicated. You need to configure it with more careful way. Okay, at this moment, I'm going to stop here. I'm going to show you the non-reg version. So basically, if we go to the non-reg version, the format does not change much. The most important thing is that the reg agent is not included in the agents list. So which means that the group chat will not do the reg process. So in this sense, it should be more straightforward and less complicated because it does not rely on the outside source to the conversation. So after running the code, I get this file. I already copied it to the markdown file, as you can see. So basically, the boss will start to chat. Okay, is okay. So there will not be the boss assistant, and the internal auditor starts to draft the internal audit policy. It looks fine, makes sense, and here the internal auditor actually continue the simulation and validation and recommendation. So about the simulation, actually this is a quite simple content that is generated. Of course, if you are going to do a real world scenario of the simulation, you should define different attributes. For example, which employees does what, with which system, what is the document flow, what is the data flow, and what is the direct result of this workflow, and how to check this work, how to check the process. Okay, very related to the auditing process. But here, actually, it kind of introduces some of the concepts. And also in here, the validation part. Yeah, it's like introducing the concepts. And of course, the recommendations based on these simulations, it can offer you a framework to think further. Okay, but at this moment, I do not think all these results can be used directly. Then the conversation comes to the boss. Bosses go on with the discussion, and so internal auditor actually continues to define the roles of the company. Okay, makes sense. Discussion complete. And then still internal auditor actually terminate. Task is done by everyone. Then the boss said go on with the discussion, and the internal auditor continues. So because there are not many constraints, actually the conversation just starts from the boss, stop at the internal auditor, then come back and forth again. So it also tried to go on with the discussion with chief auditor, but there is no definition of the chief auditor agent. At this moment, I think it actually simulated a situation where many roles, like all the roles defined in the auditing process of the company, are not included in the agents list, but it actually simulates a situation where these imagined agents gave a comment. This is quite interesting, but in a very practical view, the agents should serve to discuss and summarize their own content, but not suppose the third party to give a comment to their conversation. As I said, you can change the parameter actually to improve this part. Before we conclude this video, I want to share with you also the description file. For example, whenever you put the cursor above some of the class, like the group chat, okay, different code parts, it will show the documentation. It's very long. You have many things to configure, and I recommend you always read it carefully because it's not 100% reflected in AutoGen website, or it's structured in a different way. You may not consult these contents very easily, but really you can try to find this content in the code, copy it in a markdown file, and you check the details. So just a quick wrap up. Today we have tried 2 examples of AutoGen. First one is perform research with multi-agent group chat. We have adapted to our own user case. The other one is group chat with retrieval augmented generation. Both examples we can now execute, but as I said, if you want to further get more insightful information and to interact with third party or the outside the knowledge base more effectively, do read the documentation and try it in your use case. I wish I could create a more complicated use case in the future and share with you. And by far, I think we can already start using these tools to generate some ideas and to inspire our work, our study, and our daily life. Thank you. If you have any question, any doubt, you want to see any different exploration of different code about AI, about large language model, and also about finance, and also about the data analysis, feel free to leave a comment. If you like the video, just give it a like. And furthermore, please subscribe. See you next time. Thank you. Bye bye. To change to some easier topics like statistical learning or supervised learning. For most of the cases, I think it will be very useful for our data analysis to prediction or classification different type of the task that we'll meet on daily basis, either for learning, the statistical learning, or to use in a real world scenario. They are quite useful. This is one of the I would say test I would do from every now and then. It's called comparing the models. As you can see, first of all, I showed you a summary that usually when I compare the models, different models, first of all, I need to know the data. Today, I'm going to show you the data set from the Kaggle. Is a credit card default data set. I know it is very intuitive. Most people use such data set to train a model to predict if the client is going to default next month. It's very useful, but the first step, you need to know the data. You need to know every column, what it means. I'm not going to show you here, just to keep the content as concise as possible. Second of all, you need to do standardization. You need to separate the numerical and categorical data. So numerical data you can calculate, just standardize to do not let the size or the sheer volume or the amount of a variable impact the model too much. About categorical variable, the common practice is to convert it to dummy variable. During my test this time, as you can see here, in the compute side, first of all, I count mainly the runtime of each model, how much runtime it will cost to train the model. So like the k-means neighbor, decision tree, random forest, and so on, I use a very simplified parameter setting, and most of the code are generated by ChatGPT. I already checked it. It seems good. I suggest you also to do this test because it will help you to understand how much compute each of the model will cost. Then about the complexity and the interpretability. For example, like complexity, ChatGPT gives me complexity, is like a complexity measure. I have not yet 100% matched them to the very rigorous academic representation. But about the interpretability, I think it's quite accurate. For example, like a linear regression and logistic regression, you can interpret the change of the independent variable to the dependent variable quite easy. But about the neural network, I believe you already know that we have multiple layers of neuron. We have activation function. There are so many changes, so many detailed calculation inside the model. It will make it very hard to explain. And also for the transformers model, like the large language model, the structure is very complicated. We cannot easily interpret such model. And then if we are going to look at the number of parameters, you can see like a neural network has very large parameter sets. Of course, you can arbitrarily reduce the size of the number of parameters, but in any way, the runtime to get the similar results will be the highest for neural network. And for random forest and gradient boosting, you're going to have also much higher runtime relative to the simple like linear regression, logistic regression. Then, whenever you want to go deeper to analyze each model, I really suggest to get into the overfitting part first, because when you have this model, your objective is to catch the more generalized pattern to apply to the neural case, to the test data which you have never seen, the model has never seen. So whenever you use the existing data to do the train and the test data, to separate them and to fit them in the model, whenever you see that train accuracy is higher than test accuracy, note that the overfitting is present and you need to address it actively. Today's code, I'm not going to dive very deeper to the overfitting resolving issue. I'm just go through it quickly and show you some of the sample code that ChatGPT gave me. The final point is the solution of overfitting. As I said, you need to check deeply about each model configuration and to see for cross-validation, regularization, and hyperparameter tuning could be suitable for resolve this issue. About cross-validation, it is to get a better estimate of the model's performance. I think the more common approach of the complicated models is to introduce regularization and hyperparameter tuning. Now let's go back to the code. So basically, in order to run code, you need to install some packages about pandas, numpy, skitlearn, matplotlib, and seaborn. These are very common libraries. Then about Kaggle, I want to mention to you, if you want to use a Kaggle package, you always need to have the active API so you can download directly. I did not put much time to configure this part, but I leave it here just to remind you that there is a possibility to download the dataset directly through your code, but you need API key configuration. Then Plotly is for actively or dynamically display my data, all the different metrics that I need to evaluate the data and the model. MB format is actually part of the package that will interact with Plotly, but I did not get a successful result, but I leave it here. So whenever the system says error about this package, try to install it, reinstall it. If it does not work, check documentation. So about the several steps before the final code, of course, I interact with the large language model. I try to teach it to find the very detailed problem to refine the model. For example, I already have the structure, I have some code written, but ChatGPT cannot recognize the necessity to transform the numerical data or make certain categorical variables as dummy variable. So it is an iterative process when you talk to large language model to refine the code. But in general, these, I would say, quite simple models about regarding the model design, they are quite simple. The zero shots or the accuracy of writing the code with a large language model will actually help you to improve the efficiency of writing the code. Okay, let's go on. So first of all, we need to read the data. Okay, about the first two lines, if you do not have the Kaggle API, usually it does not work. So I actually manually downloaded this dataset and save it in the data folder here. So I use Panda to directly read the dataset, of course. Then I prepare the X variable and a Y variable based on my need, and also to transform the numerical variable, categorical variable as I need. So basically, you need to pay attention to all of these details. You need to understand your dataset so you can work better on it. Then this part about showing the correlation matrix is not 100% necessary, but if you want to visualize the correlation between different variables, I suggest you to do it. But remember here about the sex, education, and marriage, because they are categorical variable, putting them here is not 100% necessary. I suggest you to delete it. But if you put here, just don't refer to it as main issues or the main influence to the dataset or to the model in a numerical sense, I mean. Then we can see here, we actually split the data to training data and test data. Okay, this is a common practice. Then define the evaluate model function. Actually, it will record the runtime, which I personally would like to check every time to see each model consumes how much runtime, which will refer to the compute consumed. And of course, we are going to use a different function to actually to train and to get the different metrics which we are going to display later. So each of the functions, each of the equations will actually help me do that. For example, this one is going to help me get the train accuracy matrix, so I can display later. And in the later part, of course, ChatGPT was helping me to add such if condition passage to actually capture some of the information I need, like number of parameters, coefficiency number. The size means that how many coefficients used in the model, how many layers, how many features, okay, and to actually summarize these information so I can use later. So eventually it will return all these metrics so I can compare later. So about the model definition part, because we already imported different packages, actually most of the models are ready. I mean ready because we already have these packages. We can easily write in the code to implement them. As I said, like the different parameters in different function, you are free to change them. Or if you want to do further experiments, you can use a function to change it. For example, each time you change it by 10 units or 1 unit of each parameter you are setting here to see the difference. Okay, sometimes I do it just to check the different model performance. Then the results will be will be collected. So for the later comparison, and the results are going to be set or be saved in this data frame. So in the later part about the results data frame, I use different strategy to plot them. For example, this first one is quite intuitive plotting. I observe that for most of the model, they have the overfitting problem because training accuracy is higher than test accuracy. And I can also see that although the neural network has very large parameter count and also consumes the highest compute, local compute resources, but its performance is not very, very high compared to other models. And we can also see here mean squared error is a matrix to see the diversion. I would say the diversion from the actual value to the model value. And we can see that for some models, it does not have such matrix, so the system cannot produce it. But whenever we see if the test MSE is higher than the train MSE, this is also a way to see that the model is overfitting. To the later part, of course, this one was the same graph. Of course, when you try to visualize it, you can change the size of the graph. But at this moment, I cannot resolve the issue of the display because you see gradient boosting. The display of the chart was not very good because you see the I think is a test accuracy bar is quite out of range. But do not worry if you meet some problem like this. I'm going to show you some solution like Plotly library. And here I did introduce the 3D plotting of the results to see the test accuracy, which I care a lot about, and the runtime, and in the z-axis we see the mean squared error. From here, it's not very easy to observe, so I would recommend you to use Plotly. So first of all, let's try to display the 3D graph of the different metrics. If we run the code, we're going to see here. Okay, so actually it jumps into this HTML file. I think it's very easy to visualize, and you can change the different data you want to visualize. For example, I want to see train accuracy and test accuracy. Okay, so I have this pair of comparison about the train MSE and the test MSE. Okay, so in a dynamic way, it will help you to visualize better. However, I did not change much of the code. The original code generated by ChatGPT stacked them together. I would suggest you to change them to make them separate because they do not have a stacking relationship. But if you are going to see only pairwise comparison, this version is enough. So let's see here. This is going to show us the runtime, test accuracy, mean square error, the 3D plot. And here we go. You can see here, when we actually rotate the 3D display, you can see the position of different models. Of course, if we only care about the runtime, we can see here we have a neural network is way further away than the other models. And here, if we only care about the mean square error, you can see decision tree actually has the highest mean square error. I think this is training mean square error. You can check the code and change a variable to compare. Now about the complexity summary of the models. These are generated by ChatGPT. I think most of them make sense. The only thing I'm not sure about is about the equation for complexity. I think it is utilizing the number of parameters and the different variables to display. But about interpretability, it's intuitive for different model. Of course, we find it easier to interpret or harder to interpret. As I said, the simpler it is the model, the easier you can interpret them. About the last one, let's see the chart. Okay, actually this one is about runtime, number of parameters, test accuracy. Okay, so if we look at here in this way, the test accuracy does not have a significant relationship with number of parameters, because you see here in the group where we have the highest test accuracy, actually most of the models have less number of parameters than neural network. Okay, and we can also see in this way, in the runtime sense, neural network is the slowest one. So this is part of the reason that when we train a huge neural network, it will cost a lot of compute, and most likely they are not suitable to run on local machines. Then about the runtime and test accuracy, see it in this way. Just 1 second. So most of the models has a similar runtime consumption, but about the test accuracy, it don't change much. But you can see here, gradient method, gradient boosting, has the highest test accuracy, and the runtime is quite reasonable. By reasonable, I mean because we have a relatively small data set. When you have a huge data set, you need to introduce different strategy to handle such huge data sets. I wish in the future we could discuss some of the implementation of the methodology to handle large data sets. Now about the final part, as I mentioned before, overfitting is always an issue. I would suggest you to pay attention to it, and if you want to address it, use different methodologies, do more tests to understand which one is better to actually. I think models are like animals which are not contained, because if you are not contained, you may go to a very long range and you are not confined by your target. Regularization is like a way to actually make sure that the animals know their target, know their prey, so they could focus their energy to that target, to that objective. So this part I'm not going to go any deeper. As you can see here, if you interact with a language model or with your domain knowledge, you can design further code to actually test the different modification, either by the hyperparameter or some regularization terms to make the models work better. So today's introduction or a sharing of experience, I'm going to stop here. So just a quick wrap up. I would suggest you to test different models to deeper the understanding of the model's compute consumption, accuracy, overfitting problem, and how to test them repeatedly and to use them in your real world dataset to actually see if they work well. And about the overfitting issue, remember, I'm not introducing you now because I don't want to complicate the focus of this video, but I do recommend you to pay great attention to it. It will make your model more balanced if you address the overfitting issue properly. Okay, so thank you very much for the attention. If you like my video, please share it. Please give it a thumb up. And if you like my channel, please subscribe. If you want to discuss anything you like, you have any suggestion, leave a comment. And I'm going to see you next time. Thank you very much. Bye bye. Hello everyone, welcome back to my channel again. Today, let's explore the embedding models together. This video, we're going to, first of all, introduce some of the embedding concepts with the help of large language model and cross-check with online resources. Then we're going to the coding part to actually try different embedding models, which I chose for simplicity, just some basic models, and we try to visualize all these models' results. As you can see here, this is a screenshot of HuggingFace. HuggingFace has published many open source embedding models, which you can try. And you can see there are different benchmarks to actually tell you which model is best at which area. So basically, for embedding models, we have word embedding, sentence embedding, and the document embedding. Here I write document embedding as chunk embedding, but it refers to the document embedding method. So basically, from my understanding, different embedding models in the three categories, they serve for different purpose. Mainly differentiate between the context window. For example, if we have one word, we have one sentence or chunk of text, the embedding models actually works differently to generate different outputs. So according to this graph of importance of embedding, I think it touches most of the important area which embedding models are working to improve the different performance of different models, I would say. For example, like in machine learning area, natural language processing area, information retrieval, and knowledge representation. But for now, I think for natural language processing, like the large language models, embeddings are really important for us to find the meaning of a specific token of a text chunk to actually make it numerically representing in the workflow of the large language model. From the beginning, it transfers your prompt into the embedding, and also when it processing the large language model, throughout the model, it does all sorts of calculation. Then the output text was also transformed from numerical values. So it is very important for natural language processing. This is what we are going to focus on in this project. But for information retrieval, like the search, also for our RAG workflow in large language model, it is also very important. Then, from a different angle, if we focus on the large language model related embeddings, as I said, we can see different types of embedding as I introduced in the beginning. We can see the different application of the embedding models, and also we need to understand how to measure, how to see which large language model, embedding model is best. So there are different scores, and as you can see in the beginning, you can also check the HuggingFace leaderboard to understand which embedding model is best for a certain range of use case, or in general, which one performs better than the other one. Then, if we take a look at the mapping of different models to the different categories, we can see that it is not always 100% separate. Like you see, the GPT embedding model has been linked to both document embedding and word embedding. So for this kind of context or concepts, I think I will try to explore and explain in the future in more detail. At this moment, I do not give a conclusive comment because I still need to learn about it. Now, let's see how these embedding models can work. So basically, with the help of large language model, I refine my code and present you as below. First of all, we install the different dependencies and we import different modules and also the embedding models. The first one is called Spacey. The second one is Universal Sentence Encoder. So the first one will be used to embed the information or transform the individual token to the numerical representation, and the second one is going to transform the sentence text chunk or a specific length of the text chunk to numerical representation. Here I try to get the Google News. For example, I get the news with a topic with AI, and I'm going to compare this news, or I'm going to process this news single word by single word, or sentence by sentence, or chunk by chunk. So basically here, I'm using the package of GNews, which I find it very convenient to do a lot of exploration of the dataset which is readily stored by Google. So here I fetch 4 news from the package and for the further analysis. Then by introducing different functions, we actually vectorize, or in another way, transform different text lengths to numerical representation. As you can see, the first one is to actually embed each token. The second one is to embed each sentence. The last one is to embed different chunk. So after defining these functions, it will make a summary or an all-in-one process more structured. In this part, we are going to visualize different embedding results. So basically, we are going to check how they are represented in numeric field. But pay attention, I'm not using the vectorized visualization. Here we can see after choosing the one article as a sample article, we actually have the embedding numerical values in a 2-dimension graph to visualize the situation here. So like the first one is by each token, you can see the words are quite scattered around the range, but you can see some words are very close, some words are very distant. But to actually understand which words are close or far away, you need to have different ways to measure similarity. The very famous cosine similarity, or I think other distance calculation, could be implemented for you to understand a more exact value of the distance between the different tokens. Then, by stepping into the sentence embedding and text chunk embedding, like this is 100-word chunk, this is 200-word chunk, we can see the text are put into a more bigger chunks, so we can see the scatter plots, the scatter points are less each step ahead. Then after visualizing all the results, I think it's better to cluster the results to have a better visual. So here I actually implement the cluster methodology like a k-means cluster to see how many groups or a certain number of groups, how are they represented in the graph, and to sample some of the grouped words, grouped sentences to see if the models work well. So as you can see, the first one is about the function to apply clustering, and the second one is about visualize the clusters, and there is also the function to sample similar items. And we're going to both show the sample and to visualize the results of the embedding models. Here in the first graph, as you can see, because we are condensing the multi-dimension numerical values to a 2-dimension range, you do not observe a very good representation by the cluster, but I want to say that if you choose k-means cluster, you choose other cluster methodology, you are going to have different results. But here you can see some of the clusters, they actually intertwine with each other or intercept with each other. So what does it mean? It means in a two-dimension visualization, it will project the multi-dimension numerical value to the two-dimension visual. So it is inevitable where you cannot capture all the characteristic of all the embedding numerical values. Let's see here some of the examples. Like cluster 2, we have both words and non-words value. And when you check like a move, motto, hunt, for me personally, these words do not make much sense in the same cluster. I would say they are quite distinct, they are quite different. Then if you check cluster 3, fast, break, things, that, too. For me, they are not very obvious to me that this cluster is a good cluster. Then if you check the other one, and is a continuous. For this one, I think more or less it makes sense. Like and is these words do not hold a very important meaning, or I mean in a word space or in a sentence space. So I think they can be grouped together. But as you can see, the understanding of the embedding models, when you sample a certain clusters, some words, or even some sentences, you are going to see some of the understanding of the different model is not very intuitive. So you need to do more tests, do more experiments, and to read the description of each model to understand how it does its job and how it is being implemented in different use cases. Now, when we turn our eyes to the sentence embedding results, of course, they are also clustered into 5 different clusters. As you can see, for example, cluster 1, for me, it seems like these sentences are from the same news piece, because in general, it is step-by-step explaining a central concept or a central idea or central opinion. But as I say, you can examine by yourself to give your subjective opinion based on your understanding to see if this is a good embedding result which lead to such clusters. Then about different text chunks and the cluster representation, I really suggest you to increase the sample size because I only have 4 news from Google Genius package, and as you can see, the data points are not many. So if you want to check in a greater sense, to check if the embedding model could work on an increasing number of the articles of text chunks, you should increase the sample size and try another way to systematically decipher the results. Because if you manually read each of the news, you cannot decipher so many information in a short amount of time. And I believe you cannot, or in general, people do not have much time to check every detail. This, my personal opinion, would say that it is hard to examine a large language model, embedding model by yourself. You always need a systematic way to try to measure the results in a benchmark or in a visualization, and also to refer to like the HuggingFace leader chat and so on to really understand how these models work. Then now let's see what the GPT interprets the results I presented before. For example, like the word embedding results, you can see it comments that the words like model, hunt, move, which could indicate a thing around a significant quote or phrase. Then let's look at the sentence. The sentence embedding, like cluster 1, contains sentences discussing models and their historical context, which seem coherent. So you need to understand in one way or another to see if such cluster resulted from the embedding value makes sense. About the 100-word chunk embedding and 200-word chunk embedding, if you are interested, of course, you can check both the results or with the ChatGPT to better understand the results. Then, since we may visualize the maximum 3D space, I would recommend you to always visualize any result in a 3D space. Either you use 3PCA to actually divide the features into three axes, and here, because when I iterate my code, I actually get an error with MB format, so I actually change the results of the 3D representation to a local HTML file. So later, I'm going to share with you. So basically, the code structure is similar. Import library, function to apply PCA. It is a principal component analysis. I think it's very useful. It's like projecting the features of the numerical values to a condensed dimensions, like two dimensions, three dimensions. Then we also set the function to visualize in 3D HTML and eventually write this file in local environment. Of course, you can choose the different directory as you want in the code level, or after you generate the HTML file, you can save it as you like in your folders. Then there is function to cluster the embeddings. Of course, this is similar like we did before, but I want to say that to you, the cluster and the PCA, they are not the same things, so they don't interact with each other. As you can see here, I did some experiment to do PCA 6 principal components, or 3. It is just for my curiosity to check if the code works, but in reality, you don't need to do that. Then we also have the function to sample similar items from the cluster to visualize, and there is also the implementation of the word embedding and the display and the sample to actually call these functions to perform their purpose. As you can see here, this is a screenshot of the 3D representation. Actually, from here, we can see that in a 3D space, actually, you can see the difference from the 2D display I shared with you before, because you can see now the clusters are more better grouped than before. So this is because whenever you increase one dimension, you are going to see additional characteristic. It's like when you look at this group of data from the top surface, let's say, and you view them as a two-dimensional space, some of them are going to overlap. But if you increase the dimension, you're going to see a different result. The same, when you apply the 3D visualization to different embedding results, like the sentence, or even the 100-word chunk, 200-word chunk, you're going to see different results. I really do encourage you to try them and also check the results and make sure that you understand the embedding on the different contextual sequence to better understand if the embedding models work well. And here, as you can see, if we see the two-dimension representation of the data points, it actually gives you a different sense. So I encourage you to do different experiments to actually see for yourself the cluster, the embedding results, and to see if it can help you to improve your model, improve like your processing of the information retrieval or the processing of different steps of large language model. Now let's come back to this graph in the beginning. So in this video, you see that I have introduced some embedding models for different embedding tasks. Then I tried to examine the embedding results, visualize the embedding results, and I would say the choosing of the model or the examination of the model in this video or the contents are only a small group of the every possible models and every possible ways to examine the models. So I really do encourage you to try the different open source models or closed source models as well, and to apply to your use case to see if they can really perform very well. So I wish you like this video. If you have any comment, please leave below the video. If you want to subscribe, please do subscribe. And I wish this is useful for you. If you have any doubt, feel free to leave a comment and we can discuss anytime. So see you next time. Bye bye. Hello everyone, welcome back to my channel again. Today I'm going to show you one of the exploration of the datasets that I have done yesterday. It's about the SMS spam collection dataset, which you can check in Kaggle website. This dataset is about a bunch of labeled SMS message, and it's a good dataset that you can try different algorithm to analyze the spam SMS message. Here you can see the first step is to load the dataset and to check some of the statistical property of the dataset. I want to say it to you first that or the methodology or the check of the different metrics may not be exhaustive. So if you are interested, please use your preferred tool to explore the dataset first. As you can see here, the first thing I want to explore is about its distribution property. So I choose the histogram. But from the histogram, I think I lack some of the information, so I would like to make them together and to see in the later part. As you can see here, when I put them together, it is very obvious that the non-spam, which is called ham message group, is much larger than the spam message group. I do not have the percentage count here. You can try it. But only from here, I think the spam message is a small group and by nature is quite difficult to detect. If we took a look at the density distribution histogram, you can see that basically the non-spam group is very dispersed in a very wide range of the word count, but the spam message are quite concentrated in a relatively small range. Starting from here, I'm going to try different ways to analyze this dataset and to find the best way to classify the spam message from the non-spam message. The first methodology is totally invented by me, which is not based on very rigorous reasoning, but I think the word count would have some meanings for us to categorize these different type of messages. In the process, the key point is to assign several integer values to each word of each message. So give that frequency meaning to the message. So As you can see in the code here, especially this part, actually I'm getting the frequency of the specific word in the specific message and also in the specific group. For example, one word is in the ham message group, and what is the frequency of such word in the ham group. In the end, I'm going to have a so-called 3D data. It's like a vector space that I designed for each single word, which will have 3 dimensions. So I call it 3D data. The 3D data, as you can see in the below part, for each word, I know its position in this specific message. I know the frequency of this word in this message, and I know the frequency of this word in its group. For example, if it's in a span group, it means the frequency in the span group. As you can see here, this is a GPT generated summary of this code. If you're interested, you can pause here and check the sequence of this code. So getting to the next stop, we are here to actually further explore the vector space that I created. So basically, the idea here is to standardize, to limit the range, the dispersed range of the vector space so that we can have a more standardized calculation. I used the min-max scalar method to actually contain this vector space. So as you can see, the message 1, the first word go, is in position 0 with a frequency in this message as 1. In total specific group, for example, it's a group as a ham or as spam, the count is 10. So these 3 integers are standardized to these float numbers. As you can see here, there are some descriptions for the code above. If you're interested, you can pause here to check. Then let's go to the next part. So basically, now I'm going to cluster the message with the k-means cluster methodology and to check if I can correctly cluster the different groups of spam and non-spam messages. And here, as you can see, first of all, we vectorize the message using the standard 3D data, which you have already seen. And then we actually utilize the similarity matrix based on the cosine similarity methodology to actually find the similarity between different messages. So the basic idea is to assume that the spam messages will be very similar and the non-spam messages will be also similar. So it will be easy to separate these groups. So as you can see in the k-means cluster methodology, I set them as 2 groups and it will fit into this similarity matrix. Then in the end, I have also created this confusion matrix, which you can see the accuracy value is 87%, as you can see before, because we have a huge percentage of the non-spam group. So basically 87% is more or less, as I assume here, is more or less the general percentage of the non-spam message. Because the confusion matrix already shows some problem, I think until this point, the methodology I am trying to apply to this use case is not suitable. In the confusion matrix, the most important part is about the true positive and the true negative. These 2 parts are very crucial to actually measure if the classification methodology is accurate or not. And of course, we're going to calculate of the recall, precision, and different metrics to compare. In the later models, we're going to see. The same as the previous parts, I show a diagram here about the cosine similarity calculation part and clustering part. And you can also see the print results of some of the vectorized data, and also this is a description of the code I ran before. Then it is also useful to check the distribution of the predicted and also the original label of different data points in a 3D format. Since this methodology already has a very obvious error, I'm not going to go too much detail to it, but just to show you, use Plotly to display in 3D way. In each step, I really suggest you to also check the data frame from time to time to see if the new columns is added correctly and what is the current status of the data frame. So now let's move to the next part. Here I'm trying a logistic regression method to actually redo the classification of the spam and non-spam message using the already vectorized data. And as you can see below, the test precision is 0%, although the train accuracy is 86%, test accuracy is 86%. They are very close. However, you can see that there is no test precision, there is no test recall, and test effort score is 0. So usually these numbers should not be 0. And I also tried to display these prediction results in 3D. As you can see, this predicted a non-spam message and a spam message. So the spam message seems very distinct and very far away from the main group. However, let's see the later part. In here, I tried to actually condense the data into 2 dimensions, which I used the PCA method to make sure that the display of the data will be more easier to be accepted. This general idea is from one of the paper about machine learning in recent days, machine learning and also large language model, and it actually used the PCA to reduce the dimension and to show the data and to see if they are separated. The first graph is about the true spam message group. The second part is about the true non-spam message group. As you can see, if we are in the true spam message group, my intuition is to predict the spam to be a spam. But as you can see here, in this group, most of the messages are identified as non-spam, and only one message is determined as spam. In the later part, of course, I wish all of my prediction will show that the messages are not spam. As you can see here, yes, of course, most of the messages are not spam, but the spam messages, we still have several, which means that these messages are incorrectly identified as spam messages. So let's see, until here, the previous self-made embedding model was not working very well. So now we are going to try 2 more tests. Both tests are going to be based on the embedding model already existed, and we are going to try both the logistic and the neural network to predict the correct label of the messages. So basically, first of all, we need to install the dependencies and check the data frame and so on. And then we are going to introduce the sentence transformer as embedding model. I use this paraphrase mini LLM L6 V2. This is one of the free sentence transformer that I find via ChatGPT. I think it is much sufficient enough for us to explore the current topic. Of course, you can change to a different transformer or embedding model in the future. And basically now we're going to transfer the whole message body to this vector space, which is determined by the embedding model, and we're going to implement a different algorithm. Like this one here is a logistical regression, and the later one is neural network to predict the correct label. So I'm going to skip to the result parts. As you can see now, all the metrics are non-zero value, which makes much more sense. And let's go through the graphic way to see if the labels are assigned correctly. For example, now if we are going to check the true spam message, we have all these data points in 2 PCA dimension, and you can see the spam message are these blue dots, and the non-spam message are these red dots. So basically the precision is quite well. As you can see here, the training accuracy and also test accuracy are both 98%, which means that the red dot is only around 2% or 1.6, 1.1% of the spam group. Now let's look at the ham group. So basically the non-spam group, we would expect that most of them are identified as non-spam. And as you can see here, there are only, I think, around 10 different data points are not correctly labeled as non-spam, but they are labeled as spam. So basically the precision of this model is very obvious, it's much better. And as you can see here, when we compare these 2 models, first of all, I call it a naive model, which the model I just invented or tried, and the improved model is more robust. As you can see here, first of all the metrics are not 0. And the train accuracy, test accuracy are both at a very high level. And for other metrics, I think they're acceptable. Now, I do not further dig into the overfitting or underfitting problem. But at this moment, train and test accuracy are quite close. Okay, it might have some overfitting problem because the train accuracy is higher than test accuracy. But it's not our point today. I'm not going to go deeper in it. So below the code description, if you want to check the different step, just pause here and check. So in the next part, I'm going to use the embedding model plus neural network model to predict the correct label. And here I'm using the PyTorch library. The reason I'm using it because our TensorFlow sometimes has different problems. So just to avoid repeating the problem, I choose PyTorch. As you can see, the basic idea are almost the same. We actually separate the train and test data and then implement the different algorithm. And all these parameters are quite standard, so we configure just a very basic neural network and to try it and train it to see if it can get better prediction capability. So as you can see in the later part, I'm going to use also the PCA, two PCA dimensions to plot the data points for us to see the result. As you can see during the training, in each epoch, actually the loss value actually change every now and then, and sometimes it can be quite large, but in the end, it's always around zero value. As you can see here, most of the values are close to 0. Then let's take a look at the graphical information. So it's quite obvious that in a spam message group, we have these messages not correctly assigned as a spam, and in the non-spam group, we have only these, I think, 6 messages not correctly assigned as non-spam. And if we check back to the training metrics of the model, the train accuracy of this model is 100%. Test accuracy is around 98.74%. I think it's already showing an improvement from the previous model. As you can see here, the model performance comparison, I put them all in the same graph, and you can see the later two models both have much improvements related to the naive vector clustering. So basically, the different embedding models, if you try them, I think you are going to see a different result. From a different point of view, now you can see that embedding models is quite convenient and important to analyze the text information because it gives you more robust or more accurate information about the different text message in our case. And the numerical representation has more statistical meaning than the manually or DIY design embedding models. I really wish you enjoyed the video today. I wish I have made myself and also made the project very clear so you do not feel confused. If you have any question, feel free to leave a comment. The video, please do share or like. If you really like the content I create, please subscribe to the channel. So until next time, have a nice day or nice evening, and see you again. Bye bye. Hello everyone, welcome back to my channel again. Today I'm going to share with you one of the test projects I've done recently, which is designed to prompt a large language model with the same question several times and to see how the questions disperse in the space. So basically this idea came to me when, like months ago, in different social media platform, people are discussing about the accuracy of the large language model and about if the RAG flow or some additional design would actually make the large language model more reliable. So I guess this will be a start point to test the large language model. Of course, this is a very basic format, so it cannot match to a very specific use case. But I just wish that this kind of test would give you some idea or inspiration to do further tests on large language model. Basically, the first thing is to install the different packages needed for this test. So I'm not going to go over everything. You can just check by yourself. And the most important thing is that I use Grok because it has very fast inference inference efficiency, and it can save a lot of time. And I also leverage the Google Cloud, the Colab environment to implement this test. Okay, so basically installing all the dependencies using Colab. I also saved my Grok API key here. The Grok API key actually you can get from the Cloud Grok platform. It's very intuitive. You can get it and use it. Uh, then I start by defining, first of all, is calling the Grok model. This is a function. Then there's get embedding. So it's not very complicated, right? We just prompt the same thing to the model for several times and to see how the response is getting feedback. But you already noticed that here, I did not specify the temperature. I do not have a rag flow to actually do a test to compare two groups of the different model design and the different answers. So this is a basic model, like I said. I just want to fast test and see if some of the visuals and the general design works. So we also come down here, you see, to initialize the tokenizer and the model for embeddings. So basically, these models are useful for me to transfer the text information to vectors. Okay, just simply put like this. Then about the main part of the code, first of all, I have the different prompts ready. Okay, these prompts are not designed by me. Okay, so basically, for my personal use case, I never would like to write a short story, like some sci-fi story using LLM. I would like to read somebody's book or check or watch a movie or watch a TV series, but not to talk with a large language model. But I let ChatGPT to design these questions, just to see how it goes. And the number of repetitions, I want to see 10 times of the different responses. So 10 will be the threshold of the for loop. And then you can see we're going to save our embeddings and also the responses, because I also want to see the embeddings. These like the vectorized information for each response, of course we can do further work on it. But to be honest, if the dimension is very high, to actually capture the essence of this information, the best way is to do the dimension reduction, like use principal component analysis, PCA. So when I use PCA as 2, it crushed the vector space to get 2 dimensions. When I crush it with PCA 3, actually all the information is condensed to a 3D space. So in both way, I'm going to see how they are dispersed. But now I only get a graphic idea. I do not have a measurement of the different distance between these dots. So to actually see a more complex result, more numerical and more robust result analysis, this test is not enough. Okay, we can do many more things. But here, I just prompt, get responses, transfer responses to vector space, show it in 2D space, 3D space. That's it. Okay, so basically in here, the inside the for loop is actually to call the model and get a response. Okay, and also append the embeddings, those responses. And eventually, I also print some of the information for me to check. But to be honest, if the response is very long and not, let's say, it's not well designed or contained, for example, you want every response to be limited to 500 words, something like this, it's very hard to see the difference. Because it takes, if you use your human judgment to evaluate a 500 words long paragraph or a story, one from another, it's really hard. So in that case, I think the embedding results, the vector value results, could be a way for me to understand the distance between the two results. But let's see, it only gives you a general idea and nothing more. But I think this could be a good start. So in the later part, you can see there are 2D data and 3D data to actually print them in 2D and 3D space. For me, really, generally speaking, I think because our limitation of understanding the graphical information, 2D and 3D space are the maximum because visually we cannot. For me at least, I do not understand how to represent this 4D space. Maybe from a sequential 3D space, or from some other representations that requires more profound understanding of data and machine learning and so on. So let's see. So basically, the first question is to ask the large language model to write a short story about time-traveling cat who visits ancient Egypt and befriends a pharaoh. It's very nice prompt, I see. And you can see the large language model without setting any parameters. It's very creative, and it actually created a short story. So I'm not going to go to the detail. If you want, you can check and get a sense of it. But to really understand and interpret it by human for several chunks, documents with very long length, it's really time consuming. So I'm going to jump to the second part of the embedding, and you see to transfer this whole passage to embedding to the vector space. It's very complicated. See, it's very long, a long list of numbers, and for a response, so I print only 5. So let's see. For the first question, we get all this response. We can see that some of the responses are very close to each other. So, which means that let's see, the general pattern large language model we can actually summarize to different categories. It's like this one is the main part in the middle, and the others are outliers. But you see, if you do not contain the large language model, either using RAG, either using chain of thoughts, there are many different tools to implement the tool calling and different methods to make sure large language model is more reliable. Without those tools, the results you see from a large language model are very dispersed in the vector representation, or in the 2D space, in the 3D space. So as you can see, just intuitively we'll understand that there are some outliers and some of the responses are very concentrated, right? So if you change the temperature, if you change how the large language model is getting the response, results are going to change. So based on my understanding now, in the market, there are some people who like to use large language model for enterprise use case. So even for query, like a large language model to query language like a SQL, its reliability is key. So in a very specific use case, the accuracy should be 100% because you don't want a large language model to go play with the whole workflow and generate a very simple query, with error. Like I want to query company A 2022 net profit. It should be a fixed number because that's it. It should not be ambiguous. So in this case, after seeing these results, I think with or without a very robust RAG flow, I think no matter what is your use case, first of all, you need to identify the accuracy requirements. For example, if you just want to get inspired, of course, you can let the answers fly. But if you want a specific query, like a SQL query, the results should be very accurate. So this kind of test, I think, could give us some idea. So basically, based on this 2D representation, you can do clustering, you can analyze dispersion, and if you really have large computer resources, you can actually test many times to see the dispersion. So this idea is actually partially inspired by one of the paper to discuss the different response. I think malicious response from large language model and their dispersion. So basically in that paper, eventually it has to crush this huge list of number to 2 dimensions, 3 dimension, to let us understand, to better get a sense of how the responses are dispersed in the space. And following the PCA two-dimensional graph, I also simulated randomly some of the number to give you a sense that if the results are really random, actually the dispersion in the two-dimensional space is more dispersed through the space. Okay, this is only for showing the idea, but it's not related to the test data. Then here, this is a 3D vector graph that is simulated by the random number. So as we can see, if we are seeing a really random result distribution, the points are very different and dispersed in the 3D space. So based on this, we have an expectation that the large language model should have a not so well clustered results. Okay, so let's see the next part. For the other question and response, of course, you can check. But the general idea is that we get a response to the vector, map it to the space, and to get two random vector sets to let you get the idea how the really random numbers could be. So now we go to the dynamic 3D display part. Of course, we use Plotly package, and we now crush our data to a 3D space. Okay, so in this part, I do not show the textual results because I think the 3D graph should give us the idea. So basically, each question has got 10 responses from large language model. This is the first one, and this is the second prompt, and this is the third prompt. As we can see, if we actually make our space into another dimension, the distribution is how can I say is more dispersed through the space. You see, there are not. Yeah, you see in the middle, maybe there are some points that's very close for specific prompts, but in general, it is more dispersed in the 3D space. And we can see that for a different prompt, which got generated different responses, they could potentially get very close. So this is very interesting. It really encourages me to do more tests about a specific use case to actually understand how these responses are dispersed. So basically, without dig deeper to the training, to the building of large language model, or fine-tuning to make it more accurate, or to add additional workflow to it, after this test, one thing is for sure. I think to understand the large language model's answer distribution, the best way is to test with a very specific question and see how they dispersed. But I think only relying on the embeddings, there are maybe some of the semantic information or meanings, different textual information you cannot capture. So I also doubt that if the distance is this far away, does it really mean these two answers are really different? So we need to find more ways to actually get the insight of the differences of the different data points. Okay, that's all for today. So today I have showed you tests I have done is to actually prompt large language model to get a series of responses and use the embedding model to transfer them to high dimension vector space vector and to crush it to 2-dimension or 3-dimension. Okay, so you can see the difference of different response. So based on this, it will give you a good start to get deeper understanding of large language model, especially if you are like me, who is very interested to understand how the large language model perform. I think this is most intuitive way. When you actually go deeper to go to like the fine-tuning and different workflow design, it will create more, the more chance for you to better utilize large language model, but you need to test it. Even with RAG, like one of the products called Perplexity, I remember. It is actually very famous for its RAG flow. I think it actually forcefully puts all the citations to each answer generated by the platform. But even that kind of software can hallucinate one day I just asked a very simple coding question. It actually gets to a very simple loop. So this really makes me think. If a large language model cannot be always 100%, using different combination of tools, we always need to understand, to test, and also to, if you are using it in your production case, always make a good ledger of all the results generated. That's very important for you to keep track of the performance, how you choose the model, how you fine-tune the model, how you build a rag flow, and so recommendation to all the audience. Do some tests and see how the large language model works. See you next time. Bye bye. Hello everyone, welcome back to my channel again. Today I'm going to share with you four very frequent or very popular cases for the machine learning. And these four cases can be easily linked to the scale-up case, which means if you successfully handles a small portion of the data set, it is optional, and it is also encouraged that you utilize a more advanced algorithm, like with the Spark handling of the data set, to actually calculate a larger portion of the data set. So basically today I'm going to show you some basic steps to analyze these documents and the possible solutions for the next step. Okay, so today is a quick overview over the four cases that you might meet in the machine learning study process. So the first one is finding similar item. The setup of the Kaggle API and also the secret in the Colab, you can check a relevant instructions. I think in Colab web page, it is also clear that you can set up the different parameter to facilitate your quoting of such a resource, so you don't need to type into the information every time you utilize this functionality of Kaggle API. And the dataset we're going to use is this one, LinkedIn jobs and skills. So basically we're going to use two parts. One file is called LinkedIn job, and let's go to see it. This first one is called job summary. So basically this one is about a job link and a job summary. I do not print the data frame details or statistical information here. If you are interested, you can do so. So I'm going to focus on the very shortened process. So basically, since this data set is very large, I sample 1,000 data points from this data set. So basically, they have two columns. The first column is links, the second column is job summary. And then we may utilize the vectorization method of the summaries. Basically, it just transfer these textual information into the vector space, the vector values for your further processing. If you want to go to more details, make a comment, let me know. I can go to details to explain to you. And then we can calculate the cosine similarity. So basically, this is one of the way to calculate the similarity of the different text information after they are vectorized. Okay, so you can also find the different ways, like Euclidean distance. So like Euclidean distance, you can somewhat transfer it to a similarity case, because the longer the distance, you are going to say these values are largely different. The closer they are, the less the value of the distance. You can see they are more similar. And of course, you can also use some of the other algorithm to see the overlapping of the shingles or the tokens that you set for the textual information. You can use that also to compare. Of course, that one is called Jacquard similarity. So you have so many options here. So if you want to expand this part, you can use different algorithm and compare their difference. But to be honest, at this moment, a pure numerical comparison sometimes cannot catch up the semantic information contained inside. So later, I'll show you some of the print results to explain you what I mean. Then about finding the similar job summaries. Usually you can set a threshold, right? A threshold like 0.8 is what I think is a threshold to say they are similar pairs. Okay, this is to find the similar pairs of jobs and save the similar pairs information. And eventually the print of the similar pairs is just to print the similar jobs. So I'm going to show you several. Show you just one. Okay, so to save the time, the first one is job 4 and job 48 are similar with score 1.0. So basically it says that these two jobs are largely similar or a potential duplication. Let's just see. This says love your job at Texas Roadhouse. Okay, and to be a grill master. Okay, I guess these are the two most important information for me to read this text at this point. Then let's see what it says. Job 84. Let's see. Yeah, it's job 84. Job Texas Roadhouse, right? Grill master. Okay. So after this quick check, I get an idea. This is potentially a correct answer. It has found some duplication. And of course, you can go on and on to check the others. So basically, the similar job search, you can use it in many ways. For example, if you want to detect the duplication or similarity pairs of the dataset, or whenever a user of the LinkedIn, the user uses this platform to search for a job. On the other side of the page, it can show a similar job. So just to guide this user to another potential candidacy possibility. So these are the ways that they can be used. Of course, you can also implement and improvise many other use to use these pairs of jobs that you found. So there are also other examples. If you're interested, you can check. And then let's check about the cosine similarity distribution. I think the pairwise similarity, the best way to visualize is by the heat map. Okay, so you just use a heat map to see which pairs are less similar and which pairs are highly similar or even duplication. As you can see, we see very few red dots, so which means that red dot or orange dots, so which means that the duplication or the largely similar pairs are less than the blue ones, the less similar ones. The other way to go into this visualization is to partition or set a section-wise partition to investigate in more details. So here we just see a very macro level summary, and if like here, I actually separate them to different ranges. You can see this is from 0 to 0.25. So you can see this is one part of the similarity information, and then we go to 0.25 to 0.5 and so on. So by separating them to different range, you can see basically if you are going to find a high similarity pairs, actually the data frame, the data set has been shrinked to a much smaller subset, so you can work on. By these visuals, it can give you some idea how you can move to the next step. Then let's check the second project. It's called market basket analysis. So basically, the project is to find, let me show the result first, to find the specific rules to interpret the different keywords, let's say. For example, like this rule number 1 is saying that if a job requires leadership, there is a 62% chance it also requires communication. Okay, so this is a way to find the possible information connections between the different data points and give you a sense, like in this case, where some of the keywords are highly relevant to each other. And you can also see here communication is 2.13 times more likely to occur with leadership. Okay, so these are kind of information that you need to use to analyze the data set. So here, as I said, this data frame could be potentially very large. The best way for you to start with a Panda data frame, Panda package to analyze the data. It can offer you many versatile tools to calculate, to visualize. But the most important thing is that to remember, you don't want it to explode your memory budget. Like in Colab, your memory is fixed. Your local machine can handle a fixed size of the data simultaneously. So without using additional large scale calculation package or methods or database methodologies, the best way now is to sample. Okay, always recommend this. So you can also do some data clean that is optional. But if you want to do more, you can clean also the special character and so on, right? And here is to convert job skills column to a list of unique values. Then we use one-hot encoding method to create the data frame. And there is also a step to apply a priori algorithm. So basically, after implementing this algorithm, you can print out the association rules. Okay, and of course, if you want to go more detail, you can adjust the parameter, check the documentation, check the methodology description to understand it better. Okay, and eventually we see here are the rules, right? The rules are printed with numerical values. This is one thing that I like about most of the outputs of any algorithm, because you can interpret the numbers in a more direct way. So let's see some of the explanation here. It actually explains each column like if, okay, the first column says if, like this one, if leadership, then communication, okay, and then the proportion of transactions that contain the if part, okay, antecedent supports and also consequent supports. Okay, you can check the details here. But eventually, if you map it to each detailed case, it actually means that if a piece of information requires a keyword, there is how much chance that it would also require, okay, another keyword, okay, about the coincidence. And about the lift is like odd ratio, I guess, about how many times more likely. Okay, so this is a second project. The third one is about link analysis. Actually, I wanted to utilize a data frame where we can have the different links of a art piece and to analyze the link relationship there. However, that data set in Kaggle is not working very well, and I have not been successfully downloading that data. So now I choose another data. So this one is called Karate Club graph. Okay, so just worth mentioning, for either you want to analyze a bunch of URL link and their relationship, or this one, the basic thing is that you need to understand the data frame should have nodes and edges. Okay, these are two most basic ones. Basically, each node has some representation. Like this one is representing a member of the karate club, and the edge representing a friendship between the club members or relationships, right? An edge between two nodes indicate that the two members are friends, or even you can define a different type of edges. Okay. And there is also a split. I think it's in default for this specific data set because it's for test purpose. Yeah, they are actually split to factions, right? So you can check the different rules of different data sets. Then let's go to the analysis of the different methodologies. First one is the function to implement page rank. Okay, so the page rank is actually utilizing this algorithm, calculate, and eventually return this nodes and page rank information. Okay, back to the function. So basically, we actually use PageRank, this function, directly on this dataset. Okay, and we need to convert these data frame. The original data frame that is not like a table, to put it simple. And here we actually transfer it to data frame. It's like a table, so we can better analyze it. If we display the first 10 nodes, we can see here. Okay, so one node with one node is PageRank as how much value, right? So basically, you can view it as kind of importance of this page. Then visualize the PageRank as node size. Okay, so just to show its importance, and here we have the graph. So basically, we can see 0, 33, 32 are the biggest nodes, and it actually connected to all the other nodes in different ways. And all the edges, all the lines are showing a relationship. Okay, so how can we interpret this? So PageRank values output. PageRank values in the output represent the importance of influence of each node in the network. Higher PageRank values indicate more influential nodes. Okay, so basically, node 33 has the highest influence with the PageRank over this value, and so on. So in summary, node 33 is the most central and influential node in the node in the club. So we can interpret it in different ways. For example, like in the social network, okay, in a social network platform. If they find, using this type of way to find several people in a hypothetical group of people, users, and this center person is very important, we can actually implement some algorithm. For example, your strategy of of the advertisements, your strategy of marketing could potentially change, because once you get the attention of the central person, this central person can share or can spread this information in a faster way than the other persons. So they are kind of identify the key personnel in your user base. Okay, this is one type of the interpretation. It may not be very robust, but it can give you some initial idea. And we can also see here, okay, node influence, node with higher rank page scores are considered more influential, more important in the network. Okay, and also we can see the network centrality. So to find the most important node, you can have different ways to handle such information. The last one is about the plant leaf recognizer. To put it simply, it is an image recognizer problem. So for image recognition, I think we have so many existing tools in TensorFlow. And also to classify these photos, I think is always a very interesting task, because classifying the photo, I believe it can also extend to other calculation or algorithm about images. Okay, it's like object detection, different ways in machine learning, automatic driving, and so on. I suppose I have not yet touched the automatic driving part, but yeah, here we are. Let's see how it goes. So basically, this is the data frame I found. It's like the flower photos. Okay, so basically, the first thing you need to do is to extract this data, right? So basically, it extract this data and create a generator. Okay, this image data generator is actually directly using the TensorFlow package. Okay, so if you want to go to more details, I can also do another video to explain you how this in detail works. So basically, it actually needs you to set up different parameters, okay, according to your needs. Then you can set up the train data generator, okay, and also the validation data generator. So basically, it's like any machine learning model. You can set training set, validation set, test set, and so on. So here I do not set the test set, but I have the training and the validation, okay, to do the basic calculation and to see how the loss and also the accuracy evolves. Then I build the model with the MobileNet V2. This is a specific model for image classification. And the model use here the base model, then like the global average pooling 2D. Okay, these are different parameters set to the model. Okay, so basically, if you are using a neural net, is a different story. You need to set different types of parameters, function names inside. Okay, so here is also the layer. Okay, and the activation function is value, and also there is also a dense layer about generating the number of classes, and the activation function is softmax. Because in general, the eventual target is to classify, to tell you if this flower is this flower or another type of flower. And when we come to the compilation of this model, like the optimizer, loss function, matrix, these are all parameters we need to set here to determine how you run this model and get the result you want. And I also add some optional steps here it is a iterative process when I use them to facilitate my debugging or stop some of the unexpected problem of the training. Then about 1 hour, I'm using Colab free version about 1 hour to actually run this code. So if you are running the previous 3 projects, I think the first project took about 20 to 30 minutes. It depends. But this one is about image. It takes the longest. It's almost 1 hour. And here we can plot, right? Plot the process of the whole training process. We can see that the model accuracy, about the training part, it goes higher and higher. But the validation part is going down and rebounds a little bit, but still not as we expected, right? So the model loss actually in the validation datasets, the validation partition, it actually goes very high, okay, higher and higher. So we understand this, and let's try to use this model, okay, to test, to generate the classification results, and we can see how it goes. Okay, I'm not going to go to the details here. If you have any question, you want to go more detail with them, you can do it in future videos. So here, after the training, we get these results, right? We test for, like here we show 9 images. We see the first one is wrong, right, wrong. So basically we have 2 images classified as wrong category, the others are correct. Okay, not so bad, but always be cautious. If we have such problem in the machine learning area, always try to regularize the model, okay, to add a penalty term to actually at least make sure that the validation set or the test set, that the loss will not explode, okay, higher and higher, and accuracy could be guaranteed. Okay, so later I'm going to show you additional ways to make this work. Basically, it's just one single regularization method. So here we can see we have different steps summary here. This one just stops here. I'm going to show you some further improvement. So here, let's see how we can improve this model. So the first part is still the normal training, and we got the mapping or the graphical information of the model accuracy and the model loss. right? So accuracy during training is very high, and the validation part is very low, relatively low. And the model loss about the validation part actually explode somewhat. And let's see. So using this initial model, let's see the first two, the first 3, 4, 5, 6 images out of 9 are only classified. But remember, this does not represent the whole dataset or the dataset that you sampled. Okay, this is just some quick example. So after checking the original train and validation results, let's see here, we're actually doing some tests to see the prediction, if the prediction is correct or not. As you see here, we have many images wrongly classified. Okay, again, if you want to investigate the statistical property and go deeper, always stop and go deeper of the algorithm, calculation method, and the theory behind. And here we come to the final part. In the final part, we actually add the regularization term in here in the model part, and for the first dense layer setting we get the L2, okay, regularization. So in my other projects, like when I did the neural network project, I did some tests about L1 and L2 and the mix of them, different regularization methodology. Basically, you can see different results. Here, it started with 0.01, the regularization value. It actually already improved the model. And if you want to try the other parameter, please use a for loop or other methodology to test it. Okay, so the other part does not change. Let's see how the graph change. So as you can see now, the train and the validation accuracy, it actually improve, and they have some synchronization here. They don't diverge from each other very much. Then we can see the model loss, both the train and the validation drops, okay, after the epoch. So this is a improvement for my project. Of course, if you are not satisfied with this one, try different regularization or even change the overall prediction model structure. Okay, so let's see here. Okay, luckily the some of the predictions see here are all correct, but we cannot say this model is 100% correct, because as you can see, the train and the validation accuracy is around 85% to 87.5%. Okay, although the training accuracy could even go higher, but it does not actually have a real impact like on the validation set, or even if you set another test set, either with new images or the existing image, but you partition them, you're going to see some variation from the current version that you see. Okay, but the general principle is that we need some convergence. We need the improvement of accuracy and also the dropping of the loss. Okay, so here we finished the final one. And remember about the regularization, it is very important. You use L1, L2, or combination of them. Do some tests to get some visual understanding of them, and then you can better implement in the future projects. Okay, so today I have finished all the project introduction. So basically, these are very fast without going to every detail introduction. I wish you enjoy it. If you have any question, feel free to let me know and we can discuss. If you want to go deeper to some concepts, we can also do that. There is no problem, but really, I need your feedback. So basically today, all the projects, I think on the small data set range, we sampled 1,000 data and so on for different occasions. And if in the future you want to do these analysis on a huge data set, it will require like the Spark and the different ways to handle them. In the future, if we got a chance, we can share, we can also discuss some of the parts. But at this moment, for a small, limited data frame, try different algorithm, try different models, visualize them, and then get more insight. So you can move to the next part. Machine learning at this moment, for all the courses I learned, I checked about generative AI, AI agents, about machine learning. I think one thing are in common is that no matter how you change different machine learning algorithm and so on, always you need to focus on the accuracy and loss. You need to check if the different parameters are set well. You also need to make sure that you could better understand a problem and its solution. For example, like years ago, CNN was used for image classification, but maybe now it is too antique. But if you are going to adopt a new algorithm, it's better that you see the difference between the different types of algorithm. So when you implement them, you can see sometimes the different results. Why? Okay, these are just my quick suggestions. So wish you enjoy this video. If you like my video, give it a like, leave a comment, we can discuss. And if you like more updates like this, feel free to subscribe. So see you next time. Bye bye. Hello everyone, welcome back to my channel again. This time I'm going to share with you this tool. It's called AI on device. You can check it on iOS App Store. This is the screen on my iPhone. I'm going to show you. This is iPhone 11. So basically when you open this app, it will load the default model. And it offers different model choices. I'm going to show you later. Okay, so basically I think this is a very great tool to bring with you to anywhere. So if you want to ask a quick question or ask a quick assistance, it could be very handy. So let's see. So first question I'm asking, what is LLM? So you can see there is AI is thinking, then changes to AI is typing. So it will go on to the streaming mode and then show you the results, right? Whenever you want to stop, you can stop. I just stop because LLM is not what I expected. So I ask another question, what is large language model? So it actually provide me with the answer I want. Okay, so it is a streaming mode and give you all the answers word by word. Yeah. Then you can see there are some buttons, for example, like the microphone. So basically you can input with voice, but sometimes it's not very handy, so I always prefer to type. And the next question is to ask for the code to get NVIDIA stock price at the last 3 months and the latest financial information, and show the graphs and results. So it will give me some of the code in Python. So basically, if you do not specify your language with the default model, it will provide you with Python code. As you can see here, it actually is okay to import different packages and start setting the different variables for further analysis and display. It's not very comprehensive, so you do not see very sophisticated code structure. But at this step, I think is okay because it shows something. So if you want to improve, you can keep asking questions, like you talk with other language models. But again, for any on-device models, the usage is quite limited because its capability is limited. As you can see, this advanced setting page, you can download the model and then load it, or you can set different variables, parameters to use the model. Okay. For the chat history, you can scroll up to check and to copy or to change the previous question. That's about it. Wish you like this tool. Thank you. Bye bye. Hello everyone, welcome back to my channel. This time I'm going to show you the use case of Gladio, where I use Gladio as a user interface to link with the large language model, especially the local model. And the main purpose is to have the user interface, which I can manipulate in local environment. I can modify, I can use it, I can even in the future to upgrade it. I have already tried like Streamlit, but Streamlit it is a very highly configurable. You can change a lot of parameters, and of course, with the help of large language model, you can quickly create the code and run it. Okay, it's an app, and you can see multiple examples in the Streamlit website. It's very useful. You can also try that. But today I'm going to show you another one. It's called Gladio. The reason I'm coming to Gladio is because I see some examples that some of the developers are using Gladio to create their app, either to interact with a model where you can chat with the image, chat with video, and also the language model. Okay, so it actually shows very good appearance. I find it very interesting, so I'm now exploring it. So basically, in my use case, I do not use the Llama interface to link with a large language model. I use the LLM Studio because LLM Studio sometimes I can check the log. Like on the left-hand side, I can check the log, see if there is some problem, I can debug quickly. But it's optional, right? You can change to link with your language model API, okay, with Llama, with LLM Studio, is optional. Okay, you can choose based on your use case and your preference. So here I use LLM Studio to load the model and be ready. And after the assistance of large language model, I created two applications based on Gladio framework. You can see here is the chatbot and the chatbot 1. The difference is that the chatbot version is totally based on the creation of ChatGPT and some manual modification to improve the code and to debug it. The second one is based on the creation of Claude. Okay, Claude. This is also a very popular platform now. But later you are going to see there are some difference. And without going to the detail of the code, first of all, let me tell you how they look like. On the right-hand side, the first page is the LLM Studio chatbot. The name, of course, is you can name it whatever you want. This one is created by ChatGPT. Okay, so my first prompt is to code to show chosen SP500 stock price trend with chosen time horizon. It actually produced the code, okay, and the answer seems right. You can try the code. If the code is not working, of course, you can iterate the discussion with the model. And on the right-hand side, you can see this is a different kind of design, okay? So the prompts I used to ask the language model are basically very close, except that in cloud environment, I ask it to add some features. First of all, I want to improvement of the UI, user interface, to look better. Second, I want to see the code output. Of course, this is just a test. I know that in order to run the code, you need an environment, you need a lot of things to be set up. Simply on the browser, it just does not work. But eventually, I just want to see how it designs the interface. So let's come back to the left-hand side. So basically, their proposal of the code, okay, the structure, are similar, okay, from the GPT model, from the Claude model. Let's see the GPT-1 first. Okay, so the basic setting follows the design of LLM Studio. Okay, how to call the client, how to set the system message, and there is also the function to actually chat with the LLM Studio. Okay, as simple as that. So a good thing with LLM Studio locally is that you do not need to mandatorily fix your model. Okay, you change the model you load in the LLM Studio app, you don't need to change the code. It is adaptable. You just call it whenever you want with the model you already loaded in LLM Studio. Okay, and then like the Gladio chat interface part is very simple, just several lines of code. Okay, so I think after you learn more about Gladio, you can of course change it, like the UI, like the functionality, and so on. Okay. Pay attention to the right hand side because at this moment I only tried to submit the prompt and get a result. Okay. Like undo, retry, clear, retry already tested, it is okay, but like undo and clear. For example, if you already prompt the large language model, I think it's quite impossible to undo the prompt. So basically, I think the undo and clear are very similar. Okay, it's just to clear your user interface because once you prompt a large language model, the record is there. If you see the verbose log, you are going to see everything. Okay, let's see the Claude version. It actually incorporated more modules. Okay, and of course in the first part it actually preferred to do the configuration. Okay, which is quite different from the GPT version. It actually set up all these system variables. Okay, either you are using Colab or in local environments. Okay, in some cases it's quite convenient to set the system variable in the beginning. And the format of the history, like the functions are more. Right, it's not just the chat with Studio. The chat part, the function are almost always similar. However, you ask the large language model to produce, and it has more functions, right? Like handle the history, execute the code, and to process the message. And this is the interface. You can see now the interface has more details, which make it look better. Yeah, I think to work on the interface, you can work on this part of code and to improve it. And now I really have a problem about the execution of the code. Okay, it actually gave me this part to execute the code. Okay, but it is not successful. So I guess in the future projects, this should be what I work on. Okay, I either to bridge the code generated with some environments and let it produce results. So this is the code and this is the result. Okay, so basically you see I think from my point of view, I think the right hand side UI is more organized than the left hand side. Of course, if you break down to different windows and you need to check the different elements if their layout is meeting your demands. Okay. However, I still think the right hand side seems the fonts are bigger and you see there's highlights of the window title, right? And of course, there's option that you can actually change the window size to display. Okay. And on the left hand side, it's kind of rigid, the design. Yeah, but for the prompt box, of course, you can change. Okay, these are just some details you can explore later. So basically today, I just want to show you that if you want to build a local user environment, user interface to interact with your local models, Gladio is a very good choice. You can try it out. If you have any problem, if you want to discuss anything, feel free to leave a comment. And see you next time. Bye bye. Hello everyone, welcome back to my channel. Today I'm going to share with you one of the projects I have done from the beginning of July. Now I have some intermediary results, so I want to share with you. So basically this project is based on the framework of nested chat published by AutoGen. So basically if you go to AutoGen documentation and you check this nested chat page, it will describe to you how the different scenario works with the orchestration of the nested chat. So if you are interested, you can go over the whole document, see how it performs. One thing I would like to mention is that because most of the AutoGen example and the results are run based on the backend of GPT-4 model. So its results may be quite different from the open source models. I'm not arbitrarily define the open source model as inferior because there are many benchmarks, as you can see in different social media channel, and also the HuggingFace, for example. You can see there are a lot of analysis saying that the open source model is approaching to the level of answer precision and different benchmark. They are going to approach the closed source model. However, in my use case, I still find that there are some gaps. So now let's read the summarization from ChatGPT. Actually, this framework nested chat refers to the process where a receiver agent, after receiving a message from sender agent, may initiate multiple internal chats with other agents. Okay, I'm just going to stop here because in my understanding, it is actually, for example, if we have several agents talking in a round table, it's like several people have a meeting. Okay, you have different ways to organize, like a sequence to ask who to speak first, who to answer first, and how to go back and forth, and how many rounds of chat you want. In this case, nested chat is like you have a smaller subgroup. Okay, it's a subgroup structure where you can refine the answer before present to the user proxy or to the for us to see. Okay, so there are some examples. I prefer to read the official documentation, but from here you can see a very shortened, okay, very summarized information. You see, you need to define the task. Of course, you need to define the agents, right? And the most important part is the user proxy register nested chat. This is the key part of the chat orchestration. Okay, so it's not like in the other example that you initiate a chat. This one is actually to register nested chat. So the package or the program will understand how to orchestrate this nested chat. So like you ask the agent to write a story for you, it will have a critic in the nested chat. So critic will critique it and also improve the writing with the writer and then present you the final result. Yeah. But of course, as you can see here, if you want to expand, want to have more complicated, complex, nested chat structure, you can do that. But I would suggest that when you handle the package like AutoGen, just do gradual improvements or gradual modification. Later, I'm going to show you some of the journeys, some of the experience I had during this period of developing. Now we are back to the VS Code interface. You can see some similarity with my previous projects. Basically, we have the app Python file as a main program file to actually execute the very important execution sentences and to organize the workflow. And we also have the agents file. We have also the configuration file. The API key, I just use a random number to hide the actual API key I use. I'm using Grok as backend because such a program, when you test it, the speed of the backend is quite essential. Okay, you cannot just, for example, my local machine is very slow. I cannot wait 2 or 3 hours just to see a group chat results. Okay, I mean, if it becomes very complicated, it could take several minutes, even 10 minutes. Okay, and the most complicated case where I let a local large language model to run continuously, and it is a relatively big model. It can take 2 or 3 hours. So the suggestion is that if you want to experiment some of the projects, Grok is a good option because it's really fast. But pay attention, most of the models are quantized model. It is for me, I understand it as a shrinked model. So of course it has limited capability than the complete model. Okay. Then I also have the workflow Python file to actually define some of the workflow. Okay. In here, There, of course, if you want to separate it, put it here is okay, or you can just put it in the app.py file. Okay, so let's go back to C. So I'm going to explain mainly on this part. So basically, first part is importing the different packages. Then we define the task. The reason I'm writing some of the predefined task is sometimes I want a quick test without manually input a lot of information. Okay, you can input your prompt however you want. Okay, that is also an option. And then I show this markdown in the page. Of course, now because I add some of the explanation sentences here, you're going to see in the app page, but when you delete, it will be fine. So we also have some sidebar functions to let's choose a model and do a lot of things. So basically, you can also choose the temperature if you set it correctly. Okay, as I said, if you want to interact with the large language model to improve your code writing, it's better to gradually increase the complexity of your program. So, like now, I have not done all the tests necessary to make sure that my application is robust, which means are all the functions called, are all the variables called, are all the lists correctly set up. So eventually, if you want to have a very robust program, you need to check a lot of things, test a lot of things. Okay, so that's what I suggest you to do. For example, now I might have some error. Okay, most of the contents are generated by large language model. Of course, I get it step by step. I change some variable, change some sentence. But in general, if you want to publish it, if you want to present this project, please do more checking and test. And of course, there are some additional steps, but here I'm going to say the first important part is to create the agent. So agent has different definitions, have different functions. You always need to define it. Okay, so one way to do this, I can put the documentation description into large language model, say what I want, ask the model to give me feedback of the code. But this code may have some problem. For example, some of the functions are not called. We have some idle sentences. Okay, these such kind of thing are not good for your program. Okay. Then we have the button like the how we initialize this nested chat. Okay. And here for the graphical chats is the chat I really want that the program can do for me. So to provide me with additional graph, financial analysis, and peer review. So far, this part does not work as what I want. So basically, there are some issues here. So if the agent get the code correctly, it can run. Okay, can run the code. But to display the graph in the Streamlit interface, I cannot resolve this problem. I cannot display it. Okay, this is a problem I left for the future projects. The other thing is that if you want, like I said, the complexity in the example, official example, is to draft some of the reports and to iterate, use large language model as a critique. So as a critique, I mean it could be like if I'm a person, it's very subjective, right? I can talk, even without some of the fundamental base to back my opinion. So in the official example, you cannot see a lot of variations of the execution of the program. But when you, like my example, I go to production, I will see a lot of issues. For example, I would like to say, okay, nested chat has the main purpose actually to get the stock information, analyze, write report. Okay, then I wanted to get a graphical information, financial information, and also do some peer comparison. Okay, it's not very okay. So like I said, one step forward to increase the complexity of the program. I think it requires more expertise over the programming language. So that's what I'm going to improve. Eventually, we have the result processing. Okay, result processing like the summary and output and so on. Yeah, you are going to see the results later. Then you can see here, display financial visualization, conversation history. Mainly the financial visualization. This part is the most difficult part. I have not yet resolved the issue. Okay, for conversation history, and also the chat of the summary, we are going to check later. Okay, so now I'm going to review one of the chat detail and also the result with you. For this one, actually, I ask the application to analyze 3 random SP500 report stock and to show me the analytical results. Okay, so basically this is what I get from the app, okay, from the web page. And I can see it's a very comprehensive report. You see the title is okay, unveiling financial landscape, 3 of the SP500 stock analyzed. Okay, so it says it picked Nvidia, Microsoft, or Disney. Okay, so because my prompt, if I remember correctly, is not very complicated and does not have many constraints. The main thing I would ask it to remember is that today is September 6, 2024. And please show the citations, show where you get the data, okay? So from the appearance of this report, you will say, okay, this model has, this chart has given me some very useful information. But if you look closely, I already examined some of the data. They are all wrong. This is a hallucination results, okay? And you see, especially in the citation part, is general citation. It's like the model makes it up. Okay, so if, for example, for serious matters like financial analysis, if you have the wrong data, basically it's useless. And let's see the chat result. So basically, the framework will start the chat and chat manager. The first assistant will start the work. Okay, this is my prompt. Okay, analyze 3 random chosen stock in SP500. I want the price, financial, market sentiment, show sources if you say anything, show dates of all data, use latest data available, today is which day. Okay, so my prompt is quite complicated. Of course, in my program, it cannot decipher this task. If you see my previous video, we have it's called agent chat. I remember is you have the free tier and the paid tier usage possibility for that tool. I have tried before. It actually has a very good framework to decipher your task, separate to smaller tasks. So it could be an improvement in the future. But let's see. So basically, the inner assistant starts to work. Okay. So inner assistant, based on this task you gave it, it actually starts to write code, execute code, and so on. Okay. But you see, whenever I see this program actually touch some API key, I know it's a dead end because large language model know some of the successful data retrieving method is to link to an API and get financial data. But this API, if never offered by me, okay, in any of the agent chat, it will not get the necessary information because it cannot just make up this API key. So whenever I see this API key, I know this chat will most likely give a failure results. Okay, so actually as it goes on, you can see, yeah, all the steps are described very comprehensively. You see, even the sentiment analysis, right? Okay, and let's run the code. Yeah, and also error fixing, okay, also mentioned. So by this step, it actually stopped. Okay, and there is a new chat directly to polish the content and make an engaging and nicely formatted blog post. Okay, so this part is actually directly citing the official documents of AutoGen of Nested Chat. So the assistant actually still acts as a report writer. Okay, so here it does not get any information, any true information that we needed. So it continues to do the job. Okay, so you can see this is actually useless because all the data are fake. Okay, so then the writer continues to say, okay, now we write this report, okay, until here, and we see a reviewer. They basically just continue to repeat the things again and again. So there is basically no improvements. And you see, there is also a reviewer to review the compliance. Okay, the compliance is a quite broad concept, because if you are going to say compliance, it depends on what you say. If you are saying the compliance to the exposure to the publication of financial report is one thing. Okay, especially the financial analysts, they need to follow a lot of compliance issues. So that is just one example, okay. But in general, the compliance issue, it actually said the regulatory, compliance and so on. It looks good, okay. And it also analyzes the compliance of different tools like the NLTK and the sentiment analysis and so on. Although it did not run that code, okay. But it shows the compliance review. So actually this chat continues to polish. I do not see any improvements. Okay, so it just go on, and eventually we get the summarized report similar to the previous chat. Okay, so I'm going to say this is not what I really want. So there are several issues at this moment. I'm quite certain. First of all, my prompt is not optimal for the agent's workflow to understand it. Second, the design of the chat or the roles of the agents should be further improved. So especially you see, like the critique, how does it identify this information is not actually get from the correct data source. Okay, once I know that you are making something up, can we stop the chat? I think I need to have some safety switch. Okay. And the models are very important, because when you change the model, like this one, I think I used the Llama 3.170B, if I remember correctly. But if you change the model, the results are so many. There will be so many variations. One example is that when you change to the tool calling version of the large language model, there will be only code. Okay, no description, no summary. Okay, these are just some of the examples I share with you. So let's go and check the other parts. Now let's go to the app interface. So basically the first one I would like to show you is that I manually input this prompt. Analyze NVIDIA, Microsoft, Adobe. Today is which date? Show past month's performance, market sentiment. Give me an analytical report. You can see in general, we just scroll very quick. You can see this is a very well structured report. But the problem is that the information is not accurate. So in my backend, it was not actually has not actually calculated well the information. Because I already checked, some of the information are very distant from the actual information. So even if it's a good looking report, it is wrong. Okay, and you see there are also some defects here, like financial visualization and the chat history. Okay, so I guess a conversation history would be better to save in a PDF or in other formats, and of course nobody will just check all the history except when they try to debug. Okay, financial visualization, I think there is a problem about showing that in Streamlit, because large language model device a code. If you run it in an environment, you get a picture. But how to bring that picture to this page? It is not so easy. If I write a code and run it directly in the page, I think I needed to improve my front end skill. It could be attainable, because I see some examples like in the Streamlit and the Gladio website. There are some interesting examples if you want to check. Okay, but so on. What I know is that this workflow. Okay, I have some very good layout of the app and the report, but for the accuracy of the data, how to really enforce the model to get actual data and stop if it cannot do it, I think a more robust flow control could be useful. Okay, now let's take a look at another example. This example is that I prompt the program to see when does Microsoft reach the price higher than $400, comment on the stock performance and make a pleasant joke. Okay, it actually checked the report actually shows that it checked the historical records, but as you see on the left hand side, I write the hard code to get from Y-Finance the data. And you see this March 19, this data is not matching with the report. It's quite interesting because you see the 2024 March 19, for example, you see there is no price matching 414. It's not very different, but it's not 100% matching. Okay, and we see the previous day the open price is 414.25. It's also not matching. So there are still some problem, either hallucination or inaccurate data, right? But as you can see, this report generally looks fine, and behind the scene factors contribute to Microsoft success. It actually, I think some of the information is from a very old news source. Okay, but in general, the layout is okay, and you can see there is also a compliance review report. Okay, and the problem is still the accuracy of the data. Okay, so in order to debug this, you need to check all the chat history and see if some of the definition of the roles of the agent workflow is okay. So let's see. This is another example. Pick 10 tech stock and analyze. It actually picks some of the stock and also shows some of the information here. Okay, like the revenue and so on. This one I think FB should be Meta, but it missed. It cannot figure out. Facebook now changes the name. I have not yet cross-checked all the data, but from a direct view, if you are familiarized with financial reports, there's no such rounding. No such rounding for all the numbers. So largely, I would assume that most of the data should be rechecked and they are not accurate. Okay, but in general, the layout is okay, and you can see there is also some citations mentioned. And here is another example. So basically, I have a definition of this app. Okay, as you can see in different example, I focus on financial analysis and stock analysis. But this one, I deviate from the predefined task. I ask it to generate some AI news. Yes, it can get some news. Okay, in August. Okay, and you can see there are different news and so on, but the sources is not very convincing. You see, there's no URL, right? And there is another example. I just ask it to analyze the Microsoft stock price. And you can see it actually goes back to January. Okay, let's see January 24th. Let's see if the data is reliable. Okay, 24. Yeah. July 24th, we don't have data. Let's see 25 like this. Yeah, sorry, January 20. We see the price. Okay, you see, it's completely wrong. Okay, I guess I would like to say if the large language, if my setting is wrong, I change my setting. If I actually build this Y-Finance tool as a tool and call it directly is a tool calling process, which I think would be much easier because at least we have the right starting point of all the correct data. Okay, but you see it actually analyze some of the metrics like alpha beta to analyze the different metrics. I think it looks okay in general. But if the data is wrong, everything is wrong. Let's see the last one. Okay, this one actually ask it to generate the AI news in Italy and show some resources. Okay, like where to get the information, the citation. Let's see this one. If it is okay. Okay, so you see it's empty. UniCredit is empty. Microsoft. Okay, there is no such page. So still, today I showed you that. For the nested chat, of course, you can get better results. As the official example said, if you want to write something, polish something, you have a critique, they will actually improve the whole process. By the critique, I mean, we can have a round table, ask it to join the chat, give some critique, give some comments, right? But if we have a nested structure, actually the whole workflow will look better, and you can focus sometimes to debug only a part of the nested chat. Okay, for example, one nested chat is about critique, we can focus on that. I think this is the main advantage. But to actually bring it to production, like I already did, I have many test and also many trials. The issue at this moment is that it's quite difficult to ask a large language model to directly involve in the development of the Streamlit app and give a very robust results. Okay, like I said, there are several steps we could improve. First of all, we can hard code some of the tools and to call the tool. Second of all, we can re-examine the whole workflow and check the workflow and improve it. The last one is that to incrementally debug or rebuild the tool. So like now as I have the code companion, every time I ask it to build something complicated, it's very difficult for it. Okay, so incrementally, one block at a time, maybe you will get better results. So today I just show you one of the project that I have worked on. I see some results, not perfect, but could be a very good starting point. I'm going to improve it. In the future, if I have some good news to get some better results, I'm going to share with you. Okay. Wish you happy coding with large language model and to explore more of the current AI trend. Right? If you have any question, any doubts, feel free to leave a comment. We can explore them together. Thank you. Have a nice time. Bye bye. Hello everyone, welcome back to my channel again. Today I'm going to show you one of the use cases utilizing Claude AI to complete a task. So before I go to the coding part, I'm going to share with you some of the preparation or the tools that I would like to share with you. First of all, I suggest you to have, if you have the OpenAI, ChatGPT, Claude AI assistant. Okay, it is quite useful because it is built, I think, by Claude AI, and you can cite different documentation, ask a question about detail of the design of your program directly here. Okay, it's quite useful. Then is official documentation. Actually, for this part, I use a repo from one of the creator in GitHub. I'm going to introduce to you later. But for the most official part, of course, everything should be already here in the Claude AI. Previously, I find it very difficult to understand the documentation because I always try to quick start with ChatGPT, put every documentation and so on, and create a zero-shot program for me to run. But after this time, I find that maybe my previous attempt to try the Claude AI was not so carefully examined, carefully organized, because there are many details that you need to understand before you go to the coding part. Otherwise, it will not work well. And I also checked some of the YouTubers. They showed you how to use Claude AI, right? Sometimes they use the command line or the other interface, not in the Colab, not in the notebook. So I previously I found it very difficult to start. Okay, but this time I find a very good starting point I'm going to share with you. But whenever you feel confused or you need to modify some of the components, it's better to read the documentation, right? And here is the documentation about the hierarchical process. I think the hierarchical process is what I'm going to use, and also used by the code that I cited. Okay, I actually cited the code created by one of the creator, and he had two versions. One is sequential process, the other is hierarchical. For the hierarchical, it is basically like the corporate structure, right? So I choose this version to as the first trial to test Claude AI. So just a quick summarization. How I quick start. First of all, I find a sample code in GitHub. Then I utilize ChatGPT Claude AI. Then I query the official documentation for any of my doubts and queries. Okay, so now let's take a look at the coding part. So I'm going to start with the first version, is the failed version. Okay, so before I go to the code, I'm going to share with you this part is about the license. So this time I actually take it very seriously. To first of all to copy the first original creator, Alex Fazio, his license here, and also mention what I actually changed in my file. And the last part is my own MIT license. Okay, I think it's a good practice to just to show who is the original creator. So basically, original creator just made the cookbook. You can of course go to his website to check. The cookbook is quite high level and it offers you all the options, right? But now I'm going to focus on Grok option. Okay, backend as of the large language model of Grok, and I'm going to modify a lot of things. Okay, so I'm going to go back to the coding part. Okay, this part is about first of all is about some warning settings. I think it's not mandatory. Okay, I'm just going to pass it. Installing the dependencies. Okay, so from here, I like the package called Pillow. It was not previously thought or included in the original dependencies, but whenever I run the below code, whenever I think some of the dependencies is necessary, I'm going to add it here. So it is not mandatory for you to run it. Okay, only when you have the debugging process and you see something is missing, you just go back to here and add your packages. This is just my way to do it. Of course, if you want a more clean version, you should integrate all the dependencies in just one code block. Then I get the API key. Okay, so the API key is previously already stored in Colab secret, so I can cite it directly. Of course, and also the different information, the different packages that I need to use. Okay. Then here I get the Grok API key, okay, and also yeah, this is just a ChatGPT suggestion to make some. It's called error handling strategy. So later I'm going to go to the most important part. First part is about defining the agents. This version, actually, I define the agents very simply. Okay, you can see like the stock data fetcher just retrieves the latest stock data from APIs like blah blah blah. This was created partially by ChatGPT, and also here is a very short backstory setting and also the goal. You have also other information that you want to set, for example, which model to use, maximum iteration, and so on. And the verbose if you want to see the chat records, right? So for every detailed explanation, you can check the official documentation. It's quite clear. So basically, I have a stock data fetcher, stock analysis, and an analyst, a stock news fetcher, and a stock report publisher. Okay, it seems good. Okay, but later you are going to see it's not working so well. Temperature and the models for each agent you can set it differently. Okay, so let's go to see the next part. It's about defining the task. Okay, the task. Okay, so at this moment, I just think I give each agent an independent task, okay, because their expertise is quite confined in that specific area, okay. So task 1 is for agent 1, task 2 is for agent 2. I think this is a standard way because each agent has definition, but you need to assign a task to it for it to work. Okay, so this kind of setting, of course, you can interact with other large language model to define it because a quick start, some inspirations could be very useful. The only important thing for you to notice is that the structure of the task. Okay, so which kind of information do you want to put inside? Does it work? You need to test to understand it. So later we're going to show you some of the chat record for you to understand. And you see there is also a context part. A context you can see, okay, it has a context of task 1 and task 2. So basically you actually give this task okay, a context. Okay, so just the previous chatting records and to let it understand the job better. Okay, let the agents understand the job better. So like the task 4, you have the context of task 1, task 2, task 3. Okay, so next part we're going to see the main part of the kickoff of the program. So basically, okay, we just input one of the ticker, okay, for it to analyze. So this part is to kickstart the Crew AI chat. It's quite similar to AutoGen, I would like to say, because you know the agents, you know the task. Okay, you have the verbose setting and you have the different process. For this part, you see, I only see hierarchical and also sequential settings. I'm not sure if there are any other types. Um, and also, I have not yet tested, for example, like in AutoGen, you have the round robin and also casual, different organization of the chat, right? How each agent interact with the others. In here, one part I see how the agents could interact with others. First of all, is by the hierarchical structure. Okay, so one one agent as manager. The manager will kick off the conversation table, and you can see for each individual agent you have there is a delegation. Okay, allow delegation true. Okay, so according to ChatGPT, okay, the Crew AI assistant, it said actually if you set true, it can better interact with others. Let's see if it's true. Okay, so the conversation is very long. I do not repeat to you for every detail part, okay? But you can see from the first view here are many errors, okay? I just asked ChatGPT to summarize it for me. So you can see the summarization, okay? So the workflow starts from inputting the ticker, okay? Then there is a delegation of the task to stock data fetcher, okay? But there are many errors. So one of the most common error is that it cannot find the agent. So there must be something about the naming of the agent. So I'm going to debug in the next version. So you can see multiple failed attempts to ask the analyst, of course. Final plan, okay. Despite to use hypothetical analyst plan, okay. Okay, it's good. Okay, so actually agents know some of the ways to analyze a stock. As you can see, let's see if we defined here. Okay, yeah, we defined here. Okay, it's not that did not make it up. So it actually follows the instruction that we gave before, but there is no meaningful results. I tell you, in the end, there's nothing. Okay. So also a stock report summary. We can see that yeah, due to tool malfunction. Okay, so what I noticed are two parts here for the first version. First part is that I needed to better define the agents. So when you call somebody, somebody will respond. Okay. The second part is that if the tool calling has malfunction, it means that there must be better with some tool settings. So these are the parts that I'm going to do later. So eventually, let's see the final result. The result, of course, it said required to inform you unable to complete the task. Okay, perfect. This is version 0. Now we are here on version 1. Okay, I'm just going to skip all the parts before. Okay, the settings, initial settings, dependencies, and so on. Yeah. So in this version, I actually tried the detailed tool setting. Okay, with the help of ChatGPT, of course. As you can see, I have the tool like a stock data tool, which can fetch different things. Okay, at the first time, I ask you to get the price data. Then I want the financial metrics. I want the other key data. Okay, like I think I remember correctly the PE ratio and so on. So actually, this class of the basic tool grows larger and larger. Okay, as you can see, the major financial indexes data it actually linked to balance sheet, cash flow, and stock splits, dividends, very detailed, right? So it's a big class, okay, with a big function inside to define. Okay, what kind of tool I need? I need a data fetching tool. The data fetching tool will fetch all these data. And we also have the analyst tool, right? And DuckDuckGo, I use it as a web search tool. So analyst tool is quite simple, right? Mainly focus on the moving average calculation. Okay, because from a technical trading point of view, it is quite important to understand moving average. For the DuckDuckGo part, I just wanted to check the news and to give me feedback. Okay, if the news is good or not. And we have also the publisher tool. It actually gives a very structured way, right? So you have the data, analytical results, and also the news part, and instantiate the tools to make sure they will work later. Then let's see the agent setting. The agent setting is not very different from the previous version, except like the role part. For the role part, now I do not say, your role is to blah blah blah. But after my test, I think the role is better to be seen as the agent name. So just to avoid any misunderstanding, I just put the name and the roles both as the name of the agent. One suggestion is that uppercase, lowercase, make sure they are the same. Okay, as you can see here, I have the first one totally lowercase, and the second one has initial as uppercase. Pay attention to this. Okay, sometimes when they talk with each other, they cannot find the correct one because it's case sensitive. It's quite interesting. Okay, you can try on the side. I'm not sure if it is an issue of the model, the understanding capability of the model, or the Crew AI infrastructure. Okay, you can try. Okay, as I said, all these agents, I also have the task. Okay, the task is not quite different from the previous one. Yeah. So another difference I want to mention is that now I add the coding agent. Okay, I want the coding agent to actually perform the coding part. Okay, so the main difference, let me summarize again. So basically, now I have the name and the roles both focus on the agent's name. Okay, both of them are agent's name. Then about the fifth agent, the reason I want a Python data coding agent is that sometimes the without control, the agents can hallucinate and provide me with data from 2023. I want 2024. Okay, so I want the coding part to be more precise, and I have these toolbox. Okay, this toolbox is not mandatory. Okay, so as you can see here, in the current version you see, I already deleted there is a tool option. Okay, it is very easy. You just add the tool option in the agent. Then agent will call that tool directly. The reason in this version I actually deleted it, I created this coding agent, is that if you want the crews to call the tools directly, sometimes it will go into a loop. It's like whenever the tool cannot give you the result, it will query the tool several times. So eventually I say, okay, so maybe my toolbox is not set very well, right? So let's try a free coding version. Okay, I just have an agent to code freely. Maybe it will work. That was my original idea. The other thing is that during the conversation of the different agents, you are going to see if you change some of the information, like if you make the task more complicated or the agent description more complicated, the total runtime will change drastically. For this version, I'm going to show you, okay, in later parts. So the task part is as this one, okay. So as you can see, there is an additional task about the coding part. Okay, so in the main block, actually here I have additional part to set the agent iteration limit. Okay, and RPM limit. RPM is like also the iteration limit. Okay, you are going to see. If you want to know the details, you can check the documentation. And okay, let's start. So basically, you can see this is chat record. Okay, there are many information to get, but unfortunately, I also get the 2023 data, which is not what I wanted. Okay, but in general, it did a lot of query and a lot of calculations. Let's see. In general, this workflow. Okay, first of all, fetch the stock data. Okay, Success. Analyze data, no problem. Key calculation is about moving average and RSI. Okay. Final insights. Okay, I asked ChatGPT to summarize a very long chat record. Okay. Price below, both moving average indicate weakening, short-term bullish trend. Okay. And the RSI suggests a potential buying opportunity. Market cap 2.42 trillion. Okay, it seems that the information is correct. Okay. No, sorry. I mean, you have some of the information analyzed by the crew. But if you go inside, as I said, whenever you see the volume or the data, okay, it actually shows the data that you don't want. Okay, you don't want to know the data 1 year ago. You can see the trend, but for the latest information, I want to know this month or 2 months ago. So the problem is that maybe I did not specify well here. So I'm going to improve in the next version. Okay, so in this version, actually, after refining the agent's name, it works well. Okay. Eventually, I abandoned the way to fix the tool. Ask the crew to freely coding the code. It seems to work well. Of course, if you assign each tool to each agent, you can try a different version of the code. Okay, so the agents will call the tool directly. Okay, and give you the results. Let's see the runtime. The runtime is around 5 minutes. Not bad. Okay. Another important difference between Crew AI and AutoGen, I think AutoGen for the similar task, it actually performs faster with the interaction with Grok API. But if the model is not so good in AutoGen, you will not get a result. But in Crew AI, it seems that the full flow control is better. Okay, it actually gets whatever the hallucination is, or if the model is good or not good. As you see, I also used Mistral and other models. It's not so bad. Okay, at this point. Eventually, you have the summarized report. Okay, for this simplified version. It actually said the date is 2023, February 3rd. Not useful, but this result is not so bad. Okay, so let's see the improved version. Improved version, okay, I'm not going to show you everything. Okay, so let's go directly to the coding part. To the parts of the change that I made. Okay, so let's see. For the agent setting, you see tool calling, I'm not changing it, I'm not using it. Okay, for the agent setting, you see now I have a backstory which is longer. I asked GPT to make it more robust. Okay, so you give more backstories like job description. Okay, and of course you have the goal like the previous version, of course. Then let's see the task. For the task is much more detailed. So we have the description of the task. We have for example, like this one. Your task is to get the price data for the ticker for the past range period. Okay, from which date? Okay, so I want to be precise. The reason for this is that if I do not precisely tell the agents to look backward, sometimes it could look forward. Example is that if I say, okay, now today is which day? I want to see the performance of the stock, okay, over the past several months. Okay, if I don't say past several months, it might look forward. So the more precise you have in the description, the more contained your response will be. So this is just one of the suggestion, is to make sure the task is specific. The more specific it is, we might get better results. We're going to see later. Okay, so I ask open price, closing price, highest price, and so on. Okay, very detailed. Okay, but one of the problem you are going to see later, I have not yet resolved, is that, for example, here, I really would like the agent 1, okay, when it solves task 1, it will delegate the task directly to the coding agent. However, if you see the actual conversation, if it starts to hallucinate or take some of the information already embedded, I say embedded in the large language model, it will give you some historical data it was trained on. Okay, the model was trained on, and will not call the tool. And eventually, when the crew manager actually calls for the coding agent, it will go to a very interesting loop. So let's continue to finish this part. Okay, task 1, task 2, task 3. You see it's very detailed. Okay, so for the setting, for example, if you have this task, you can, of course, if you're already working in this field, just add the information that you think is very necessary. If you are not working in the field, just check some of the reliable sources to see how the task is constructed, okay? So you will get better results. So let's see. Okay, so here, like the coding agent has also a more robust description here. I do the calculation and see the data anomaly. Okay, it's very burdensome. Okay, it's not an easy task. So dependency, like I said before, if I meet some problem running the code, I will come back to install some of the dependencies. Okay, so in the main part, there is a calculation of the start date. Okay, it looks good. Actually, it will better confine my prompt. Okay, to let the team knows that what I want. And you can see after choosing different variables and to take the user input. For here, I just don't. The first time I run this code, it took me 1.5 hours, and I did not see a result. So I set a limit for the maximum iteration and RPM to 2. And here we can see I put all the inputs, okay, the different inputs here, and the prompt, okay, inputs are going to be fed into the team, and you are going to see, okay, now we're starting the analysis of the stock, blah blah blah. Okay, so here we can actually define, okay, what the user actually input. Okay, these variables are going to be used. Okay, so let's first see here. So please enter the ticker. Okay, additional words, I want a comprehensive report. Okay, enter the date. Today is the date, and the information range of my month. Okay, so it starts working. Okay, it will start working, and as immediately you see here, it actually go back to 2022. This is not what I want, but eventually it goes on talking a lot of things. You see, there is a very interesting loop. You see, whenever it gets some of the information, it will evaluate, not okay, will go back, and so on. So just to save your time, let's go to the summarization. The response is about 5,000 lines. So I summarize it into 3 parts. Okay, I take them to 3 parts to summarize. Because ChatGPT cannot intake such amount of text. So let's see the first part. User input, data verification. Okay, verify the accuracy of the data and so on. Yeah, it's good. Retrieval and formatting. Okay, it works. Okay, especially with the Python data analyst. Let's see of the stock movement. Okay, so yeah, looks alright. Okay, looks better than the previous 2 versions. Okay, let's just not think about the runtime for a moment. Okay, so in general, the quality has improved, but also the complexity you can see also increased. Okay, so the other part is about okay, so actually in the second part, the agent starts to realize, okay, now we are talking about 2024, September 8th. Okay, so and also there are some key events identified in the news, and I think at this moment when it talks to the agents, not the first agent, okay, not the data fetcher, but the data analyst and so on. There are some additional tasks assigned to different agents. This is not a coding agent. Let's see our coding agent. Okay, our coding agent. Yeah, sorry. Our coding agent is Python data analyst. Okay, name is okay. Yeah, so go back and specify the package to use Y-Finance to get the data. Okay, looks good. Then historical average data. Okay, perfect. Summarize the report. So just during the process, you see there are some repetition. it's not that we finish one task and move on. It will go back, okay, one way or another. So the third part, we're going to see there is a goal, the stock data, news summary, and so on. But you see here, the agents are going to utilize the API for Alpha Vantage. We don't have that, okay. So this is something that we would like to avoid in the future test, because if it goes out of the range, it may cause problem. Because some of the APIs you cannot just ask agents to imagine, okay, create one API for you. You need to create it by yourself. And for me personally, at the test stage, I prefer everything free, like Wi-Finance package and so on. Yeah. So basically, the news summary and the stock matrix, everything looks fine. Okay. Yeah. So let's see the final result. Okay. The final result looks not so bad. First of all, it shows stock price data. We can see that this is stock price and stock analysis. Okay, looks quite good. And also there are some notable movements following for the following news. Okay, looks fine. News summary for the from August to September. Yeah, you can see this is a sentiment analysis. Okay, in the future, if I get a chance, we're going to explore the sentiment analysis together. Okay, at this part, okay, it does the crew team does the job to analyze all the sentiment. Let's see if it is correct. Let's see this one. Lawsuits. Okay, negative. Yes. Apple Card Plus positive. Okay, if you're interested, you can check validate all the news here. Of course, if you ask Crew AI to add the source of the data, I think it's possible. Okay, just need to carefully design. About our coding agents, okay, Python analyst, because he also provides some of the outputs. So in the final summary, it actually summarizes all the information from different agents. It's like one agent for one part. Okay, it's orchestrated well. So in the future instance, I would like to avoid showing the code in the final report, right? So I would like to say, I just want to see the main part, and eventually give me a buy or sell recommendation, and look forward for some future periods. I also checked if Crew AI can generate a graph. It is a very difficult task, as I find in AutoGen. In their official documentation, I can see that the agent creates a PNG file, a picture file of the stock or something statistic. But here in Crew AI, okay, at the first check, it could do the similar things. Can they show it also in the final output report? I'm not sure. So in the future, we are going to explore them together. So just a quick summary of this journey. So Crew AI is a good tool. I would recommend you to check the official documentation and also check in GitHub like the base the cookbook that I checked for Crew AI. You can get some inspiration to build your own app. And for each of the detail setting, you need to try. Okay. Like I said before, some of the parameter you can let loose, okay, give some flexibility, but you will have longer conversation. Or you just give it a very specific tool, like to the agent, but be careful if during the conversation it cannot meet the demand of the agent, it could create a problem. Not necessarily saving time, okay? So there are some balance you can try out. Okay, just do more tests. My suggestion is eventually, as you can see, I have 3 steps. Okay, I have the simplest version. I see some results. Okay, the workflow is working. Then I improve and improve again. Eventually, as you can see, the last version of course it looks very well. Okay, compared to the previous versions. But the key problem here is that the runtime. Let me see if I already marked it here. Yeah, the runtime is around 1 hour. So you need to see if this it can meet your demands. Can you wait 1 hour for the report? Okay, and if you have a budget for the API, for example, we are using Grok freely now, but if you are using ChatGPT, you use OpenAI API. What is your cost budget? You cannot always let it go freestyle, right? It generates a lot of nonsense information, and you pay the cost for the tokens. Okay, so yeah, that's all I wanted to say. Utilize the tools to quick start agent flow. During the iteration from simple to complicated version, do it step by step, do some test, and some thresholds, some parameters always change, and to see the results. For the description of the agent, description of the tools, organization of the chat, always check the final results and see how you can better design the app. Okay. If you have any question, any doubt, feel free to let me know. We can explore future possibilities with AI, with agentic workflow together. Thank you. Have a nice day. Bye bye. Hello everyone, welcome back to my channel again. Now I'm going to share with you how to deploy the Llama 1.5 model through Grok and in local environment utilizing the Open Web UI. If you already saw my previous video, you should already know how to set up the Open Web UI in local environment and open it. After logging, you can see the normal interface of the chat. Of course, if you already tried Llama, for example, for my case, I already had some of the model like the Mistral model to run it directly. Now, in order to add additional models, like from the Grok website, you go to the admin panel, setting, connection. You just input this URL. Okay, it is from the official document of Grok. You can also see this one in the Grok website. Until this URL, api.grok.com/openai/v1. Okay, until this part. Then you should copy paste your API key here. Okay, and then you try this one, verify connection. Once you see the verified sign here, you should save. Okay, and it will say save successfully. So after this setting, you refresh the interface. Now you go to the new chat. You should see all the models available in Grok. Okay, so basically, if you already have some models through Llama, like what I had, you should see those models are still here. Then you see additional models of the Grok hosted model. Okay, so basically you can see here, if you see this link external, which means it's an external model. Okay, so let's see some example of utilizing the Llama v1.5. Okay, so originally I thought this model should give bi-directional capability, which means that it can generate a picture and decipher the picture. However, it's not the case. For example, I ask the question to draw the AAPL price trend. It gets some of the data it was trained on, but there was no picture generated. Then I asked it to draw something. Okay, I wanted to say draw start, so it actually gave me this one. But if you ask it to draw something else, for example, you want a picture, it cannot do that. So the next one is explain the picture. This is a Google Map screenshot I did before. It explains the general structure of this picture. Okay, so it's a street map. There are some elements inside. Okay, and it also explains some of the details, like the track where some of the roads occupy a large portion and so on. So it's a general description. Okay, and this is another Google Map screenshot. As you can see, the description is almost the same. Okay, it gives some high-level generalization of the information inside. Now we try another picture. This is a picture of the let's see, the total health benefit cost of the employee, workers' earning, overall inflation. Okay, the relationship of this chart. And you see, it only says that this showed some of the information like average annual salary, cost associated with it, and so on. But it cannot get more info. Another issue about utilizing this model in the open web UI is that whenever you try to follow up a question, for example, I say here, I say more detail, okay. Usually you will get this error, bad request. So basically, whenever you want to query a picture, you need to start a new chat. Okay. I'm not sure if this is my local setting problem or not. You can try it out. Let's see another one. So this is International Monetary Fund, some of the statistics about the growth projection of the different economy. And you see, it actually gets the information, okay, growth projection, which year, okay, and it says, okay, there is a wide range of outlook projections, and says what is used for, okay. It helps the viewer to better understand. So still general summarization. Then I ask it to explain this picture from Fight Club, a very famous movie. However, it got stuck. Or if you try again, it will say that this picture is oversized. So there is also a limitation about the size of the picture. So I suppose there is is like the context window for language model, right? So multimodality model, it has also some of the limitations. This one is actually about the loss function. I just randomly picked some of the pictures on the internet, and this is a general depiction of the loss function of the neural network. It actually says something else. It says flowchart explain how data is processed in real time, but there is no such information there. Okay. However, if I think this model actually pick up some of the traits, like there is an arrow. So arrow means trend. Arrow may be emotion. So it actually connects this idea with real time. Okay, so it says this is a real time processing of the data, but however, the essence of this picture is a neural network. Okay, so this it deviates a little bit from the reality. Let's see another one. Now, this one is actually a hypothetical organizational chart, which you can see the hierarchical structure of the organization. Yeah, the model can identify this is a business hierarchy. Okay, shows names and emails. Okay, seems okay. And also it shows the names, which means it has some capability to extract information. But that's it. It just gives some example, but not all, right? Not like a complete list. So I did another experiment. I asked it to actually generate all the text, okay, to extract all the text information. So it has still replied to me the traits of this picture, but it's not like OCR. It cannot just get all the text information and give response to me. So I would like to say that this model is has some limited capability, but if you want to experiment with it, okay, utilizing this open web UI, or you write your code in Python, you can always try it. Okay, I wish this tutorial is useful for you. If you like the video of this kind, or if you have any question, feel free to leave a comment. If you like my videos, please subscribe. Thank you very much. Bye bye. Today I'm going to analyze the presidential debate between Harris and Trump, and I have got the ABC partial transcript of the presidential debate, and I also gathered the data from a secondary source just for local analysis. And for the ABC partial transcript, I mainly use GPT-4o model. So let's see what result I get. So basically, if I keep asking ChatGPT 4o model about the presidential debate claims made by each candidate, and it will give me this statistic. It actually categorizes the claims to be accurate, misleading claim, and also exaggerated. So After running the analysis of the transcript, it actually keeps on going beyond the scope of the transcript. So eventually it made around 124 claims extracted from the speech of each candidate. And you can see on the left-hand side, Trump and Trump has more claims than Harris. And you can see largely of the Trump claims are exaggerated and false is 25.8%, and the accurate claims only 12%. And there are also 24% of the misleading claims. However, on Harris' side, the accurate percentage is much higher, although in general the total claims is inferior, less than Trump's side. Okay, so on the right-hand side, actually subjectively imposed a 20% error margin. Okay, to see if the model makes some 20% mistake, how would they range? So basically, with partially checking the actual transcript and partially hallucination, you can see that this model can give us this statistic. Okay, then I tried to limit the hallucination. So first of all, I asked another model, Copilot, to actually analyze how many paragraphs in this transcript in ABC website, and then tell the GPT model, okay, there are these many paragraphs. Okay, can you analyze the paragraph one by one? So in this way, I actually give it a limit. However, there may be still some hallucination. It actually has I would say the error margin is around 2 paragraphs. Okay, not many. Okay, but it is still we cannot avoid hallucination still. So we need to guide this model every step forward. However, in this version, we can see the Trump claims are still higher, okay, in percentage view, higher than the Harris claims. And the inaccurate claims made by Trump is still large, okay, 37% of the total claims of both sides. And you can see 27.2% of the accurate claims in the total claims. And the Harris side has accurate claims higher than the Trump side. Okay. And on the right hand side, you can also see the bar chart of the claim counts and also 20% error margin. Okay, so basically, we cannot give a conclusion about whether the analysis is accurate or not. First of all, if it is accurate or not accurate, we need to verify from different sources. As I read one of the posts by one of the professor in university, he actually said now some of the sources like the websites or internet content keeps disappearing. So whenever we do a fact check, now the difficulty has increased. Okay, so basically, if you are going backwards to check some of the facts which are recorded by internet, the difficulty will increase as the time progress forward. The other thing is about the model. Okay, so the first point is that we assume that the model can get all the internet content. Okay, but the internet content could disappear, so it is very difficult for the model to verify the claim. Also difficult for us. The second point is about the training set of the model. If the training set of the model was largely favorable to like Harris side, so the eventual results will pivot to her side. Okay, but I do not know how many training data are used to train the political side of arguments, so we don't know. Okay, the last one is that natural language processing and large language model analysis are totally different things. Just like you see in the next page. Okay, so if I try to do the local analysis on the transcript, but it is very computational heavy. Okay, I needed to use multiple models. So the fastest one to count the word and also to give a word cloud, this is the most direct thing I can do. But if I really want to do the natural language processing, it will involve much more efforts. Although I have not done it yet, if you are interested, I encourage you to do also your own analysis. But it is not so easy. So this is a partial analysis made by my side. I wish it could give you some useful information. And if you want to dig deeper in the language processing, please try different tools. Now we're going back to the ChatGPT phase and see how the chat goes. So basically, as you can see, this is the first attempt I tried to analyze the transcript. I actually save it to a PDF format and start to analyze, right? So at first, the model actually just displayed okay, first of all, he asked me to identify which is the first paragraph I want to start with. I just provide. So it actually goes on to check the fact, but it did not do the function call, like to cross-check with internet content or so on. So basically, the whole chat is based on the training datasets of the GPT. So it keeps on going to check each of the claim, but it does do a good job to separate one paragraph or one piece of speech to multiple claims, so you can view it clearly. And at some point, I ask the model to actually start counting the claim types. So from this point forward, the statistic will start building. And as you can see, at first, some of the paragraphs are well analyzed and all based on the true transcript until I think around here, right? Until here, actually the model starts to hallucinate. This is not the actual text because I just search the partial wording. It's not present in the transcript. So the model starts to hallucinate. Okay. So let's keep on going. And eventually we get the statistics and we can ask GPT to analyze, okay, display the data analytical results, okay, as I just showed you before. Okay, this is version number 1. You can see that the model hallucinated a lot and we get this results. Then let's see another version. In this version, I actually guided the model to make sure that the response is more accurate or at least statistically more robust, I would say. So this time I also simplified the count to accurate and inaccurate. Okay. Because I want to say I don't want to analyze an emotion, like exaggerate or not. I want to say, okay, is this fact or not fact? Okay, it starts to analyze, and this time I only ask it to show the first sentence, so I can quick check if this paragraph exists or not. And it does the job. Okay, just to save time, I ask it to do 10 paragraphs for each time. And eventually, I think about here, the paragraph, if I remember correctly, is around 48 or 46. So it actually go beyond that. So even if in the beginning your prompt actually guide the model through to make more accurate results, you still need to guide until the end. And with a small margin of hallucination, we get the below results. Okay, so this is just a quick analysis of the Trump-Harris transcript. I wish it is useful for you and wish this could also be a good start for you or for me to analyze the similar language contents in the future. If you have any question, if you want to discuss anything, feel free to let me know and have a nice day. Bye bye. Hello everyone, welcome back to my channel again. Today I'm going to show you a quick project about the sentiment analysis of iPhone news. So basically this project will involve one of the algorithm and also the repo of text blob in GitHub. This is a tool that ChatGPT actually recommended for the sentiment analysis, and we are going to go through the code step by step. Basically, I went through 4 iterations of the code, as you can see on the right hand side. Okay, so basically we first got this version of the code. So we have the function to get the iPhone news, then another function to analyze sentiment. The important thing is to actually categorize the sentiment score, so you can know it's positive, negative, or neutral. And so this is a function to perform the sentiment analysis and news results. Okay, so this one is focusing on utilizing text blob. This one is to conduct the result analysis. And we also need to plot the results because I want to see it visually to get a better understanding of the sentiment analysis results. Let's see. The first result actually was like this. Okay, so basically I have everything is neutral. So the intuition tells me that it is most likely the problem of the data set. So basically I get the news from the, let's see here, from this function. I utilize the search query here. Okay, and I use the package Google search. Okay, so basically the search results, if it only returns the title or the URL, the analysis will not give any meaningful results. So the next iteration is to describe this issue. Okay, I did not even go to the details of reviewing this code, but at this step, I think the first thing is to actually see some distribution, okay, of the sentiments. That will be more useful. So I keep on iterate the code and see the second version. Okay, in the second version, actually there are some improvements. So basically the function changed from the get news to get full article. So for each URL to pass the HTML and to get through the beautiful SOAP to get the information, okay, and to separate into paragraphs. Yeah, so extract the text from paragraphs. In this way, we are sure that we are going to analyze the main contents. But remember, my code is only the first step. So in a more rigorous way, we should actually handle the text message more carefully. Especially we need to do a lot of pre-processing, like what I did some time ago, another project. When I analyze the job description, I need to eliminate all the punctuations or the different characters, special characters, and so on. But here I did not. Okay, I just do the easy way to build this framework. And the other parts mostly do not change. So let's see the results. Okay, this distribution is more sensible, I would say. We can see here there are mostly positive news, then small amount of negative news, and also some neutral news. Okay, so I think analyzing the news about a specific product could be useful to understand the views, the news views to the specific product, because sometimes it's quite difficult to do a market survey. Although different ways to do this, to collect the statistical data could be biased in some way. But I would suggest to use more ways to analyze the sentiment about a specific product. So we can see that for each product, yeah, the sentiment analysis result is shown as below. Okay, also we can see how many positive, how many negative, how many neutral. But still, for this kind of graphical presentation, I cannot understand the involvement. So it's better that in a later stage, I'm going to see a pie chart or the other charts. Okay, so in the fourth version, I'm going to present also the pie chart. Okay, and here I also notice a problem because for each product, after the search, I get a different news count. So basically, I think the package search results can vary based on the topic I search. So this could potentially bring some bias. Okay, so basically the source of my sample data is not at equal quantity, and also I need to further investigate how the news were searched. Okay, if I want to be more rigorous. But as the initial results, I think this can give me some indication. Okay, about the sentiment on the news side to this product. Okay, so yeah, also for each version, I also posted the GPT comment about the version of the code. So you can see there are many ways to improve. So I just leave it here. Do not go to more details. Okay, let's just go to version 3. Okay, in version 3, actually, I asked GPT to double check about why the article numbers are different. So there is not a direct answer. But I rearrange the graphical representation about the sentiment, so I can have a approximation of the full picture. Okay, but as you can see here, I can only say like iPhone 14, we have 70 positive news, which is higher than the iPhone 15. But since the sample size of each research are not the same, we cannot compare in this way. Okay, so here we have the fourth version. Okay, the fourth version. Let's see the code. Yeah, so basically in this version, I also added some of the requirements. So basically, I want to see the original website. Okay, so basically, I want to double check. I can see the URL. Okay, this is okay. I get the URL. The information is able to be double checked, and I also want to categorize the channel. For example, if the news channel is from like CNN, like other news source, and so on, or it is from the other source. Okay. But eventually, most of sources are other sources. As you can see, we have one New York Times, which is specified the channel as mainstream New York Times. But for the others, most of them are others. Okay. So it does not make much sense to actually visualize because most of them are other source. So I guess the result is quite scattered in the internet. The randomness seems okay. All right. Yeah, and for each news, we can still see the polarity score. Okay, and let's see. Here, this function will make sure that we have the 3-column results of the graph in the end for us to visualize. And here we can see the classification function of the different channel of the news. Okay, so these are the two, and also here. Okay, known channels. Okay, I gave some of the examples. So this function actually helped me to understand which channel it is. Okay, so both of these functions, get channel and then classify, work very well. But I did not put the visualization part on this statistic classification results. Okay, so basically, let's see the results. It looks okay. And also I expanded the search from the iPhone X, iPhone 10 to iPhone 15. Yeah. Now let's take a look at the final version. Okay, the final version is still running because I think the job is quite intensive. Okay. But in general, this code does not change much in the general structure. Okay. But eventually we have a different way to display the data. Okay, so we can see here that we have the percentage of the positive, negative, and neutral news. So since each sample size may have small deviation, we cannot give conclusion that okay, the sentiment trend is more negative or more positive, but it could still give you some approximation. Okay, let's see here, like iPhone 15. We can see the negative news actually has a very small percentage. We can see that there is an improvement from iPhone 14. Also, you can see the neutral part, but the neutral part has increased a lot, around 7%. So in general, the positive comments and positive news has decreased about 6%. And let's take a look at the iPhone 13. We have 90% of the positive news. So is the market taking the new iPhone release a little bit tired? Okay, they are tired of the small improvements and the high price. It could be a possible explanation. But here I just showed you a quick view of analyzing the sentiments of news on a specific product. You can actually implement this to different products, but remember, always pay attention to how you gather the data, how you pre-clean, how you pre-process the data, and how you cross-reference, okay, cross-check the validity of the data, and eventually how you display this data, okay. About the natural language processing, I mean, the current methodology I used is just a start. Of course, we can use different natural language processing models. In the future, I wish when I dig deeper to that, I'm going to share with you what I find. Okay, so feel free to use this code. If you have any question, leave a comment. If you like my channel, please subscribe, and see you next time. Bye bye. Hello, everyone. Welcome back to my channel. Now I'm going to share with you another small project. It's called weather forecasting. So I should not have started this project because actually when I saw the Wikipedia page about the weather forecasting, it is a very complicated subject and was including lots of algorithms, a lot of history and algorithms, and different government institutions are actually conducting the weather forecasting on a daily basis. Okay, so I just simplify the weather forecast to show you how to implement three models. Of course, again, I interact with large language model to refine my code to make them robust. Okay, so at the beginning, I have a small description of the three models. I have ARIMA model, VAR model, and the long short-term memory models. So basically, the long short-term memory model is more prone to the deep learning, machine learning parts. It's more complicated, right? For the VAR model, is like you have not a univariate. You have multiple variables simultaneously to influence a result. Okay, so it's preferable when you want to model the time series where multiple variables are moving together. A Riemann model is univariate, means that there is only one variable you are concerned with. Okay, so let's see how these models perform. Again, if you want to dive deeper to the theory background, I really recommend you to look at the Wikipedia, like official books, okay, to get more robust descriptions. Below, let's go to see the code. Okay, so basically, I have the first version of ARIMA model. So, okay, I use the package. The most important package is Meteostat. Okay, this package actually can get the weather information. Okay, basic weather information for me to do the analysis. Okay. I'm going to focus on several variables you are going to see later. So basically, first of all, I need to get the weather. So I have this function. I choose New York as the analysis start. I just choose this location. And I have a time period from 2020. Okay. And also I get the data and also print the data head. So basically, I'm going to have the temperature average, blah, 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 1, 2, 3, 4, 4 variables, okay, as you can see here. Then I pre-process, okay, pre-process the data. So it's there is one of the experience that I want to share with you for any numerical data. It is better to standardize. Actually, to make sure they are on the same range, it will be better for you to analyze. So if, for example, if you have one variable is 1 to 1,000, another variable is 1 to 2, the range actually will impact the analytical result very significantly. So this min max scalar, okay, this kind of transformation is useful. Okay, you have many other transformation methods you can try. Then I use 80% of the data as training, 20% as testing. And also we can also print the shape of the train and test data. And now we're in the modeling part. Okay, so basically the most important part is first of all, we need to understand how to evaluate the model. Okay, previously you already understand how the model works, but how good is the model, I think, is the most important part. So I just chose two of the metrics to evaluate the model. Of course, you can also add other metrics in your case. Then we do the forecasting utilizing this model. Okay, so basically at first, the features, or I say the parameters of the ARIMA, or P, D, Q, three parameters are preset. Okay, just for simplicity. Then we do the prediction and transform the prediction to original scale. Okay, I think this part is out of my expectation. So ChatGPT really did a good job to mention this part, because we need to see the original format of the data. It's better for us to understand. And you see this is a model result. Okay. Yeah. So after running this code, I see no visual. Okay, I cannot do variations. And here I try to fine tune this model. Okay, so basically for the different variation of the model, I want to see the results, and add this widget so I can choose a different parameter and train the model. It is strongly suggested, because recent days I find the Colab widget documentation is super useful. It will make your interface very interactive. You can try the different parameters, not only here. In the future, I'm going to tell you how to use it in the artificial neural network. Okay, when you try this, each time you are like doing experiment, it will give you better sense. Okay, so like in this case, I change one parameter, it will give me one result, right? So in your network, when I change the layers of the neural network,